their name. Rather than an ask them, did they accept the Duma? Yeah, sometimes it's in the bank mail. Hey, why didn't this in the confirmation? I said, check your bank mail. Spam box.
零色的现在都出现项目是用全息技术提供下一代各种我们是app， 比如说 AI 角色的养成，更强的情绪价值就在你面前，所以我觉得多么太下一步可能会想传达一个高情绪价值。
你这个全息是怎么做呢？
就是用光学器件，然后把像素导引到空间当中不同的光度，然后我们提前已经判断了眼睛在不同的位置上应该看到的景象，所以它的 consistency 是。
那你这个做全息技术在一套，也很好的。
其实它是就是那个，但是它的像素并没有特别高，高频率高频率在那里。然后这样它在就是分散到空间当中，稀释之后，它仍然保持一定的视角的力度，所以它的效果很高。不过我们平台并不是一定要跟这个竞争，我们要去做那个，就是下，然后 Sony 他们也在做。
So our MC is running to front desk to pick up people.
一些现成的那个消费的那个。
那就是说，那这种就是要有 3D 的。
对，比如说最简单的这个3D 项目，你可以当成比如再增进一步的话，可能是 AI 陪伴的价值。比如我们可以帮问题把他的形象放进去，让他的粉丝们可以订阅，可以跟他去长期陪伴。这个市场是非常反馈非常好的。因为缺乏一个界面，人们已经很久不想换这个就是收费服务了。对，我们好像都想不起来。我觉得一直需要一个新的推的，然后对 fundamental 的东西去提高它的。而且这个 Vision Pro XR 是不同的，因为我希望做的是没有物理束缚，然后是可以长期在哪里，它是 on demand。我觉得这是可能是一种选择。
那你对那个像 Vision Pro 啊，它的特点。
Hey everyone online, we are waiting for our MC Wilson, and he ran to pick up some people.
Space。那您这里边呢，用户只能在那看，给他抽。
就 hand gesture, body gesture, skeleton，我也会做一套，就是 input instruction set。觉得，但是现在我们没有做到
做的 audience 是 inside 整个的时间，是 outside， 只是像看电视一样看。
它会有一点泡泡，会有一点触屏的效果，但是你很难走进去，大部分是在里面。它做不到，就是我觉得 immersiveness 你不见得要在里面。如果说空间的感知，你提供了一个 spatial occlusion， 还有遮挡关系，你会觉得它在哪？觉得也是一种选择。
因为你能解决的实际所有这些问题，在我看来 ，Vision Pro 的感觉比较 stupid， 太憨了。但是它真正的意义在于，它真正第一次解决了 space computing。那么 meaning 就在一个 confined 的一个 space。实际这是一个这个 space 任何一点都是computable。也就是说，我们原来的所有的 user interface 是 2D， 放在它上做 3D， 而且呢，甚至我可以在中间，只要是个 confined space 是可以做的，跟 predefined space 是可以做到的。理论上，
我们就是没有从技术的 roadmap 里边这个贝斯拉应该到没有特别从这上面。
主要是从内容上。
对，因为我觉得，我们能把东西卖掉，消费者其实是 体现出了需求。我觉得顺着程度是有可能的。然后我们现在做的大部分是输出，就是没有那么多的交互，大部分是输出。首先，
我倒觉得这东西要真用在什么？我做第四个单，那个 system 比较熟悉，像 Zoom 像是这些系统，如果他们现在说的做 Zoom 做这个好多要求 space 还得戴个眼镜什么的，但是如果真有创造这个场景，如果是
做的很真实。
我的意思是说，我在参加会议，那这个时候的会议已经不是说我要通过屏幕带着一个人去看，那我的同事都在这儿，那我觉得这个场景就很有意义。那这个场景就是
康考是个刚需，我们也是往上，就将来这是其中
一
一个，
就好像咱们设计一个虚拟人物，大家都在这里。
对。
那就不是仅仅是戴一个眼镜，那样能弄那就更没意思。没事，咱们回头再那个，但我觉得这个挺有意思。而且用现在的可能optical 的一些设备，我至少没想到。
现在业界还没有做出要求的那个规格，但并不是他们做不到，是没有人提出产品定义。我觉得好像有蛮近然后也有些 to B，比如雅科类似的项目，它做牙齿3D 造型之后的检查，以及跟患者之间的沟通，看得很高大上，进一步提高专业感。
那他那边做都是要求。
对它，其实它还是看一个空间概念，它并没有说精度要达到微米，它其实是要达到10米，像牙和牙之间是舒适的。它但是在用的时候不用这样，它主要是用户体验，并不是太好。它是一个双线权，一方面是内容的规模形式，一方面是硬件的实现，双线权。将来它没有会师，不过始终要让内容要
内容是3D，都是3D，都是吧？
也会有真人实景。
就是 in the front， 就相当于是一个billboard， 这种是2D， 但是我觉得这种东西大概3D 的一个 express。
我看用户是已经有一个视频了，回头给交流。没事，咱回头加微信视频。直接过来。
So you want to rearrange?
方面做
Every second week. Oh, that's right.
但如果你
Screen time. I came yesterday.
You mean here yesterday?
I'm not sure.
For the picking up things.
Because another people
Yeah, we do. They complain. During lunchtime. I know. Sometimes you. I know.
Yeah, same.
Is this Wi-Fi still
anyone need
good?
Wi-Fi, just let me know. The
I
Wi-Fi
think it's
password.
Wi-Fi from yesterday.
Oh, it's
Hey, Tom, can you get a new Wi-Fi?
That's a new one.
This is a new one?
Yeah, that's a new one.
Awesome. This is a new one.
这样
你要不要一起做？我们有一个小的饭。
Hey, where
Where are you feeling better?
yeah, I can speak. Yeah.
Yeah, so like some of our colleagues, participants, they got COVID, but they still get online.
Yeah, I was like, my husband and daughter both got COVID.
But you're negative.
But
Yeah,
I'm
she's
negative.
negative. Just
I'm
to
negative.
clarify.
Yeah, I was like, I tested myself 3 times at home. And I was like, how can I be negative? Even though my husband and daughter are COVID positive. So I got a PCR test day before yesterday and I got the result yesterday and I'm still negative.
Good. Yeah.
So that's why I came today. I don't want to spread it.
I think yesterday's was a great meeting, that hackathon.
Yeah, I know.
The words went out. So for people for communication, there are barcodes on the doors, one for lock group, one for Slack group. Feel free to join. We have regular communications to those two channels. Finally, where were you yesterday?
What's that?
Did you come yesterday? Oh, yeah, okay. Yeah, noticed. Oh, Michael. Friends from Texas, Haya,
Okay.
and friends from Japan. South of Japan, I think Fukano San flew from south of Japan to Tokyo and then come here. It's 24-hour journey. And then we have Anthony from Hong Kong, Shenzhen, also like at least a 12-hour flight on the flight, not counting the other traveling times. Yeah.
Oh, wow.
And Tom is from Beijing. Yeah, people from all over the world. Waiting for MC. Yeah, sometimes I think besides AR for D, I need AR for kids. Like this morning was chaos, sending kids to school. Yeah, let's start. Let's go start.
I think it's normally in the middle.
Good morning and welcome to day 1 of the AI for Developers meeting, where we're going to explore the intersection of AI, edge computing, and distributed cloud. We have a jam-packed day of insightful presentations, discussions, and networking opportunities ahead of us. Let's dive into the first session of the day.
We use AI digital characters to share the meeting. So it's truly AI for D.
Yeah, I heard that yesterday. It's pretty cool.
Yeah.
We will begin with a brief introduction to today's events and an overview of what to expect.
Okay, hello everyone. Thank you so much for coming in this amazing morning. And I'm so glad that everyone come to visit Finance and we have the chance to share our idea of AI. And today we're also going to have a lot of amazing presenters to share the advanced knowledge about AI technology in a different company. So today I would like to have I'm going to have a first introduction about our product. The name is Codes. Give me 1 second. Okay, let me start to share my screen. Does everyone can see that? I mean, especially in the Zoom, in the lock meeting. Okay, pretty good. So today, the topic I bring today is simplify your AI development with codes. So let me have an introduction about myself. My name is Gary, and right now I am the developer operation manager of the codes. So I don't know how many people over there has the AI background or have the coding background. So right now there's one big challenge for the AI development is a consuming process, because right now a good AI app is not just an LLM, but also prompt, API, rack, memory, and the DevOps, a lot of things. Also, you need to provide a really good and user-friendly interface. So in order to deliver a good AI product to our user, people, especially for the product team and the engineer team, they need to spend a lot of time to focus on to solve this kind of problem. So in order to solve this kind of problem, we bring our codes. So the definition of the codes is we are a leading AI platform from Binance, and also we would like to offer the one-step functionality to allow everyone to build the AI product just in a really fast way. And we are also so glad to be announced that recently we just be selected as the top 50 AI's consumer web products in the whole world by A16Z. So you can see this is our code's website. So it's kind of similar to the GPT store. So we have a lot of similar, or say different category like learning, coding, programming, and also the image generation and the efficiency. So you can pick the AI agent that you like to use and apply your work. This is some showcase that what people they do in the codes. You can build a code optimizer, or you can build an AI chatbot that recommends the hack news to you every day. Or you can even integrate the Photoshop into your chatbot. So you can see, I just upload a doc, and then they help me to remove the background. So the similar action or functionality, we still have a lot, and hopefully everyone can have the chance to explore it. Also, we offers the entertainment area. For example, people can build an interactive game over there, or they can build a bot that generate a lot of image at the same time, also tell a good story. In addition, some people say, I'm lonely, I need a friend. They can just use the codes to build AI desktop. Also, for some people, they are working on the business part. They would like to say how I can let AI help me to make money or to complete some business task. This is one example. So some people build an IELTS mentor. You can just have a phone call with the chatbot, and they will just react to like real people and help you to practice the English. Or you can build like marketing consultant, job hunting assistant to help your life. And I do believe right now, you definitely see so many AI products in the whole world, but we would like to recommend codes. So why codes? Because codes make the AI development never be that easy, especially for a lot of high-level technology like Llama Index, LangChain. It's really not friendly for our normal people, especially the people without AI background. So we want to 10 times faster allow you to build an AI agent, no matter you know coding or AI development. This is how we build an AI agent. 4 steps. Number 1, write the prompt in the left to tell AI who you are, what you can do, and what you cannot do. This is 3 steps. And then add the skill from the middle. In the middle, we offer a series of powerful functionality like plugin. It allows your AI to connect outside the data. Or we have the workflow allowed more than maybe 10 workflow, 10 LLM working together. Also, we offer knowledge, which allows you to easily to enable your AI have the rack functionality. Or we allow the Code's AI to have the database so they can have a long-term memory. After you pick those skills, you can test in the right side and then click the publish. What's going to happen is your AI chatbot, or say your AI agent will be everywhere. They can go to Discord, they can go to Telegram, they can go to your Ins, your WhatsApp, and your Slack. Or if you want to do some high-level application, you can wrap it as Web SDK or API. There's some use case. For the first one is the people, they just build AI assistant in the social media like Telegram and Discord. They can help the company or help the organization to answer the question 24/7. Another use case is some people, they just build a website, but they don't know any AI development, even coding experience. So they just copy the Code's Web SDK code in their Wix website. And you can see that chatbot can answer the question in a really easy way. Then this is another use case for the enterprise side. This is a CRM website. It's called Attractive. This company is based on the Vietnam. Right now, they have like more than nearly thousands users to connect the codes in this website. They use API connected with the CRM system. So those customers, no matter where they are, no matter where they're from German, from American, from like Singapore, all the people can talk with this chatbot, like in the different platform. For example, WhatsApp, Facebook, and all the chat message will be just like show at the same time in the CRM. So the business people can easily to tell if those AI to solve the question or help the business to complete some shopping order or something. This is one use case, and they told us Code's chatbot helped them to improve the 30% efficiency. Also, this is a more advanced user case. This AI, this is like a Chinese version Perplexity. They totally use Code's API because they are not a big team and they don't have enough like an AI engineer, but they still want to offer that some amazing AI product. This is like the showcase. They use the Code's AI to search the information from different websites, different platform and the channel, and show them together. They also show the image and show the video. This is like the power of the code. A lot of people, no matter you have AI experience or not, to build a good AI application. So how to build a code? So today I'm not going to talk about it. You guys can go to the Code's website to check. But I would like to offer another opportunity is like be Code's partner, because I believe today definitely have some like founder or investor. So I would like to, have an opportunity to help you to join the Code's or say the ByteDance ecosystem. You can try to build a bot about your product on the Code's. We have like more than 1 million users in the whole world, so it can help you to get more user. Or you can integrate your product ability into Code's plugin store. So everyone who wants to build an AI agent, they can just easily to click your product plugin to get your API, enjoy your service, and then they might transfer to your customer. So this is like one use case. Another one is like if you are interested to hold more event no matter in the US or in the whole world, we are welcome with this, because recently we just hold an event with TikTok, for example. some people post the codes on the TikTok and everyone can access it. Or we're going to have like hackathon with Google Gemini just in this month. If you are interested about it, we are welcome you to join. So we are welcome this kind of similar cooperation in the marketing, and it can help us both get more attention in the whole world and help us to get more exposure. Yep. This is me. My name is Gary, Developer Operation Manager from Codes. And the left side is my LinkedIn, and in the right side is the Codes Bay Area community. If you are interested about the codes, you want to know more, and you want to apply into your company service or change your life, join the community. Let me know. Also, I'm going to post a lot of event, no matter from ByteDance or from outside. We're going to post the event for you to join and share your knowledge. So thank you so much. This is my presentation. Thank you. Any question?
Especially from hackathon people attended yesterday. That was a
So-
great time.
Yeah. If there's no question, that's all. Thank you.
One question.
Oh, please.
So what's the roadmap for supporting multi-modular capabilities?
You mean multi-user?
Voice to voice, end-to-end voice to voice, video.
Oh, yeah. We are definitely working on this. But I would just say it's heavily rely on the model that we have. Right now, we have a GPT-4o and Gemini. So if they have the multi-modal ability, voice or something, then we will have it. But we will, based on this, offer more ability. For example, allow you to like have a phone call and like to talk with real people, because we are applied by this advanced voice ability. So it just sounds like a real people, which sounds much better than OpenAI voice. Yeah, this is the effort that we have. And in the future, if you're interested, I will let you know. Anything else? Okay, that's it.
Our first keynote will be from Tina Tsu, representing ByteDance and Infinige AI. She will discuss how AI 4D is bridging the gap between edge AI and distributed cloud computing.
Hello, everyone. My name is Tina Zhou. I'm the co-founder of Infinite AI. I'm wearing the T-shirt. And the chair of Infinite AI Technical Steering Committee. Additionally, I serve as Director of Developer Relations at ByteDance and have over 2 decades of experience working in the technology industry with a focus on distributed cloud, edge AI, and open source ecosystem. Today, I'm excited to present our topic, AI4D, Bridging the Gap, where we will explore how AI4D is essential for connecting the edge AI with distributed cloud computing, a field I'm deeply passionate about and committed to advancing. Let's dive into evolving landscape of edge computing and AI. The landscape of edge computing and distributed cloud systems is rapidly evolving. Edge computing brings computation closer to the edge user, reducing latency and increasing efficiency. Distributed cloud systems, on the other hand, spread resources geographically, offering resilience, improve the data severability, and the lower latency. So together, they are essential for processing the vast amounts of data generated by connected devices. AI drives innovation by accelerating development, enhancing efficiency, fostering scientific breakthroughs, and personalizing user experiences. AI-powered tools help developers build solutions that solve complex challenges faster and more efficiently, leading to cost savings and increased productivity. Developers face several challenges when integrating AI into edge environments, such as limited resources, unreliable network connectivity, data privacy concerns, and difficulties in optimizing models for resource-constrained devices. Overcoming these challenges requires a deep understanding of both AI and edge computing technologies. To address the challenges of distributed edge AI, developers are turning to the cloud-based platforms like AWS, Azure, and GCP. These platforms provide scalable resources for training and deploying AI models while offering integrated tools to streamline workflows. By leveraging distributed cloud infrastructure, developers can efficiently manage and deploy AI across edge devices and edge environments. Developing AI applications for edge computing requires a well thought out strategy. Number one, define goals. Clearly define the objectives. Number two, data acquisition. Gather relevant data. I think Marsha will talk later about how we gather the data from the water meters in the city in Kansas. Number three, the model selection. Choose a model that fits both the problem and available resources. The gentleman was asking about the multimodal. I think this is relevant. Sometimes we think about large model or small model. And the fourth, about deployment. Efficiently deploy the model to edge devices. These steps are critical for successful AI deployment in a distributed cloud environment. Several tools and platforms aid in the development of AI for edge environments. Model training frameworks like TensorFlow, PyTorch, and Keras. Oh, I'm going to the PyTorch conference in San Francisco next week. Hope to see you again there. And also the edge computing platforms like the Google Edge TPU, AWS Greengrass, Azure IoT Edge. Of course, our company also have this BGE, the ByteDance Global Edge, and also have the Edge Intelligence. AI development environments include Jupyter Notebook and VS Code. We have a Mouse Code, which has the plugin of VS Code. And the data management tools include Amazon SageMaker, Ground Truth, Google Cloud AutoML Vision, and these tools streamline development and deployment across edge devices. To maximum performance and efficiency, developers should optimize models for resource constraints. I think Jeff Brower is on the way here. He's gonna talk about something like how to optimize model, and Marsha talk about how we distill a small model using the smart meters from the large language model, and also prioritize data privacy. So this is very important about the trustworthy, and also ensure the robustness and reliability in the face of noisy data. Continuously monitor and improve deployed models. These practices ensure successful and reliable AI implementations. Optimizing AI performance in resource-constrained environment involves techniques like module compressions. I think the work stream number 4 in the Infinite Edge AI project has that. And the hardware accelerations, I see the work stream number 1 to leverage the CPU and GPUs for this acceleration, and the edge-specific optimization to reduce resource consumption and improve accuracy. I think Tom is going to talk about something, the edge gateways for that has been used in many cities like California for the Agriculture Department of California, and also in Malaysia for the on the ocean, it's not submarine, right? It's the underwater, some of the workload there. Tom knows more and he will talk about that. And distributed inference is also key to scalabilities. Yeah. And in 2 weeks, we probably have Nexa AI to come in here to talk about how to do the inference on the edge. And also, Edge AI reduces latency by performing inference locally, improving response times, even in bandwidth-constrained environment. Distributed cloud architecture further enhanced this by offloading data to the cloud when necessary. That's why Edge Cloud is important and play a great role here. Security is a critical concern in Edge AI. I have Wenhui, our security expert. She may chime in at any time. Techniques such as data encryption, security communication, anonymization, and access control protect sensitive data and ensure compliance with privacy regulations. Scalability and efficiency are essential for Edge AI. Model compression, hardware accelerations, and distributed inference allow AI models to run efficiently on resource-constrained devices. Edge AI benefits from cloud services for tasks like data offloading, model training, and resource management. These services ensure real-time AI inference at the edge with minimal latency. Federated learning allows models to be trained on decentralized data. As Marsha and John will talk about the federated learning, how to use our environment, preserving privacy and improving model accuracy by leveraging diverse data sets. This is crucial for industry with strict data regulations. Our adjacent project, OPIA, they more look at the enterprise level, enterprise grade solutions. This is crucial for them. Continuous learning is essential for Edge AI. By collecting and analyzing data in real time, models can adapt and improve over time, creating a feedback loop that enhances overall performance. Ethics in AI4D is critical too. Developers must address issues of bias, fairness, privacy. We don't want to see a black, maybe there's a black polar bear there, but it doesn't make any sense to me. And the transparency to ensure the responsible AI development. Accountability is also key, especially when deploying AI in sensitive environments. Edge AI enhances the user experience by offering personalized interactions, reducing latency, and improving accessibility in remote and low connectivity areas. I do like one of the hackathon team yesterday, I think from Team Pacific. Are you here? Wave your hand. Like they do some, when you ask, when you type, the AI agent they built, it comes with a read out, because some people they can see, right? Like you have to read it out for them. And also contextual awareness further improves the relevance of AI-driven experiences. Efficient AI model management and deployment are key to AI adoption. This includes selecting the right models. I think the gentleman asked the questions before, optimizing them for performance, and monitoring them for continuous improvement. I see Coase or Doubao probably have those model marketplace. They can choose which is the best. From yesterday's hackathon, I see the teams, some of them choose like Llama, they choose Doubao, they choose Cloudy, they choose OpenAI. I think for different workload, different use case, the models, different models will have their pros and cons. And I think as long as the effect is good, as long as it's in line with the ethics, that's okay. Collaboration between the AI researchers, we have some researchers, we have developers here too, is essential for translating the cutting edge research into the real world applications. Yesterday, me and my team mates, we built a robotic arm who can say hi and shake hands and dance and smile. Yeah, this is to the real world applications. By deploying AI models in industry like healthcare and manufacturing, we can solve the real problems and drive the societal impact. AI experts like you guys and developers must collaborate to bridge the gap between research and application. Experts provide the knowledge needed for model optimization, while developers integrate AI into practical solutions. Our AI4D landscape focuses on model development, layered applications, and security. By building on a strong foundation, we can accelerate innovation while ensuring secure and efficient AI deployment. So if I walk here, you can see this is the core, the models. Because these models, we have all of these things like what is it called? The house the bees build. Yeah, but to me, it's more like you are peeling the onion. Based on the model, whichever model you choose. So at the very top, you have this AI agent framework. Like you can have Coase, LangChain, and the others. And then below it, you need to run the runtime. We have the workstream 3, which is the edge agent runtime in Infinity Edge, the AI project. You can see we have many here. We even have this, we call it Spear, right? Wilson, you want to chime in to talk about this? Yeah, Wilson and Professor Lee are the leaders for the workstream 3 for the runtime for Edge agent.
So yeah, so the runtime is just like it's a design that we want to provide a platform for, just like a layer of like system. You can think of it as a system call for AI agent. So like for us, we have POSIX, and for the AI agent, we want to provide another layer for the particular, for the AI agent that has it provides all the features needed for to implement AI agent, for example, workflows and some like memory, and also some other feature like the vector database. So we want to provide this layer to the AI agent. So later, it will be much easier for us to implement different kinds of AI agents. Yes.
Yeah, thank you, Wilson. And I'm so proud that we have the great engineering team here. For the AI libraries, so we have Western Edge runtime. We have our guru, Michael's there. Michael have the other talk later. Like Opia, Malini, you want to say some words? Malini, yeah. Your voice broken up. Malini is the TSC.
Hello,
chair.
hello.
Hi, Malini. Yeah.
So OPIA is one of the newer projects in the LF, AI, and data space, and we're focused on making things easier to adopt in the enterprise space. So it is all about integration with like authentication, authorization, scalability, sharing. So all the goodies that are coming from other open source projects, we integrate to here and make it enterprise ready. And I'll be happy to share a few more words tomorrow. Thank you. Tina, you're still on mute.
Okay. Can you hear me now? Malini? Wei?
Yes, we can hear you now.
Okay.
Yeah, we okay.
When I talk about my previous life, I got a multi, I don't know who did that. Sonic, and we are building also a Ethernet protocol for the scale out. If any company is interesting, come talk to me during the break. And also, we also have like a PaaS platform like Kubernetes, everybody know, OpenVINO, yeah, and the others. Why we have security. I think Wenhui has another talk all about the security. We have a confidential computing infrastructure, and we support trustworthy, and we have the CC APIs, and she can talk about a lot more than me. Okay. Looking ahead, edge computing will continue to expand, driving the need for AI4D and collaboration between AI experts, developers, and industry professionals will accelerate innovation. Advances in AI will lead to more efficient models, transforming industries like smart cities and IoT. This concludes the presentation on AI4D. Bring in the gap. Thank you for your attention. And I'm now, by purposely, I leave more time for Q&A, more, I like more interactive discussion and communication here. Does anybody know where to find the Infinite Edge AI project? Let me see what I can go. This laptop goes to internet, right? Let's see what I can pull to Google Chrome. This is a wiki page. We have can control from here. Yeah. So if you Google the elfedge.org, then you will find all the projects, and one of project I launched is called Infinite Edge AI. So today we are my time can get all the way to 11:05. So yeah, we still have like 9 minutes, so I'm open for discussion here. How can I like? Is there any way I can like control? Like, should I change your setting to like a duplicate? Yeah, let me change it to duplicate. Is that a display, right? Displays. Displays. This is extended. How can I change to duplicate main display? Oh, okay, mirror for use capture. I just want to control because I can see from here, I can control, I want to show people where the website is. So I need the duplicate the screen. Sorry for making trouble. Let me see. Building display. Yeah. Okay, yeah, perfect. That's one guess. See, that's why we need AI. Okay, this is the wiki page. But if we go here, you can see the project. And you can see the Infinite Edge AI overview here. So if you are joining the lock meeting, and Wilson, can you help to post the official like like the official website? If you Google Infinite Edge AI, yeah, that's the first one from Google. Thank you, Google. And this is like what is Infinite Edge AI, the vision, the mission, and the architecture picture and the use cases. To get started, you can get a code, go to a wiki, and we post a lot every day there. Join our mailing list and discuss on step. Just click, it will just guide you there. And this is the wiki. If we click in, we have this AI overviews. It gave like edge apps, manufacturing, and also there were like 5 work streams. The first one is Geo-Distributed Cloud for AI agents. Yeah, so we have this global AI inference infra. There were like 7 data centers all over the world using the OpenAI, Anthropic, Gemini, but we run some edge app like live translate, styling very smoothly. And the edge database and algorithm, a lot of cloud companies, they are very interested on this because they have a lot of legacy on the database, but now how to run at the edge. And also, Wilson just introduced the Sphere, the scalable and performant edge agent runtime. Wow, this is a great name. It's called Sphere. And the things I was just showing you the landscape, right? Remember, there's this runtime on the right hand side. And this is more. See, this is 2BD and invite for contribution. And also, this is the architecture picture and explanation. I think the team is just at the stage contributing the code. I think it's the right time to join. And also the work stream 4 for the federated learning with Edge Lake. Marsha and John will talk about more later. Excuse me. You can see these are the already filter data set we got from a real smart city data from a city in Kansas in United States to how we do the get the data, but the train our small models. And the work stream 5 for Edge Gateway, and Tom will talk about this later. There are more things, and if you want to know what about this event and accept the invite invitation for tomorrow, in-person arrival for today, and this was yesterday, the day 0 hackathon. You can see all the information from yesterday if you miss. And this is a result. See, if you were here, great, yesterday. This is a result. Otherwise, you just missed like $14,000 awards. Not everybody got awards, but they're all great teams. This is our day 1, day 2 timetables. For the speakers, if you haven't uploaded, please upload your slides here. And we do have the community meetings. These are the meetings. We have meetings at California time, 6 p.m. for 45 minutes every Tuesday. It's going through lock because it takes the AI meeting notes and have the live translation on the script. This is perfect for me, and you can see any of in September 10. Okay, I see we are missing the meeting notes here, but the previous, this is a meeting recording and the summary. Look at this summary is all based on our AI tool to summarize. I talk about enough, and any questions so far? Yeah. Okay, perfect. I just stamped you successfully. Okay, cool. 3 minutes in advance. I actually upload the slides here at the event, Day 1, Day 2. It was uploaded here, so feel free to download. Cool. Thank you. Thank you, everyone. Should I change it back to the extended mode or not? Do you want me to change?
Next, when Huey Zhang from ByteDance will talk about how to optimize edge and cloud inference systems, particularly in the context of large language models.
Hi everyone. This talk I'm going to combine two topics. One topic is like how we deploy like edge and cloud collaborative support for large language models. And secondly, we are going to address what are the security issues inside and what are our solutions to handle the security issues. So the topic is like firstly going to like optimizing edge and cloud inference systems for collaborative large language models. Like everyone knows about how to train the large language models, and people like have heard of like large language model serving is a popular topic and it's a trending topic now. As far as we have already got the large language model trained, the key obstacle to get it onto the market is like to serve it to the different apps. So what are the difference between like training and inference? So there are two main differences between the training and the inference systems. First of all, like usually the inference system is a long-term service deployment, which means that once the models are deployed, they typically operate as a long-run service, which means probably if it is deployed and it works fine, then people probably like will keep the version for a long time. That means we should have like version control of the system, and also we should have like a stateless serving for the whole system. And the other thing is like there's no back propagation required for the pure inference part. Like when people usually talk about like serving system, people usually means like both continuous fine-tuning and inference. However, the inference part only process and it does not involve the back propagation or gradient descendant, which makes the system quite like a straightforward and quite simple. And so what are the optimization objectives when it comes to the edge? So the difference between the cloud and the edge is like edge devices, not what I mean by the edge cloud, is the edge devices are usually like with little battery and also it with limited resources. So with this stricter like resource constraints, inference system often face more stringent source limitations than the training systems. And also one key difference is like, as far as we know on the cloud, we have H100, like A100, mostly is like NVIDIA GPUs. However, on the edge, the devices on for the inference models that deployed are varied, requiring adaptivity for the difference of the hardware system environment. So how could we resolve that? And this is a topic to talk about today. Before we want to know like how to how before we go step into what the system is and how to do we do optimization, let's go for an overview of how the Agile Cloud inference deployment model is and how the system end-to-end system looks like. So there are 5 different deployment nodes across the different companies. Like most of inference systems on edge right now is is similar to this deployment model. Like people deploy the model on the device, focusing on optimizing the model execution to reduce the latency. And this kind of like a smaller LLMs are put onto the cell phones, earplugs, and smartphones. For example, people previously use like transform models to work on the applications. Like when you download the app, the application will download the smaller models onto the device and do inference from there. This is a model structure specifically for the edge, and it applied compression techniques beforehand. For example, it used like model quantization and pruning techniques to make the model smaller. And the model is designed specifically to run the ASIC chips for neural networks. And there comes as it deploys, people want to use larger and larger models. So that's why people are trying to use secure communication protocols between the edge devices and the cloud edge devices, where they deploy the model in a data center, where the edge devices send the request to the cloud via the security communication protocols. And the cloud actually do the inference and returns the results. And the large language models residence in the cloud, where we need to enhance the model security by running in the cloud. And actually, we fully offload it to the cloud. And this might compromise real-time performance. So this one is not largely deployed. The third one is like collaborating edge with cloud inference together, where we put the smaller models on the edge devices and the larger models on the edge cloud. For example, the planning model, the agent model, is a small model that is dedicated to this user for this application. So it is pre-downloaded and trained, a little trained and compressed on your cell phone, stored on your cell phone, and it will communicate with the large models for further execution. So it leverages the structure of the AI model of the different layers. For example, for a student model on the device for computation, while the other parts are still placed in the cloud. And the fourth one is like, some people think, okay, I have a lot of devices, IoT devices in my home, and I want to use them all. So how could I do it? I want to do a distributed system from a distributed serving, where we got the inputs from the edge cloud, and it also requests the LLMs on the edge cloud to support some of the services. So what it did from the different from the previous model is like the models are dynamically sliced into different slices. So some of the models are dynamically downloaded from the edge cloud onto the edge devices, and some of the models are still resident on the edge devices. And these two models actually dynamically change and collaborated do the computation with the thing is like then we manage the scheduling of the computation models and balance the load through input data scheduling. So this is the most of the current status of the companies, especially the phone companies. And ultimately, we want to let edge and cloud synchronously and serving the distributed dynamic of loading for the inference. So we want to ultimately what we want to do is like we want the decisions of the slicing of the model and the scheduling of the models between the different devices that make the decisions based on the empirical balance of factors such as the power consumption, the accuracy, latency, and input size. However, this procedure is like this deployment model is still work in progress. And this model this kind of the deployment means that different models can be selected from the current popular models, and layers could be combined from multiple models through knowledge distribution and mix and match techniques. For example, more powerful models can be placed on the edge cloud, while the less powerful models can be deployed on the edge. So what it does is like this. Data scientists, developers, and DevOps actually write the app descriptor and put their like requests through a container registry to select the different models. And the container, they do the planning on the data scientists and developers side. And then the planning will select the different large language models and it finds the like a container registry with the right model to use. And then the orchestrator will follow the idea from the data scientists, developers, and the developers and orchestrate the LLMs they want to deploy into the centralized infrastructure. So what does the Kubernetes container layer looks like? It has an application layer, and then under it, we support the CUDA toolkit layer. Under the CUDA toolkit layer is like a Euro Ubuntu 2204 or like a Debian 12, Docker and Container OS user space. And under that, we have the CUDA driver installed. And under that, we have the host OS and the NVIDIA GPUs passed through to the containers. So in this case, it will support low latency, high throughput, scalability for use. For example, if we have lots of user requests for example, during the Christmas season or Thanksgiving season, then we could scale it out dramatically from there. And this one, because we are selecting the best models for depending on the planning, then it could provide precise predictions to adapt to the evolving interests of the news content and readers. So what are the open source inference frameworks now? So we have from 21.6, we have TensorFlow Serving, TouchServe, Trident, Bento ML, Kubeflow, Sheldon Core, etc., etc. And all these different inference frameworks, they have their own data structure. They have their own format of the input model, and they have their own ways of loading the models, doing version control, and doing the data management and then support the APIs to the end. However, so this one actually introduced lots of hurdle to our deployment, right? Remember that we have lots of different devices and different devices might use different inference frameworks. So how could we resolve that? So we need some optimization and adaptation to apply all the stuff of all the inference systems across the different devices. So what we need is we have to support the different devices with different kernel hardware level optimization, and then we subtract the IR, which will accept all the different data structures and transform into one pure format to run on the runtime. And on the runtime, it should do the auto scaling and slice split between the edge devices and the edge cloud. So what are the bottlenecks now? For example, to adapt the cloud-based inference systems to the cloud and edge collaborative inference systems. First of all, as we talked before, we have different frameworks. So it's not like our cloud, for example, on the model as a service, we only have one solid inference framework, right? But for like edge devices, it has different inference frameworks. So we need a model converting of the different previous AI frameworks. And then the size of the models are quite large on the cloud for the cloud inference, right? So usually it's 7B equals to 28 gigabyte or more. So this size is not acceptable for the edge devices. So we need to reduce the size of the model. So, and also for our edge devices, it goes through the I/O. It goes through the internet. So we want to reduce the size of the model for I/O bottleneck, reduce the I/O bottleneck. And also for collaborating edge and cloud, we need the scheduling algorithms for faster execution. And for the edge devices, we need faster executions to be specifically for that different hardwares and to adapt the large language models onto edge devices. So how could we resolve that? So to resolve the problem of model converting of various AI frameworks, we need a model conversion and optimization, which will convert models trained on different AI frameworks to one single format. We call it MLIR. And to reduce the size of the model, we need some lightweight models. And these lightweight models are deployed on the edge. And to reduce the size of the models for I/O, we need a model compression for the regular traditional 7B or 1B models. Techniques like pooling, distillation, quantization are used to compress the models. So to do the scheduling for faster execution, we need lots of parallelism. But this parallelism is different from the previous cloud-based parallelism because we need to do batching and we need to do bin packing to pre-download some of the models to the edge devices or pre-upload some of the results or intermediate results to the cloud to avoid the I/O bottleneck. And we need to do faster execution on the edge devices. Which means we need high performance operators. The operators such as supported by NVIDIA TensorRT, Tensor Real-Time, and also TF TensorFlow Lite, or TVM by Apache of Tianqi Chen's lab is another good option. And Apple also supports high performance operators set of the core ML. However, as we know, the operators will dive into the details. The different frameworks have different operators, and some of them are redundant, and these operators are not quite aligned. So somehow we need to abstract the operators, map it into a simple set, and then translate it to the different hardware devices. And to adapt the LLMs on the edge devices, we need execution of the inference engine for the specific kernels. So let's dive into the first one, which is model conversion and optimization. As we can see from this table, for example, the popular frameworks like Caffe, TensorFlow, and PyTorch, they have different model format. Caffe supports the Caffe format, and Torch support self-native Torch model format, ONNX, and TouchScript format. And different like a format, they use different set of the operators, for example, and the size of the operators are totally different. For example, the TensorFlow has more than 1,500 operators, while PyTorch has 3 versions. Different versions have different operators. And both of them output the models, the layers of the models in different format. For example, Cafe in Cafe model and PyTorch in PT file, etc., etc. So what we need to is like, we need to firstly write a converter for each and every framework, and then convert the different formats into one consolidated inference IR. And from this consolidated inference IR, we firstly do some pre-optimization. The pre-optimization is some standardized compiler technologies, such as dead code elimination, like a constant elimination, and the common operators elimination. And then we do some optimization, such as the operator fuse, the operator replace. So why do we do operator replace? It's similar to the architecture part. Like you see, like Intel x86 has several implementations of multiply. So we want to like, well, ARM only has one implementation of the multiply. So we want to make the x86 also into one consolidated form, multiply. So like all the operators could be orthogonal. So so that in that way, like all the AI frameworks, they could be formatted into one IR. And then afterwards, in the end, when it deploys on the different edge devices, we want to do some post optimization, such as we want to change the data format into the where the edge device could accept. And we want to like remap the memory and then reduce and combine the operators so that it could be more efficient on the edge devices. And while transforming the while transforming the AI edge devices between the cloud devices, we need some model serialization. We need some protobuf and flatbuf conformated serialized format, and we do need to do a IR design and schema design to transform and convert between the different edges. So the converter, in summary, the converter includes 2 parts. One part is a graph converter where it converts all the different frameworks into inference IR. And then the other part is graph optimization, which is like a do static and conform static and dynamic graph on top of the inference IR, and do the operator fuse, operator replace, layout adjustment, and memory allocation for the different devices. So so what are the in the AR frameworks? As we could see, like the AI frameworks usually includes the tensor and operator. So what are the a tensor is like a kind of int, float, or string format of matrices, or like a different what we call tensor is like not only matrices, it has 2 separate dimensions of the matrices, which will tell us what the models are and the different dimensions for model. And inside of between tensor calculations, it's like the operators are calculating them. So we can go from one step to the other step. So what are the common operators include add, sub, multiply, and convert, convolution, batch form, etc. So how could we when we define the tensor in the PyTorch, it looks like this. The data format of the data look like this. So we have different memory allocations for like the tensor. And the different memory allocations, some of them works for the edge devices, some of them work for the cloud better. And we have the definition of the tensor. And we also have the different operators, like the common like and special operators of their use. And we have some like common operation definitions for each and every operator. For the compute graph, we have the subgraph definition, and we have the net definition. So all these stuff are in the model. We need to translate them from one to the other and translate them into a consolidated IR. So for operation replacement, as we said, for the first optimization, operation replacement is like sometimes we have one-to-one. First method is like we do one-to-one mapping, where we map for example, we map a linear to the convoluted 2D. So like make the fully connected layer into 101 convolution, so that if it is 1x1 convolution, then it is much easier to be calculated on the edge devices where they have the neural circuit ASIC. And we could do some other like calculations on the edge cloud for this. And also, we have the 1/several, which means we use one operations and translate into several other like 2 or 3 operations. For example, the shuffle channel replace could be replaced by reshape plus the permute. And also the path replace could be replaced from path to like a pad 2 from the like inference like the input model to the other kind of model. And also the ship n replace, which means like we could translate the ship n operation for different and several like ship operators. And the group convert replacement, we could use a group convert and use it to be implemented by slice and convert. And the group convert probably does not like work on the edge devices, but the edge devices could calculate the slice and convert convolution. So that's why we use this one to we use like some operators that could be work on the like edge devices to replace the complicated operations on the cloud. And we have the linear operations of the different linear like operators, which is called optimization of operator fusions. For example, we could use convert, bn, and act, and we could use convert, BELS, and add, etc. And also, for the operators like permute, we could fusions, we could add matmu and skew, and batch norm with skew, and batmu with add, etc. And for the other fusions operations, we could use a convert with a ReLU6, so that makes like the operation action faster. Another technology is called to reduce the size of the model for the I/O. We need to like do some pruning, distribution, and distribution, and quantization. For the lightweight models, sorry. To reduce the size of models, we want to deploy the lightweight models on the edge cloud, on the edge devices. Previously, there are lots of lightweight models. For example, the SqueezeNet model, the ShuffleNet, BottleNet, ESPNet, etc., etc. And what they do is like the main contribution is like they use a smaller like kernels to replace the old big kernels, so that could be executed on the edge devices. And it uses a depth-wise convolution to replace the previous normal big convolution. And also it uses a thick connection to make the model like more steeper, so the results could be more accurate. And the most recent like lightweight models are including mobile VTI and mobile former and efficient former. We'll not go into details for today, but I will put the inference, like the references here. Sorry, a little typo. So another technique is what we call is like a model compression. Model compression, a popular like compression technique ideas include pruning, distillation, and quantization. For model compression, for quantization, we have like a QAT, is called QAT, and we have post QAT and post static QAT and post static QAT. What it mostly works on is like, for example, the edge devices only works for the bit-wise, for example, int 8, or like even smaller like precisions. While the edge cloud device models, they work for like float 32 or like the other kind of like model sizes. So we want to quantize the float 32 into int 8 models. In that way, both the IO and the model size are reduced. So I just, and there are some like pruning techniques. Pruning means like, for example, we have a large model, and some of the models, they actually are zeros. So for those zeros, we could actually cut them. Like, so like when we do the convolution, we don't need to multiply all of them to like, that makes some redundant calculations. So there are lots of pruning techniques. And also they have another like model compression idea is like knowledge distillation. What we are doing, like we use the teacher and the student model to train the teacher model to make it much like smaller. For example, we have a model size of 32B, and however, this model includes lots of knowledges. It includes response-based knowledge, feature-based knowledge, relationship-based knowledge, and architecture-based knowledge. Well, in our like application, we probably only need a relation-based knowledge, right? So in that way, we could do some like distillation, to use the data to fine-tune the models to make it smaller and make it perfect for the relation-based knowledge. So in this way, the 32 billion model could be reduced to 2 billion model, which could be deployed on the edge devices. And I want to go into details because of the time limit. And for the scheduling of fast execution, as we know, like we have previous batch and bin packing techniques. And for faster applications, we have light operators, like a call ML and TF light, as we could see here. And as we talked before, we have lots of like different deploy models which request us to communicate from like the edge devices with the cloud. And also we need some synchronization between the edge devices and the cloud. And also the users, maybe they does not trust the cloud. And they might think the cloud might steal the data and the cloud might change the models from somewhere. So how could we make sure as edge device owners, how could we make sure that the cloud did as it is, especially in the mode 4 and 5, where the models are dynamically cut and have constant interaction from the edge devices and the cloud. How could we make the track monitoring system, for example, what we call it attestation, to use a third party to attest and verify that the cloud devices did what it is, and the interaction between our edge and cloud did as it is. So here comes our a framework. Our goal is to build a unified APIs which actually support different devices and the different edge device, both edge device and cloud devices, and make it a unified attestation and evidence support for the large language models. So using this API, you could track the model version and which model slides are downloaded onto your edge, whether that your action and your requirement are actually executed on the cloud as you want it to be. So this framework could be deployed on Intel TDX, AMD, CVS, MP, and etc. Any TE-enabled hardwares. For example, most of our edge device enables the Trustro, and they are going to enable more on edge devices for this support. And in the cloud, it could we could support confidential virtual VMs. And on both the edge device and the cloud, we could run on top of the containers, where we support the confidential Kubernetes cluster to collect the evidence across the cloud architecture. And you could find the link from the details from the link of the spec and Elevators API from here. So we have the stacked measurement framework where we collect not only the model slicing and their hashes, and not only the data you actually use, but it also collects from the bottom up. It all collects firstly the vendor specific services to testify the TE hardware, and then on top of that, it attests the EFCC measurement of VTPM to attest the firmware, and then it collects the node level measurement to attest for if it is the right OS version that is a prompt safe OS version you are using. And on top of that, we do the container level measurement to ensure remember the agent on your device will select which large language model slice that will run in which container, the container images. We do support the container level measurement for each and every image layer. And for this way, we use a stacked measurement framework to ensure that in its integrated measurement register, and it will gather a node level evidence and container level evidence for the framework, and could be used to complete the remote attestation on your business needs. And we provide easy to use tools and examples to building in multiple deployment flavors of the confidential computing environment. We also provide the reference design for the confidential and generative AI load-on model and data protections. And one of our examples in the our repo is to support the large language model inference protection. You could just run and test it out. And we also support, last night we used some time to write a quick start to support 2 specific use cases, and we put the links here. You can just click on the quick start and follow the procedure to try it out. One use case is for the node level measurement in confidential VM, and the other use case is for the container level measurement in the confidential cluster. And for the node level measurement in confidential VM, will not only support our cloud, but we also support the other cloud for federated learning as well. For example, we support Google and we support Azure. Then please like check out our website, and like everything should be like on the first page for the quick start and all the information. If you could not get and have the information and have any questions, just reach out, and then we have a stack, and then we have some like team members to support you for your questions. And also like if you have any questions about like optimizations, due to the time limit, we could not go into the details in this talk. However, like we could communicate and talk about it and discuss it like offline. Yeah, thank you. Please let me know if you have any questions, and leave on this stage for you to check out the code and demos we put there. And we have like several demo videos. I think we'll upload them on the website like later in the day. Yeah.
I think we have 2 minutes for questions and answers.
A quick question. Did you folks build your own optimizer compiler, or are you leveraging TVM or Triton?
We use like we leverage other people's like inference framework.
No, the optimization you talked about. So there are a lot of frameworks available, TVM and the OpenAI Triton. Or did you build your own framework?
Oh, we build our own. Yeah.
Oh, okay. Are you planning to contribute that back to TVM, or is it just
No.
no? Okay.
Yeah, that work is still in progress. Like as I'm in like security, so I'm mostly focused on the security part now.
Yeah, because there are a lot of work being done in open source, the Triton work and TVM.
Yeah,
So,
I think the O1 API, the ONext, that IR supports like more optimizations and more like hardwares and TPMs. Yeah, TVM. Yeah.
Okay. Yeah, I'll sync up with you offline.
Yeah.
Thanks.
So we do encourage everyone to try our confidential a demo for supporting the inference for the large language models inference in the link. Like if you have any questions, just reach out to us. And if you think it is good, please do a start and fork the repo. Yeah. Thank you so much in advance. So it's time I'll give it back to a next speaker.
Our next speaker is Haruhisa Fukano from Fujitsu, who will share insights into the future of network and computing infrastructure.
I like to have a two screen separate. Screen is okay.
Today, I want to talk about computing infrastructure of the for the 2030s, with focusing on the collaboration between the ION Global Forum, which is an innovative optical wireless network global forum, and also LFH on the photonic disaggregated computer, which is the new concept for the computing architectures. Let me just start by introduction myself. My name is Haris Safkano. I'm working for the Fujitsu about the business and architecture, planning about the 6G era infrastructure. I have more than 10 years of experience in the research and development about the heterogeneous computing, and also my job is PJ design for the network equipment. About activity in the open community, I joined the Linux Foundation Edge from the 2020, and I become a technical advisory council member from this year, and also LFH Agreno project. I am the TSC co-chair from the 2023. In Agreno, we contributed OSS stack for the building sensor network for the robotics. Let me explain about the outline of today's presentations. Firstly, I'd like to introduce LFH and also Agreno project as LFH members. Next, I will talk about the computing challenges, including the edge area. And then I'd like to introduce about the idea and activity to solve these challenges. And I will explain the photonic disaggregated computer as proposed by the ION Global Forum, which is a key to solve the challenges. And also LFH and ION started the joint proof of concept using the photonic disaggregated computer. I will explain about this. And finally, I would like to introduce our upcoming schedule. So let me introduce to the LFH and the Agreno project. Here is the LFH overview. LFH is an umbrella organization for the edge computing under Linux Foundation. The goal of the LFH is to create an open source framework for the edge computing. As an umbrella organization, we have several projects under the LFH. As you can see, the project is divided into the three stages, from the at-large stage, growth stage, also impacted stage. Impact stage means which is market release phases. Each project has its own technical steering committee, which decide its management policy and operate independently. So Agreno is the impact stage, and also HREC and Infinite Edge AI, which host this event, is at the large stages. It starts from this year, the new upcoming project. And also, there are more than 30 sponsors in total. Fujitsu is one of the premier members from the 2019. And next, I'd like to briefly describe each LFH project. There are a wide range of edges, including the area code for user edge and also service provider edge. And also, there is a layer about the from the infrastructure layer to the application layer. The LFH project covered all wide range area, user edge to the service provider edge, and also application layer to the infrastructure layer. In particular, Acreno aimed to develop and publish the edge use cases and the OSS stack, which achieve the use cases. And also, Acreno is a wide range of the area from the user edge to the provider edge, and also infrastructure layer to the application layer. For this reason, we Fujitsu has been working in that layer for several years. This slide explains about the LFH Acreno. LFH Acreno is developing and publishing the edge computing use cases and OSS stack for the as a blueprint to implement edge computing more easily. As shown in this picture, Acreno blueprint is the OSS stack, use case basis, fully integrated end-to-end solutions, and also proven and tested by the communities. So using this blueprint brings users to reduce the cost and also large scale and integrated as an few effort, for example, zero-touch provisioning, and also can be deployed on the open hardware and other benefits. So Acreno published over 30 blueprints across a wide range of the area, from to the user edge to the service provider edge, and also infrastructure layer to the application layer. If you have an edge use cases or ideas, we can help you open it on the Acreno. So feel free to ask us about it. So next, let me get down to the main topics. I'd like to talk about the challenges in the computing for the 2030 LF. As first, these figures show you evolution of the AI model. The vertical is the amount of the flops required to train each AI model. And also, horizontal is the year of the publication for each AI model. As you can see, flops of the AI model is growing at a rapid rate of amount 23 times per year due to the generative AI evolutions. This is much faster than the speed of semiconductor evolution. We call the Moore's law. So we are holding on that speed by increasing the number of the power GPUs and CPUs and making the system larger and larger. So I think this will eventually bring us to a power consumption collapse. So I say the power GPUs and also power CPUs. And another idea is that the system should be tuned for an AI model using the specific accelerators and also specific circuit. But as the diagram on this slide shows the resource requirement for the AI model different for each model. For example, the phase of learning and inference, other AI use cases, for example, ranking and recommendations, and also inference training. So I think coexistence of the reducing power consumption and the flexibility is challenges in computing for the 2030s. To solve these issues, the Linux Foundations and also ION Global Forum has signed a master agreement. The ION Global Forum stands for the Innovative Optical and Wireless Network. They are working for the innovations and implementation of the new network and computing infrastructure for 2030s. Regarding ION Global Forum, MTP, who is the Japanese biggest telecom provider, Harada-san will explain more detail in the evening session. So LF and ION Global Forum will integrate Linux Foundation software with the ION Global Forum network and computing platform to enable higher performance and low latency and energy efficiency to meet growing the data delivery demand. In this slide, I will introduce the ION Global Forum and the LFH joint blog, which we propose as a specific initiative for the ION Global Forum and LF collaborations. As shown in this figure, the ION Global Forum has a use case working group that define future use cases, and also a technical working group that consider the technology required to implement these use cases. And also LFH has use cases and also Acreno have use cases and OSS stack to achieve them. And use cases, there is many common use cases between the ION Global Forum and LFH. For example, the cyber-physical systems. So based on these common use cases, we started to integrate LFH OSS stack on the ION Global Forum infrastructure to improve the affinity between each technology, power, efficiency, and flexibility. Before I explain more detail about LFH and the ION Global Forum joint block, let me explain about the photonic disaggregated computer, which is a key technology to improve computing performance and efficiency. And this is proposed by the ION Global Forum. In this slide, I will introduce photonic disaggregated computer. This photonic disaggregated computer has two features that very different from the existing computing architectures. The first is disaggregations. This allows for us for flexible device allocation and reallocation using such PCI public switches. The second is to communicate the data directly between the accelerated devices via the photonics connections. As shown in this figure, the users request resources depends on their applications. Then the controller of the photonics disaggregated computer issued the instruction to the CDN management software, the CDI management software, which manage the resource pool and also allocate resource to the user and configure the logical node. Depending on the use cases, there also controller set the optical switches to configure a direct connection between the accelerator devices. So I'd like to talk about the more detail about the photonic disaggregated computers features. First is disaggregations. This allow for flexible device reallocations and also allocation. For example, if each applications require different resources in this figure, the current computing is server oriented. So we will allocate resources to each applications on the server basis. So this may leave some device unused resources. As a result, utilization efficiency is reduced. On the other hand, this is a disaggregation. We will allocate minimal resources from the resource pools which comes from the PCI switches, so we can optimize resource utilization. Second is device to device connection via the photonic connections. As this figure shows, the left one is client CPU-centric architectures. Data is transferred between the such as the accelerator devices by the CPU through the CPU memories. So this cause CPUs tend to be a performance bottleneck. On the other hand, the case of the device-to-device direct connection using the photonic connections, the data is transferred between these accelerators via the shared memory or connected by the PCIe fabric switches and also directly. So this will reduce the CPU load and the cord used for the data transfers, thereby reducing cost and power consumption. And also, I think processing delay we can reduce. And next, let me explain about the ion global form and the LFH joint bulk detail. Now we are looking for use cases to maximize the synergy between the ion global form and the LFH. So first one is generative AI plus robotics. There is many challenges for the current robotics. Current robots perform certain actions in the certain environments, but the future robots will be required to perform various actions in different environments. For example, collaborate with human in the same place. But it is difficult to design and to build a program teaching to the robot, assuming a different environments and the various operations. So teaching to the robot will be a big challenge for us. So so we think generative AI plus robotics is the solutions. When robots receive the command or operations that it does not know, generative AI asks to the generative AI, and the generative AI generates the animations regarding the command and the operation. And then from the animations, convert the animation to the robot teaching data, such as the arm trajectories. And also the result of the robotics motions, we will capture the data and also correct it as a training data of the generative AI. So generative AI, we will implement in the cloud area, and also robotics. Robotics will be the edge node area. This is the overall architecture about these use cases ideas using the ION and LFH technology. At the edge area, we collect the data and store data using the Grand Robotics Blueprint and also HX Foundry framework. And also LFH Edge Lake manage this data. About Edge Lake, tomorrow, Moshi and Nilog will explain more detail. And also, to sending data to the cloud and process data in the cloud, we will use ION Global Form technology, which is the NFS over ION All Photonics Network. All Photonics Network means directly to the each node connected by the optical network using several wavelengths. And also photonic disaggregated computer composable disaggregated infrastructure. If we resource need, just allocate the resources. And second use cases is storing data at the edge and also processing the data at the cloud using the green energies. We think there is some challenges for the green energies when the amount of the electricity generated by the solar or wind power exceeds the demands of the electricity. Power generation companies need to reduce the output from the solar and the wind power plants. This means throwing away all the green energy we have generated. As a result, the Kyushu region, where I live in Japan, lost approximately 1 billion kilowatts in the per year. This is equivalent to the about 10% of the electricity originally generated by the solar powers. So therefore, I think it is necessary to use the green energy more efficiently and reduce the ratio of the thermal power generations. So we think storing data at the edge and also processing data at the cloud using these green energy, which now we are throwing away, is a solution. So we put the data at the edge and processing data in the data centers, which area is where there is a surplus of the green energy. For example, when some data center is at night, we change the data center which process the data to the data center at where the data center on the evening, which is enough. There is enough green energy. So finally, I'd like to show you about scope of our joint POC. We are thinking about several phases about our POC. For for the first phase one, we will feasibility studied about the NFS over RDMA over ion or photonics network plus edge rank. Verify how fast ion can share the data to the cloud while managing data at the edge with the edge rank. And also phase two, verification of the improvement by the composable disaggregated infrastructure, which is the photonic disaggregated computing. Measure the time from the resource request to the resource allocations, and also measure resource efficiency by the things such as the composable. So the final phase is for features, actual application, for example, generative AI plus robotics, and also green energy use cases. Yeah, here is the related information. If you are interested in, please access from this link. Thank you for listening. Okay. If you have any question and comment, so we have no time. Sorry. If you have any question and comment, please send me from the Slack channel or the some email is okay. Thank you.
Before lunch, we have an exciting presentation by Tom Chin from Edgenesis and CC from Allegro on how AI and IoT are revolutionizing edge computing with Infinige AI.
The last one before lunch.
Hungry.
Lunch is still not here, right?
Yeah, they are, I think it's right in front. The cart is ready.
All right. So, hello everyone. I am Tom from Edgenesis, and today joining me online is CC from Allegro. So together, we're presenting the revolutionizing edge computing, AI, and IoT with Infinige AI. So here's today's agenda. So first we'll talk briefly into Project Infinige AI, since Tina kind of walked through most of it, so we'll just cover it briefly, and then I'll be introducing Shifu, and then CC is going to introduce Yomo, and lastly we're going to show you a demo of everything in action. So first, yeah, Infinige AI. So just wanted to talk about the terminologies because edge is a kind of a broad term. So in our presentation, near edge will be the edge cloud, which is closer to the data center, or it could be on-prem, but depending on the computational resource you have. And far edge is devices usually are resource constrained, like a Raspberry Pi or Intel NUC or Jetson Nano. And then for the IoT devices, we refer to them as edge devices. So Project Infinige AI standardizes the way to run, use, train AI at the edge as a whole. And then they also implemented using AI from different providers, such as function callings and API calls. And then lastly, it also includes a IoT connectivity part, which is done by Shifu. So I'll talk about Shifu first. So the problem today is that current IoT system lacks interoperabilities. So you can see we have a bulk of heterogeneous devices. And usually each device has their own siloed system, making it difficult for developers to develop IoT applications. So usually IoT devices and applications are highly coupled,
Well, in a traditional way, when we have only just one manufacturing software, it's fine. But nowadays we have ERPs, we have AI models, we have data centers, we have data lakes. So this just won't work. So think of it, if you replace one of the devices, you have to change every single application that interacts with it. So currently, this is done by manually. There's no standardized way, and it's a $400 billion US dollar per year problem. So how do we solve it? So quoting from Professor David Wheeler, all problems in computer science can be solved by another level of interaction. So let's think about the mobile development ecosystem for a while. The development costs are relatively low. We have a good ecosystem. If I were to develop an Android application, I don't have to worry about what kind of sensors on the phone or what model of the vibration motor it is. All I have to do is call Android's SDK or API to develop my games. So essentially, Shifu is, we're aiming to build Shifu as the Android for AIoT. So by abstracting all the device specific thing, all from applications, and put it into a layer of reusable drivers. The layer is Shifu. So Shifu kind of sits in between your applications and your IoT devices. And then abstract IoT devices as a set of APIs. So by doing so, we kind of completely decouples your application from your hardware. So it reduces lifecycle management, and everything we've integrated using Shifu is reusable and it's containerized. And then we have enhanced endpoint security down to the physical connection or up to layer 7. And then superior scalability due to its nature of Kubernetes native. And then we have minimum maintenance. And lastly, it reduces the overall development time for IoT applications. So here is a more detail. I'm not sure if you can see it. So this is a architectural diagram for Shifu. So at the bottom in the square, we have an IoT device, whatever it is. It could be running certain protocols, or it could be from a different vendor. And then what is it called? So the middle one is what we call it the device Shifu. It's referred as the twin of a device. So within that, we have the driver of the device, which does protocol translation, and it also does data format. So whatever goes in zeros and ones goes out as formatted. So it could be JSON, it could be XMLs. And on top of that, we have the layer 7 proxy, which is for application development. So from an application, all you need to do is just call the APIs. It could be HTTP, it could be MQTT or gRPC. So, so this is kind of like translation, but also added grammar in. So if we think of protocols as languages, understanding a language doesn't understanding the language doesn't mean I mean you have to know the grammar in order to understand the language, not just the words. So driver does that. So that's how you decouple your application logic, device logic out of your applications. So here is a Shifu in a cluster scenario. So usually on top of it, we have the master node running the custom resource definition, usually a 3-node cluster. For master node, we usually have 3 nodes, and for worker nodes, we can just add in on demand. So the more devices we have, if we run out of resources, we'll just add in 1 more node. So that node will start connecting to the devices and balance all the workload. Yeah, so today we have about 2 million devices connected with Shifu, and we have about 300,000 instances deployed over the world. And then we are currently in more than 6 industries. So the goal of Shifu is to become the nervous system of artificial general intelligence. You guys will see the demo later, but yeah. So Shifu is an open source project. It open sourced about 2 years ago. We have about 1.3 thousand stars at the moment. about 130 forks. And then since we have an open ecosystem, we already have customers and partners from Fortune 500 companies and industry leaders. And we're also part of CNCF. So Shifu is actually a CNCF's landscape project, and also InfiniEdge AI within LFEdge. Yeah, next I will talk about two of the use cases for Shifu. The first one is something we did with the California Strawberry Commission. So California Strawberry Commission is a government-owned agency that forms by the strawberry growers in the US. So if you don't know, California Strawberry Commission contributes to about 90 to 95% of all the strawberries production in the United States. And strawberries, one of the kind of labor-intensive fruits in the world. So it requires a lot of labor work. So the California Strawberry Commission always trying to find a way to digitize everything to help the growers. So, for example, a simple pest control issue costs them about 32 million per year. So what we've done for this project is Shifu is being installed on one of their tractors, so something like that. And then on the right side is a Raspberry Pi where Shifu is running. So this is the software architecture. But basically, Shifu installed inside there's a K3s cluster within it, and then connects to all the sensors on the tractors. So by doing so, they can leverage all the data from the sensor to give real-time assist for the growers who is driving the tractor. They call it the growers A. And then in addition to that, they continuously retrieve the data and push it to the cloud, sync it to the cloud for AI training. So eventually they are going to deploy small language models or using geo-distributed cloud, or they're going to change it to a maybe a Jetson Orin, so that it is able to do real-time assistance to the growers. So before using Shifu, they have a limited scalabilities. Their previous solution is ESP32 based, so deploying everything manually. So with Shifu, it's actually, there's no limitation to scale because every one of these is self-contained. And then before taking data from the field takes a year to build a pipeline. And now we have about data processing, customizations, and everything ready in 4 weeks.
Quick question. Did you get discount from the strawberries?
Yeah, I was there. I took those pictures.
No, I mean for eat. Did you
Yeah, I
get
did.
it written?
No,
Just kidding.
It wasn't in season last year. Yeah, and then it was hard to integrate with different solutions, software solutions, and hard to enable AI. And then it requires a considerable amount of manual deployment, connecting sensors and installing the software. And with Shifu, everything is standardized. Everything is a Kubernetes cluster. Everything is a manifest YAML file. And just plug in the USB stick and flash on the OS, and everything is ready. Onboarding is automatic. And then the next use case is a supermarket chain in Malaysia. So they aim to use AI-driven smart carts to drive sales, better manage inventory, and improve customer experience overall. So they were having issues. So they have this Raspberry Pi installed on every single cart. But before they were having issue to deploy new features because they have to do everything manually, copy and paste binaries and stuff. But with Shifu, everything can be deployed within hours, and then you can roll it back instantly. And then before they were having issue integrating AIs, so they're having a hard time doing the conversion. And with Shifu plus Edge AI at the store, they're able to increase the conversion to 15 to 30%. And then before, everything is transmitted to the cloud all the time. And now 80% of the data is processed at the edge on each cart. So it lowers the cost for them and also improves the decision speed, responsiveness. So this is their setup. It's a 3-tier setup on the cloud. It's centralized for all the supermarket chain. there are management, retail on top of it, and then at the near edge, so every store, every supermarket is in near edge. And then the for the far edge, it's the cart. So the cart is a worker node in this case, and then the near edge is the master node. So the worker node joins the master node. So they're all in the same Kubernetes cluster. And then each store has their own edge AI and cart management services and Shifu is installed on the terminals to connect to barcode scanners, and also on the cart for the different sensors like the display, alarm, beacon for positional data, and battery sensor information. Yeah, so that's for the Shifu introduction. Now I'm going to hand it over to CC.
Okay. Thanks, Tom.
Thank you.
Hello.
It must be very late there.
Yeah, CC is in Beijing, so it's like, I don't know.
Yeah.
3 a.m.
Okay. Hi guys. I'm CC from Allegro. This is the first time I know CC means confidential computing from Wenhui. Yeah. So I know you guys are hungry right now. Believe me, I'm sleepy. It's definitely a time and space problem. So today we discuss geo-distributed computing. Geo-distributed computing, we all know these words, but I think in the past 30 years, distributed system is it must be misunderstood because generally speaking, what we talk about distributed system means distributed in data center. Like Facebook, like Instagram, all applications did that because there is a database. I started writing code from 1998, and what I learned first is called Focusbase, a database software. And I think from today I can get rid of database because of database, we built API on top of it, and then we built our application. So the data must be exchanged between servers less than 7 million seconds. That keeps the distributed system healthy. But if we deploy our services applications around the world in different data centers, the only problem we got is time and space problem. If we can solve the problem, we can build a geo-distributed system. So people can put their request to the data centers close to them, so they can get the fast response and more secure and like GDPR compliance system. Okay, Tom, can you help me to next page? Okay, about 2 hours ago, OpenAI released a new model called OpenAI O1, and have O1 preview and the O1 mini 2 models. Today, when we talk LLM, everybody want improve their accuracy and improve their speed. We need the LLM answer our questions correctly and low latency give me the answer. In the past 20 years, I have wrote a lot of systems, but at that time, I used a word called loading instead of thinking. Today, the slow response of LLM get a new name to take place of the loading. It's called thinking. Thinking means the LLM is very, very slow. Tom, can you help me to next page? Okay, for accuracy, in the past 2 years, RAG is very popular, but uh, I wanna introduce a function calling uh, to guys because RAG is useful for static knowledge data, but when we build a completed system and a production grade system, we have a lot of things to do, like real-time data retrieval, real-time request data processing, and interacting with external APIs. So function calling make a great way to meet these requirements. And the next page. But but when developers implementing function calling, it's very difficult. First of all, like OpenAI GPT model, if you wanna put your APIs connected to GPT model, you have to write code like this. Say there are two functions built as tools, then put all the tools to the prompt, and then we request the GPT model. I don't think any senior developers want to write code like this, because you have to put all your tool calls to the application code, and you cannot do unit test and evaluation properly. And for next page, we will say Google Gemini function calling is way harder than OpenAI model. And the next page. So we are thinking, can we improve the developers' experience on implementing a function calling? If they can write once, run on any model, that would be easier. And I want to introduce strongly tapped languages to function calling, because Python and Node.js are great languages, but in production environment, we usually use more static tapped languages for more high availability. So let's say an example. If I wanna add a function to OpenAI model, the feature is when user ask a website, I can give the latency measurements of the domain. I read this demo by Go language. This is a common function called a ping. The parameter is a domain, just a string. So I will ping this domain and put the result back to LLM. So LLM can get any website the ping results for me. And the next page. What I do is just to write a function called description and return a string. In this string, I just described how this function do the requirements. I just write, if user asks IP or network latency of a domain, you should return the result of the given domain, and try your best to dissect user's expressions description. The description is the domain of the website. That's all. And in next page, I just implemented the handler function, and in this function, I use context.read LLM arguments to get the arguments given by OpenAI LLM model, and I put the result of the ping by context.read LLM result, then read back to OpenAI. So next page. By this, just about 30 lines of code, I just write my first function calling serverless, and I can run on my own dev machine or deployed to many data centers around the world. And when I ask compare Amazon and Shopify network performance, LLM will infer Amazon.com and Shopify.com to the function calling, and the function calling did the ping command and give the result. So the LLM can answer these questions with my function calling. And next, in UMO, there are two features. One is LLM bridge. For this feature, we built a gateway to many LLM models with popular LLM models like OpenAI, Anthropic, Google Gemini. So developers do not need to change their application code when they want to change to another mode to try the new features. They just change it in the LLM bridge. So their code, their application do not need to change. And the next page, is serverless LLM function calling. We make LLM function calling can be written and collaboration in serverless way. So we can build secure function calling, especially when we want to access private data in our DMZ. So we can decoupling function calling from application services as our infra, and we can manage them DevOps and collaborative development and debugging unit testing, so that we can build a production-ready system by this. And next, is we can build all our LLM bridge and function calling to many data centers at the same time, and the users will automatically be routed to the closest data centers, just like a user from Spain will be routed to German or France data centers. And currently we have 6 data vendors free for developers who want to try VivoGrid and UMO. And next. Okay, that's all. Back to Tom. Thanks.
Thanks, Casey. So last I'm going to show you the one in action. So it's a pre-recorded demo. It's 2 parts. The first part is Shifu integrating devices and in real time. And the second part is the function calling feature. So, what the hell? All right, this one. So, to run Shifu, you need a Kubernetes cluster, which we created using Kind for this demo purposes. So, by creating the cluster, you can see we have all the system services, and also we have just one node that's running on a laptop. And then the architecture looks something like this. So we have an empty cluster, and then we have 3 devices. One is a RDSP camera, the other one is a Siemens PLC, the third one is a LED display using OPC UA protocol. And next, I'm going to deploy Shifu and Ingress. So Ingress is being used for exposing my services to the public so that AI can connect to it. And then the second one is Shifu, which once deployed, you have the capabilities to spin up the device Shifu, which is the digital twin of the device. Yeah, so, and then after that, the cluster looks something like this. Yeah, still, we're not making connections at the moment. And then next, we'll spin up all the digital twins for the devices. And then similarly, it can be done by just one command line. But firstly, we need to create a secret for it. So that's a secret for the IP camera. And then we're going to deploy everything within the device Shifu folder, which is all the manifest files for all the devices. And then lastly, we're going to apply the Ingress configuration that exposes all the devices. So as you can see, we have all 2 devices deployed up and running. And then edge device is Shifu's custom resource definition in Kubernetes. So each physical device will be an edge device here. So after that, your architecture looks something like this. Yeah, so all the twins has been deployed, and then now you can actually interact with the device. So the first device we're going to interact with is the camera. So we just copy this string and put it in our browser. So you can see everything is running. So that's the first device. And then on the left side is the PLC, and the right side is the LED display. And then to control the device or get data from the device, all we need to do is use HTTP post or get. Okay, and now let's do a post to the PLC to turn one of the lights on. So that's one of the output. So you can see it's on, and we can turn it back off. So the light is off. And then we can try modifying the LED display. Same, we're going to use post with the JSON. We can change it to like $39.99. And that's that. All right. So this is the flow of the data. So from the terminal, we have the curl command, which is the HTTP get, and then it enters the ingress, and then enters routed to the corresponding pod, and again within the pod, the curl command gets translated by the driver into an actual PCUA command that gets the data from the device or sets the data in the device. And then the second demo is with function calling. So now we have the cluster set up. We're able to do function calling, but this demo uses OpenAI. We also have one ready that's using YOML, as CC just presented. We'll be giving all the links for those 2 repos in the next slide. So yeah, this is just setting up the OpenAI client for the endpoint and also the API. Then next, I'm going to define my functions. So as you can see here, all the functions calls to the devices are just one line of API calls, basically. So that kind of simplifies your whole IoT development. And then next, we're going to define the tools, which is the description for the function, and also if the function takes the parameters, we're going to describe the parameters and its type and what it does. And then next, we're going to write a function called handler. Basically, when AI returns the function name and its parameters, we have to find a way to handle it. So that's that. So after that, we're able to call GPT to take a picture. So the setup looks something like this. So our function calling services sits outside the cluster, and it's interacting with OpenAI, and the input takes is natural language. And then the first thing I asked OpenAI is, hi, can you tell me what the camera see? And then OpenAI is able to automatically find the suitable API endpoints and call that API. And then it calls the get image function, and then the HTTP route goes into ingress and then turns into RTSP. So we have an image. And then next, I'm going to pass the image back to the chat. Basically, I'm trying to ask, can you tell me what's in the image? Specifically, what is the number on this display? And then does the PLC has 4 output lights on? Now, this is important because we're going to use this context to do our next function call. So we're going to run this. So it's going to take some time. And then the first return is the display shows the number 3999, which is correct. And then the second one is the PLC has 1 green light illuminated, indicating that it is on, but I can't confirm if all 4 output lights are on based solely on the image. So that's one of the limitations of the model itself. So we're just going to call it again to see if it can be said about the result. Then after the second call, still for the PLC, it appears that only 1 light is on, so that's good. And we're going to use this into our next chat. So next, I'm going to ask AI to increase the LED display number by 5. So we're going to pass the image into OpenAI, and OpenAI is going to read the image from its GPT-4o model, and then add 5 to the number, and call the relative function with the correct parameters. So in this case, it sets number and then turn into 4004. And then the next one is PLC output. So the message is, can you set the PLC output to true if it doesn't have 4 output lights on, and off if it does. So this is going to do the same thing. So AI has to kind of think and then understand the image first to make a decision. And it says, since it's off, I'm going to turn everything on. So that's a function called by the AI. And this is the, that's the flow. So this is just a quick demo using OpenAI, but by leveraging YOML and add it into this project, we're actually, we can put everything we define, the Python, the function calls, a call handler into just one app.go, and then run it using YOML so that it will be LLM agnostic. So everything you define can be used by either OpenAI, Gemini, Anthropic, or even Code. I don't know. So yeah, that's the demo. And then lastly, we have put on some resources. So if you're interested, we have the InfiniEdge AI project, Shifu project, YOML project everywhere. And also all the demo files we've used will be available through these links. So yes, that's it. Thanks, everyone. Questions? Like around here. Go ahead.
You have to have an IoT device with the Linux, is that right? You can do more than Linux. For example, ESP32 is smaller than that.
Are you asking about people or the device?
So what I see is you deploy a Cupertino node for the system. I think these need to be a Linux system, right? There's nothing lower than Linux.
Yeah, but we don't deploy on IoT devices themselves. We deploy on the far edge node or edge node. Yeah. So where it could be a Raspberry Pi that connects to a sensor.
But also some sensor has a microsystem.
Yeah, which is those we can't install anything on.
So the lowest level, if you have to have
Linux or Kubernetes runtime to operate.
So you don't really need a driver for local IoT device, right? You just send the command over, right?
Yeah, so the driver will be embedded inside Shifu, so it is able to communicate with the devices using their native protocol or language, but you still need the driver. But the driver can be anything, any language, as long as it's containerized. We actually have a tool for generating drivers, but it's not released yet. Yeah. It's lunchtime.
I was gonna ask a question. I got a call. From the dentist. No, this is previously. Like, because I saw CC just use the strawberry. The newest, was wondering how is it? Is that fresh? Like it's much faster, 21 seconds.
So it's slower. It's slower. It's actually slower.
Slower? Okay,
Because
so
it has
we
to
have a
think.
CTO from the gaming company sitting on the last row. Anthony, you probably have a say. I see the OpenAI latest version model today. It says you can make a game in 21 seconds. Do you think it's actually true?
I don't know, I'm also, looking into the news.
Okay, we can talk about that during the lunch break. Yeah, okay. Awesome. Good thing.
Take this opportunity to grab lunch and connect with fellow attendees.
Okay, it's lunch now. We can try to have some food over there and networking.
Actually, so we'll provide the whole.
Yeah, we have partnership.
Yeah, that's you just.
它上面的如果专门用了。
管理。
Oh, you're asking back home like India. Last name George is very similar.
Strawberry 那家它买的是算是我们的新service，其实就是需要情况下来去做联赛。然后如果
说那个翻版怎么开？
做的是一个他们的 innovation department。然后如果是国内的话，就是要学的思维，然后国际的采购。
support myself, I'm like recent grads from a master's program at UC Davis. And I used to work as a data scientist. I just wanted to learn what's going on in the market, what's going on in the market, like cutting edge.
把自己装上去以后，在美国的话，可能现在都是这样，中国的 model 都是在美国用，美国的 model 不能在中国。这个对，就是就是啊，那不是叫什么？叫什么扣子，对，扣子，然后可以装那个。 是吧？对，反正现在这些东西都是只是把 license 以前是 global 的一些设备，然后它的就在那个上面，晚上的那个然后再可能自己的模型。
Yeah. You would find me, you would find 5 other people. So, but I won't be the first, I'll be like the third or fourth one or something. No way you do that. I didn't tell anybody else. I'm like, give me a little apprehensive. I know. Yeah. Yeah, it's good. Yeah. It's good. They'll show me the first like top 5 young. A lot of it, like, as soon as you just think of it, you will show up. Yeah, only the other that we got cheated or yeah.
说你随便一个人啥都不会抠你，你能做，但是多半没有任何抠你。他出来
因为你
没有念老这个说是吧？说实话，昨天我也出来的话，我也搞不太明白。你要写他那个 basic 感觉发展之前对不对？
So I was talking about where basically building
knowledge， 就是相当于你这个有些 database 可以帮助你。OK， 我之前有一个朋友，我们去年。搜个几十遍的资讯，他美国打药现在全球因为打药。
I mean, please, I can't get to Pearl. The node is there, and the node is there. The node radius is like 2 meters.
现在大规模很少，我觉得就是
它这个 cost 比较高，是吧？
它的不一定啊，它可以用一个大的加能力，
就是写的 code
小的时候他们出来就是看设备供应商嘛，对他如果有限连的，那就限购；没限有 WiFi。
Yeah, I'm also really grateful because I mean,
他不管呀，但是他用户提供方案，
I had like a couple of years
有一套就是网线，
so I'm looking at the business for
他不去管这里，
我发现是
套的好坏。
这个人变得容易好久了。让你我说快我说也，他的3.5
我们的字就这么大了，
就是要slow啊，就是里面的人学过
它是一套整个包括它那个
直接靠 slow 和 slow mini 是吧？包括 cost 也不高。当然我们做的不像所有说的。
现在也支持 WiFi 的那个。
那是，那如果只是合同上是呢？
还有就是比如说就是它在另外一台设备上，在它这个上面也能够感受到这个设备点上。
Yeah, so that was like the highlight reel. You have memory.
他这个刚才讲的不断的干这个都是钱。
So and then I'm希腊城邦一样，对，希腊一个小城邦。So I learned myself and feel like yeah,
user
这个 memory 是吧？它可以 across different things。你可以在里边说你有 memory，
它应该是方案，
有的时候我就很惊讶，我今天跟他说的是，
你可以选择 Raspberry Pi，
后来发现你有个 memory， 如果你把 memory 写的话，你可以用这个方法学的。
Yeah, that's
The idea is that you're supposed to make that.
就如果你是个成人啊，那你要在什么游戏或者用的，那你没有的话，我们
那咋办呢？这个在用户端20块钱那个，然后生成完了以后再上传到我们系统里，有这样样，然后在动态。
Yeah.
而且你看它改成了那个那边有人都被审视的，就它是提供的办法，对对对，看起来
That's not just for this, but for like, yeah. I go to school or.
Yeah. 或者按照他的，
我觉得他绝对正常。
但是就以我的经验来看，对于这个交的钱一个少啊，
你说你刚才说
对，偶尔要去做，那可能会看你要不要招不招人。
And that veggie is
This is only one.
I'm sure like this.
This one is
Yeah.
10块钱20块钱。
Yeah. I got mine from here. I think all these are the same. Chicken.
流量是都不入底的。
你想想，就像你说的是吧？它一个东西，一开始说只差一条，一直在等，你想想这是
越聊越大。
actually nothing, but so I don't know how it started. Small database. We were in the 3D scanning space.
像那个他就是这样，他们实际上将来要做那个 A 是都叫他要做那个4号，后来说所以说他们要如果有1000万，如果没1000万，
那我们在这里啊
，OK，
搞完这小
哦，没问题没问题，他们现在就是 rap，就是说放一个 database 中，把你的 knowledge 放在，然后就是我们先跟他讲了一个通过 rap， 大致搜索，在我这里 knowledge 可能我们这样。
Yeah,
扔到大模型，
I'll read AI.
大模型搞，
I'll read AI.
这个就是就像 one shot
File read. It's like we're reading files. Yeah, yeah.
但是呢，
哦，
这种地方，想想这个GPT 就是非常有智慧。
It's getting a lot bigger. So I'm sure I know all the
没脑，那么你跟他讲的时候，你就先跟他讲个问题，和那个 domain knowledge 一块儿的紧。Chicken wrap.
Yeah.
These are both chicken wrap, right?
There's a mix.
Mix, right?
Yeah.
Some
veggie discovery.
All veggie. Oh, you mean some veggie?
I think so. Gain insights from them.
That's what I told him to do anyway.
Okay.
Not really. Well, actually, so like that's kind of the space we're trying to move into now because we have all the data now. So now it's kind of going into like what story are you trying to tell? How can we best?
然后没有人多花钱来知道做的。
Yeah.
Recently at an AWS, and I guess a couple of days back. So there's an AWS event. I met so I met the CDO. So I guess that's like the same.
Yeah.
但是这个是慢，我最近有个经验，就是想让我做3.5的时候，
Oh, it sounds like a B2B model. So our thing is we are client service. For kind of boutique.
3到5年就想。
Yeah. We have some large clients, but our main kind of smaller. Right, right. They're kind of their biggest edge of competing against the big guys is kind of how can I more efficiently do this without. With bigger firms these days, it's like they're really laser focused on the billable hours. So when you actually get AI, it's like yeah. So the thing is, like, if they're not doing the manual work anymore, then their billable hours goes down, and they're like, you know what, I'm losing money by doing yeah, something that's why like large firms, some of them don't actually like the product. It's like you're making our work faster, but we don't want that. Yeah, exactly. But there's a little bit of politics in there.
他怎么说这两号？你这个 AI 有一道很多的。
Yeah. That's kind of our angle now. Is kind of like we can accomplish more in the same time, and you can take on more.
接触谷歌要目标内部人或者。
It's a subscription. I mean, our pricing model is a subscription. They pay per year, and then they have a quota of the number of documents.
在国内之前那个现在实在的时候，其实都是受不了的。
其实怎么说呢？我也是
PPT 或者放在妈妈3。
对呀，啊，I'm not an engineer. I'll tell product that. They kind of focus on their acquisition. Yeah.
I'm kind of curious though, like,
What you saw?
On building a RAG pipeline using the AWS Bedrock. And you know that last 6 years Yeah, AWS Bedrock essentially has all the Python foundation models, which are directly posted. So we had access to. So we had this particular
这是我问你的，
document that we had to upload
Raspberry Pi，
stored into the Elastic vector database and like
那个最少最土的是什么？是 Raspberry Pi One 吗 ？Zero。
Yeah. We're looking into using Sonnet now because our previous product was and then now like yeah.
I didn't get enough. I had a chance to like learn a lot.
Kubernetes 的话，它跑不了一些调啊，然后号的一些 orchestration 的
It's pretty interesting. Like we had to kind of our main problem is actually the vector database structure. So like you ever heard of Qdron before or Python? Yeah. So our current setup was on Python. They kind of have some. I think they have a little shaky business going on. They're trying to like slack their engineers because they're
Okay.
So they have that default switch on. So you actually cannot disable product line. Which is a little suspicious already. But then we started like talking to the engineers like, hey, can we pull that off because it was causing issues. Yeah. And then they're like, no. I was like, what? And then he was kind of like digging deeper into like the guy who's working deeper into what's going on there. And it's like there seemed to be some fabrication. I don't want to say too much. Just say we're not really going to be using Python. It's this open source solution called Python.
Oh wow.
就是你把这个东西变成了一个 virtual。
It's like it's all maintained by like one man, like one man army, but it works. That's the thing.
然后我就看了，
He's always like kind of like 3 a.m. he's replying. This guy.
service 加这种 subscription 那种 SaaS。
I don't know. I'm not trying.
Elastic has been around in the market.
Yeah.
That's what I'm saying.
Integration 实际上它跑的都在 on-prem。
Yeah. It's kind of one of the benefits of that. I don't think I've looked at
But you know so much because I myself got into that I was writing and so like meaning of this, I do it myself, so I guess because there's a whole competition for like vector databases going on.
Yeah.
这个 system 跟硬件没有关系，跟那个说，我一直经常有个问题就是 WiFi 跟 HTTP 这些 IoT 里边，Raspberry Pi，ESP 设计这些 IoT 是不是？这些 connection wireless connection 一旦 congestion 进来是吧？这个不管。
I mean, it's after all.
Yeah. It's not the
Yeah. So that's what
yeah, it's like a
research project and production.
Are no very different. I know that's like half our work is just like I read a new research paper. I was like, oh, we should try it. So they try to reproduce it. Doesn't work. It's like man.
So I'm just curious about like sense of how maybe like right now.
然后余下的事情
still generating error.
Oh, like yeah. I mean, so like our model is specifically for like we have a very low number of contracts. Because it's law firms, right? So these guys are paying like 6 to 7 figure contracts. No, it's crazy because it's like B2B, right? So like they index themselves like millions, like $7 to $8 million. Basically, the way the product is like you have different workspaces, which is the same as a base. I'm working on a case, then I create a workspace in our product, and then I upload all the documents. That's all indexed into the it's all like that. And then we basically like periodic test our DevOps team's working on a lot of like that's all like not going into that. 'Cause it's not necessarily my area of expertise. Oh yeah, you want to ask for performance? Yeah, it's consistent. It works. Thing is, like, I mean, the legal field is where you can actually test it because if one thing goes wrong, that's all. It's all. There's this lawyer guy in New York, and he used ChatGPT for one of his cases. He got hallucinated, so it was wrong, and the judge was like, "I don't recognize this case." He looks it up; it's fake. He gets sanctioned. Very big issue. When it goes wrong. Yeah, big news. This has a problem for our clients because they were like, "All right, I don't want to use this." Yeah, overall pretty consistent, like with the terms of like really high recall F1, like 80 and 90%. Yeah. There's a reason why everyone's hopping on. It's pretty good.
Actually, I was a little more.
Yeah, like the last class.
But then again, yeah, at the end of the day, you're not.
Yeah. It's not like it's harder to scale. We have like millions of documents. New documents coming every day. You get a discovery. That's why RAG is like it's static data. And like you don't all understand here. So do anything on the data. Just reading, then RAG is RAG. That's kind of the good use case. That's kind of the project I was working on for the team was on like citations. Like how do you get legal models to cite source pages, the documents. That's kind of had to like do this kind of like back tracing. Actually, I'm talking about this thing tomorrow. Yeah. It's not directly with the work I'm doing here, but it's and we use the similar idea of back tracing. It'll be in the slides.
所有的语言都是 example。对，语言环境来说，自动就是 CPU， 386它这个。
Yeah, it's not really good.
What if you're calling?
Even if I didn't I had a speaker in my tomorrow, but I didn't hit the register thing, right? I showed up here and they like.
So I just recently what could this builder be in charge of you?
Yeah.
比如说浏览器里面我们肯定浏览他这样去做那个他这样就跟 Java 一个有界面有
Yeah, it's might be like more recommendation focused. Or is that
not even recommendation? 类似的东西，它放在浏览器里面，或者它放 Node.js， 放在 App 放在，然后当然增加其他的功能，它不一样，产品上的这种，就像情感库的 Docker， 对，就说因为 Docker 就是今天的 Docker Desktop 变成 model Docker，
Yeah.
它能采用一个
It doesn't have to be complex. It's actually worse.
So it is more like using reporting and then optimization.
Yeah.
未来这不是通信未来也
性能不太少，然后开发也简单。
轻的太重，就是在 Docker
多简单，多点你会写 TS 吗？
它这里
对啊
上的非常的就是这个而且启动特别慢，不是你要查一个
We're a consultant. We're a consultant.
然后另外一个大一个专业用因为自动合约你就表这个2人提前到24每个都是要
Oh yeah. Oh, nice to meet you. I know you're talking on Slack.
下面的就我们做了很大一件事情，是我们把下面的一些
ESP32 这些都能哦，是吗？这个你还挺牛的。
索尼
I wear Stanford
索尼有一些
Yeah.
照相机，
然后从就是
Yeah,
web 是一个那个 web server 这种，
那应
该也可以吧。web 商店因为它是一个，它其实是个虚拟经营，它的所以说你可以每个 network 也可以做它的
I don't know. It's probably much older than me.
这样的话，你要么就是直接用根线给它 connect。所以这个你如果要装稍微复杂一点的内存就比较是吧？所以你说你这个东西能够装起来。
Oh, so he's probably 1 year below me. I like to be graduated from Stanford.
上面这个因为你可以把那个日期和那个帮你审核，把 AI 或者之类的就大概20-30人民币，对吧？它在 small device 上面。
你可以上一兆呀。哇 I just want to check out this. 因为这个 ESP32的话，2兆、4兆、8兆，当然它也但是你如果越做小的话，其实这些 device 越便宜。对呀，这个来说，看见了。不知道为什么在
Oh no way.
So you want in the daytime?
决定，比如说你相机是在300天，自己现在就
像这些 ESP 设备，有些这个它已经有 WiFi 口的话，就是它的已经可以有点大，可以到外面直接无线。是的。
对，你都带 WiFi 的，对吧？
啊，就是它有不同的赛，是吧？比如说，我们最近看一款叫小系列，是吧？它就叫 CSMD，就它这个东西很没有。然后呢，它最近的就是 C6 C6 里边的话，它的小系列只有2兆是正常，所以我们说，哎，我们可以放一个 web server 在里面。所以我就在让那个 engineer 去试一试，是吧？但是他说呢，比如说，我们是做教育的，就说，哎，我可以放一个 block 有一个那个小朋友的网，直接口头评论，然后我说，加的东西太多了。所以这个就是这个事情，因为是吧？它这个 ESP32是吧？它有2兆、4兆、6、8兆，然后这个一直上去，但是呢，它越上去，它一般的版本就越大。对于我们来说，会越小。这么连接版越小的话，作为一个module，
都到 module。
对，我们可以把它放这个，因为是这样的。我们讲一个问题，就是一些 IoT 对吧？我在 Office 里做的 ，nothing wrong，Raspberry Pi 啊，全都挺好。然后你跑到教室里是吧 ？Everything is wrong。然后我觉得这个大概那么我就要去找这个 device 有没有黑的，稍微强一点。
要 worry。
对，这个东西，哎，我做的挺好的，真的，教室里全都。
那个有尝试核心的这种 WiFi 系列，
你去看 IoT 来，没有5兆。都是2.4因为我也想了 ，great， easy， 人人都告诉我2.4G， 带宽带是不是？这个太高了。去看 IoT
为什么呢？因为2.4那个稍微远一点，它也是正在努力 device， 但是比较稍微远。或者呢，可能就到 Aura， 但是 Aura 呢，这个给我看 delay 以应用场景有关系，比如说 IoT， 就家里面就有一套东西，也没什么。突然跟一个教室里面所有小朋友都在用计算机，WiFi 情况很复杂。
对啊，这个教室里面有好多。
你想一想计算机嘛，你想想一个课堂里面，30个小朋友同时在用那个。真是好像2个小时吧，就是我也
但是我好奇这种，因为像互联网这边的这种 WiFi 的问题，很多年了，问题没有人处理新的技术。
A lot of the international customers didn't care. They did have all their data centers hosted. Most of the international companies, that was good enough. Pleasure hearing you. I love your address. I was just learning about.
No. Yeah, we're up there and then here for college. Yeah. I mean, it is, but like not. That's more well known. It is there. Like, I lived nearby. To go there. I didn't want to go there. It was too close. Oh, I got in there. Yeah. I just like I didn't want to go.
Really good experience.
I was like, oh, you should learn how to live by yourself. Send me out here. It's just very different.
I don't know because
and you were from here? Oh, wow. You come here for masters. You finished masters?
Yes.
Yeah, like grinding a lot. You got the Davis, right? Oh, they have that some like agricultural lab there. That's what it's AgML. I know a friend that works there. That's hopeful. Yeah. You've been an asset all the time. You're like, I've been here my whole life. Now it's time to go graduate in some random city I've never been to. How's the job search? Really? I don't think I even passed their way, man. I was. Yeah, it's the on-site, right? They basically go there like 4 hours of interviews, like that's normal, yeah. Oh, it's Virginia, right? It's Virginia. I did that today. No, you know Palantir? Yeah. I have their on-site interview today. I didn't know I was gonna come here until I got the invite, and I was like, okay, I can't tell them to move the interview now. So now it's I have to do it in Eastern time interview here. I did it at 7 a.m. 7 a.m. to 10 a.m. that I came here. That's pretty good. Yeah, yeah. I mean, I'm not going for full time. I'm gonna keep going. I'm trying to figure out what I want to intern in. I've been in this company the last 2 years. Yeah, it's like AI slash intelligence. It's like their big thing is like they're all intelligence companies.
But I don't think going.
They're a big data company, but they started out as a big contractor.
Yeah, that's kind of small. But it's what it can
So some of the stuff is questionable.
areas that are gonna have like.
You just do the work. You don't look at what you're doing.
这就适配它的生产嘛，因为那个生产的东西一样的呀，
The
一个
idea
技
was
能都是
like,
被抓起来的。
so is the Department of Commerce.
把那个刷新上来。
How easy the I was working on that.
Like government connections?
Oh, you guys are like.
They can't do a migration.
I had to do the migration.
Oh, you did the migration.
Such a pain.
Oh no. This didn't help. Yeah. My DevOps guy in our company said like the migrations are. We did that AWS to Azure migration. We don't do I think that the cost is definitely one thing. I think the costs were pretty similar. That's also like the support was a lot better. Like we get our dedicated support engineer. Like there's like one guy who's like whenever we call, he'll answer and he'll join a meeting. I don't know. I mean, I hope he's not just for us. Like I'm getting paid like 150 grand just to sit and wait until we call. I don't know what else a dedicated support engineer means. Yeah. Right. Yeah. Not very It's kind of surprised. Like there's one. I hope I'm understanding it wrong. There's not one guy whose job is to. I mean, he answered every time we called. Yeah. So I assume that he has like 2 or 3 other people that he's watching. Like, you know, he's just sitting there waiting for us to go. Yeah, the support team was very useful. They also have like really good integrations, like the you guys have big things was like authentication. Like they have this thing called Azure Enter ID. It's like very good B2B authentication. Integrates very well. Yeah, I mean Active Directory, like it became Enter ID. They integrated both together. I think it's all. I'm pretty sure. Yeah, you gotta catch up on the Azure stuff. Yeah. I mean, some of the documentation I was reading still has Active Directory. It's the
Understand how you naturally do it.
It's hard. Maybe harder for you. I'm going for internships.
Challenge.
Are you on like OPT or something? Oh, I see. Oh, that's even worse. 因为那个因为是很老的，
对，那 Quest Pro 也很贵。
对，刚好 the same boat as you. He went to Chicago for a master's. He's trying to figure out how to find a job from the OPT. The clock is good.
后妈买嘛，后来他现在不行，现在不行嘛，对吧？对啊，就是
NBC funding like
没有，当然没有。
$1 million and sponsor your own visa, then you're done.
So Palantir does all these
它这个东西是吧？就特别像那个3个球的是吧？它已经做好了，只是你的 software change。我们做给他的就是说，我给你就用 Raspberry Pi， 你就把它变成。
Well, their CEO.
做完以后，但是还发现肯定的，他做了一些，而且是 generic， 因为你如果只是你让他拍它动啊，或者说动一动啊，这些东西他就觉得都是有意思的。这就是说 the difference between one is the education there's a difference。
不要搞到什么 WiFi
我们有一个然后很多小朋友你想象的更我们是从这儿，所以我们要一个 network 最后要把所有东西。
We're like the one-man army there, like you build, deploy.
Yeah. 这个故事就完全高明了。那像 iPhone 的时候，他就说那我就走一步前，现在也每人每年当时所有人都说，这他妈就是个系统。是，能把这事做成，花费现在1年2亿。
所有赚钱，
给包了1年。
就2亿，
所以当时他
看着我也是看这边的，我也
那时候大家都觉得这是傻逼想法。
现在到2亿美金。做过
卖不出去做出力，对，体验一下。然后
做到2亿，
那的确是蛮多用的。他个人的，他个人的。More people, they're all just at the same level. It's scary. It's 线上一般都可以买 HCI 对，到线上不可能。
So in our
That was
we
actually
had
the early origin.
advisor going on. One of our faculty advisors was like I was talking about the other way. So one of our top team had a faculty who was like a really big. And he was able to essentially guide them what exactly we were doing. He was a guy, they wanted to like do their build your own vehicle. And we were essentially looking at the whole customer journey.
因为你要知道，我给你这个东西有的，
Whereas it was debate, like why solutions to something was
We'll give you what it is right now.
yeah. So we had to come up with solutions for that. I could essentially guide those guys on it.
Personally, their team.
I wasn't on it. Sorry.
They have people in non-shop, they know it.
Oh, 我一个 robot 是吧
Yeah, I live in San Francisco.
That sounds like every Saturday basic. You know, it starts with Tuesday. Find the raspberry.
So even like starting from a lot of people that yeah,
这些东西呢，而且真的是
Oh, price. I think the price says like.
店员做对了是吧？
Yeah.
大致线差不了3根线。
It's like different. We have different tracks. It's like it's the biggest college hackathon in the US. Yeah. It's like healthcare, education, AI. There's like different tracks. And each track has a business that they want something out of it. Like hey, this year's healthcare challenge is like I want you to build a allocation software to handle an allocation problem how we send our drugs. Last year was yeah, it was like the British National Health Service. They were like, oh, we have some problem. We should... No, if you were in masters, you could have come to me. That is undergrad, masters, PhD. You can. I was organizing it. I said, yeah. I wasn't here. I flew in yesterday. Okay.
No level.
I asked that guy, hey, can I come? Because I didn't register.
对，那我其实我刚想问，就是记录过一下。Oh, okay, you didn't come.
So I'm sure like they won't allow me inside.
Okay, honestly, I think I would though. 谁在北岸是有开放的 But I was here today, like they didn't really check my name. Yeah, they didn't ask for any. They first like signing here. Yeah, but I didn't register in the link. No. No, I'm speaking. I don't know if they actually.
Raspberry Pi, ES32 这些东西就是学会了以后，哦，就是这样，这个 Raspberry Pi，哦，这个 I/O 是吧？你可以做一个这些小的 program， 那里面现在 program 都是 microprogramming， 都很好学。学到这儿，你下个地方拿一个 Raspberry Pi， 我还可以做别的分析。 然后呢，这样的话就
looking for
去买一个玩具，一般他们有一个他们给你一个 WiFi 给你一个 block， 然后你这个东西下单，
骑 run great， 然后你换了一个你知道这个 yoga， 而且这就是我发现对 education 也是一样，还有一个就是腾讯对吧？它也可以编程，好像飞起来这个不太好算，我也看，但是在美国都买不到。然后上面就几个模块起飞，向左走，向右走，这些东西是很复杂，但是你的小孩学到了啥？你换了一个东西，你能跟他说起飞，他就起飞了吗？他不飞啊！我要我小孩说。因为 Bay Area 太多，所以他们很小。我就他是although my stuff is not hey, make sure you learn something. Yeah, 我要做的事情，我就告诉他怎么做。里面那个 PID 是怎么用的？教他这个，比如说哦，如果是这几个，你写个字这也要比他我还更难一点，因为现在很多这些会，跟你说他是 program。他是把这个整个，比如说 Python 啊，或者是 JS 的这些东西，都 package 成一个 function，
好 high level 的，
对，非常 high level 的 function。但你真的学到啥？然后
但是这个跟小朋友年龄，
对，大家可以这样，这就是
他小孩根本不理解这个，
对，不理解。但是你转过来呢，也就是你今天小的小孩子越 high level， 然后越 high level 呢，因为太 low level 的话，他会 frustrate， 对吧？他会 frustrate。所以这个就说是说，在不同 level 你给他什么样的东西，
some sort of shared standard。
这种东西太多了，机器投票对话跟你说。
桌面上那个我前一个方面，我就是桌面其实这几年很多工作是
它就是四个非常的 program， 让某个问题贵的贵。
没有，现在价格都打开了。中国一搞四合院这种关节专业都下来了
200块钱。所以我就觉得这个东西，如果你把它做对的话，关键是你要把这个东西变成写的东西，不是说只是说小的时候也是，肯定也是从这个东西是吧？希望是加水，是吧？就是对小朋友来说，我比赛是一个 away show， 有点但是我们的比赛跟大家去看，不是你看他们是吧？他们是这样。他们是他们的 是吧？他也当然给你 education， rely on others， 像你说的，就是说 educate， 是吧？就是这种 help them to understand。
farmers will be able to have like open source that makes sense. It's like very small markets. You can easily where do I have it wrong? I think so it's a way to make the database easier. But he said it's not rack, right? It's a rack. Oh, okay. I just heavy rack, but also. Can be also like information. Keep it on. It's like a community thing that they. Some did it in the past, like hey, Kubernetes Eagle, right? So many open source.
不是，是 weekly 在右手。搜一个，对，搜出来。
Like they put a lot of money.
我说的是，我从6月，但真正我们也是有，对，我们也是。对于一个小孩来说，你要来1个星期、2个星期，随便你，最多2个星期，最多到3个星期。对。他想做就一点。
哦，就拿了放，
哦，那个是叫大。人家是老的，已经做了很多年的，对，就在那个
What's going on?
特别贵哦。
Yeah, some kind of like thing where you can have Yeah, you can like make a scan of yourself. I'm not really sure.
比如说，那个比较大的叫什么？
I think it's I'm not sure. Maybe you would know.
他也是教你，但是他一般的啊这些东西是发另外比如说，我们是说每个小朋友都有一个电脑，然后讲这样的东西，
Oh, that gave you.
Oh, okay.
还有是，Lima 会在Lima 但是这个一点，这个successful translation 交流因为那个我也上，这个东西我其实没做事。
I'm just going to school, so I'm
what technically what I do, what's the
I'm so glad to see you are here. Thank you for supporting.
因为我每年都
Pictures of me.
跟着 trend 说今年 AI 明年我要查的
It's hard to narrow.
我知道。
感谢各位支持。
No AI, I've seen them. Yeah.
对于小孩来说，今年可以了，明年再来。我们 return student 还是
There's a
类似准备。 而且你也希望有一个这就是我们你就觉得哎呀，这好像是我上班做的事情。
AI 真的有时候是可以。
我告诉你，他的经验是吧？
So under the house things like I mean like probably like 3 events on Go or something.
Yeah， 小小朋友这样白纸一样的，想的就是没有 limit。但是高中生呢，你要他是非常精致，但是 idea not necessarily 国内先的话，就是有人他就看到了情况，从国内来对吧？你要数吧。
Like CNN or whatever.
那他们批色去做。
You try it on.
I was there for that.
And I just like I can show the model one. Yeah.
Foundation.
Yeah, it's called.
Actually,
And she goes early, actually. You're going the weekend to EU, right? Are you going to EU this weekend? Then to Europe this weekend?
So like disconnect.
Yeah, you know.
So much. This is why. Oh. I'm very happy with that.
I met Tina. Actually, it turns out
下面的东西是吧？就说不要看这些 device。它就是概念是一样的。
How big a range is it?
这些都是有一个 operation， 这个是 run 它 micro， 它有 driver， 我们就直接用 micro。回去可以用 micro。micro 所有的都是 micro 就可以在像 Pickle 这样的放一个知道了，然后要知道呢。跟他聊过呀。不是，因为他已经开了个道的，但是呢，他的这个语言啊，是完全不一样。回头来做下你指教啊。从来没听过，所以我。
So I thought learn something new for that. Yeah, it was interesting. It had plateau. Yeah, like you're out of figure out your stuff. So I started at TSD. Yeah. I would say there's two things. Number one, TSD professors are like have a
We'll resume after lunch with Zixu and Zhang from ByteDance, presenting on Auto's an agentic AI application workflow.
Okay. They already running the business.
Sign up for
They gave a link or something.
So you have interviews, essays. Was that? Yeah. Like it's an amazing. If you can do it, you know.
I think the microphone's not working.
Application.
Microphone now?
Okay. Yeah.
So can you guys hear me?
No.
Can you hear us?
I don't have like.
Can you hear Zixuan?
Well, that's probably okay.
Let me get your.
He already texted you, it's in the closet. You never found it? It says in the closet. He texts you the group, the event group. It's right here. You never follow his instruction.
Yeah.
It's already charged, and I say it's like a, it's there. You say you want 2 months, and he says it's here.
Okay, so let's get started. My name is Stefan. So today I'm gonna talk about our AutoSAFE project, which is agentic AI application workflow. Here's my agenda. I want to go through the sections one by one. So I will first to do a self-introduction, and then after that, I would like to talk about the rationale for building our AutoSC, like what I would like to invest for our project. And then after that, I want to do a comparison between the GitHub Copilot as well as our AutoSC. Then after that, I would like to introduce our features as well as some other key highlights. Then last but not least, I want to introduce understanding in the assembly based leaderboard, and then I will also do another comparison between the assembly agent as well as our AutoSC. So let's get started. My name is Sean, and I'm a software development engineer at Day1, focusing on cloud AI infrastructure area. And I have been actively working in the design and development of cloud infrastructure system. And also, my recent work includes a service designed to enhance the resource management of cloud infrastructure, resulting in significant improvements in both resource efficiency as well as operational efficiency. And also, our team is dedicated to building cutting-edge AI infrastructure that powers innovative solutions across various domains. And also, we're also focusing on creating scalable, reliable, and also efficient systems that enable seamless integration of AI technologies into the existing workflows. Then you guys may be curious about what is AutoSC. So AutoSC, which stands for Automated Software Engineering, which is the AI agent-based service that automates various software development activities. And also, it is designed to seamlessly tackle the complicated software tasks across different stages of software development lifestyle, including the coding, design, and testing, as well as the operation. And also, by leveraging the cutting-edge LLM and AI and the AI agent technology, our AutoSC aims to provide more effective solutions to these challenges. And also, other than that, I would like to mention that we are integrated with the fourth branch of assembly agent. So, since our AutoSC is an agentic AI application workflow support system, actions plays a really important role in our project. And also, we have already made several enhancements to the assembly agent by adding a lot of different actions. And other than that, I want to state that we're still in the process of open sourcing it, so we'll definitely like the community to know when we're ready. Okay, so here's the next part. So in this part, I would like to talk about the rationale for building our AutoSC, like why we would like to invest in this project. So the first question is gonna be, why do we pursue the project at the application level? As we all know that the LLM technology is rapidly evolving, and not just at the model and the infrastructure level, but also in the application layer. In order to stay at the forefront of the innovation, we aim to launch a research project focusing on exploring the core technologies behind LLM applications and AI agents. And also, the other thing is that our S department has always been interested in expanding beyond the traditional S project portfolio and also seek the new growth opportunities. So our project represents a step towards discovering these opportunities. The second question is, why did we choose LLM applications for software engineering? So as you all know that the LLM applications span numerous fields, including healthcare, legal, education, e-commerce, as well as software engineering. However, given our current customer base and expertise, software engineering is the most practical area for us to explore. By focusing on software engineering, we can self-validate functionality in our daily work and also provide fast, actionable feedback. More than that, our S department is keen to leverage LLM technology to enhance R&D productivity. While there's a significant buzz around code agents may somehow replace our engineers, this project will definitely help us critically access how practical and impactful these technologies truly are. And then other than that, we still have some other motivations for building our ISC. First of all, we aim to address the specific challenges we face in our own software engineering workflows. We are current tools and process flowchart in optimizing the automation and also the team collaboration. And also by building a robust and the smart system, we would like to improve our development, reduce the repetitive tasks, and also create some solutions that are falling tuned to our unique needs. Other than that, as part of our broader AI initiative, we are committed to exploring the potential of AI agents, the design pattern of that. We would like to discover more ways to revolutionize our software engineering by automating the complicated workflow and also to improve other decision making, and also we can drive the future of AI powered development. Then last but not least, we are always pursuing the opportunities to cooperate and build and share our expertise with our open source community. Then other than that, I would also like to mention that we really hope our AutoSC can truly help the software engineering task, and our developer can actually use our AutoSC in their day-to-day work. Since there's a lot of hype in this area, so we definitely do not want to make another half of that. And we really want to deliver practical and also useful features of that. And also from the technical depth perspective, our focus is more on the AI agent layer, and instead of just being a wrapper of that for any existing LLM or any open source agent. Yeah. Okay, so in this part, I want to do a comparison between the GitHub Copilot and as well as our AutoSC. So you guys may ask, what is GitHub Copilot? So GitHub Copilot is an AI-powered coding assistant developed by GitHub in collaboration with OpenAI, which can definitely help you to write code more faster and with less effort, which can also allow you to focus more energy and problem solving and collaboration. And also, the GitHub Copilot is integrated into many popular code editors like Visual Studio Code. So basically, it has a lot of features. And so for example, like you can just get code suggestions as you type in your IDE, And you can also chat with Copilot to ask for help with your code. And you can also ask Copilot to help you with the command line. And you can also generate a description of changes in the pull request. And also, last but not least, you can also create and manage collections of the documentation and also use it as a context for chatting with Copilot. The more important thing that I want to highlight here is that GitHub Copilot often operates in a one-shot manner, which basically means that it can only generate a single complete suggestions based on minimal input from the user. So how does our AutoIC act differently from that? So in comparison with the one-shot service such as the GitHub Copilot, our AutoIC is a more comprehensive agentic AI application workflow system that can support complicated workflow orchestration, planning, and appropriate tooling usage. And other than that, our whole flow process follows the React pattern, and also it can have the human interaction as part of the workflow. And the more important thing is that it can operate iterative interaction rather than the one-shot interaction. So what does this mean? So basically, it can engage in multiple rounds of communication to progressively refine the output, like by processing each round of feedback and also sending back to the model. It can make more improvements step by step, and also it can generate more accurate output. And also, beyond all that, we also have more features and highlights. So let's check it out. Okay, so if you have the command line of AutoIC space dash help, it will just show you the possible command that you can use. So for example, you have the link command, which can help you to link the file. And you also have the def command. That means that if you provide a description, it can just write a patch for you. And for the help command, it can basically give you some suggestions for the comments that you're available to use. Okay. This is the first feature that I would like to introduce. It is called link. So basically, it can just scan a code file or a Git diff to identify potential code problems, which means it can offer suggestions and potential fix for the problem. So how does this work? We actually have two different modes. As you can see here, I already pasted the last here. So for the file mode, if you do AutoIC space link space your file name, it just can scan your code and then to help you to identify all the potential problems in this file. So I have an example here to show how it works. As I just mentioned, the command line is AutoIC space link space your file name. So in this case, it's the guest city itinerary. This one is a script that will print out the city itinerary based on the user's request, like what specific city that they would like to visit and how many days that they would like to stay. So the potential output of this one could be something like, in the morning, we would like to visit the Eiffel Tower in Paris for day one. And also in the afternoon, we would like to have afternoon tea in Paris for day one. And also in the night, we would like to have a fancy dinner with our family members for day one. So what's the problem in this one? As you can see, the output in the first line, it already identifies the potential risk in this code. Days in the range 1 to days plus 1. And also in the second line is describe the reason of that. So basically in this case, it's saying that there is a risk of days starting from 1, but risk starts from 0. It should be from 0 to days. So what does this mean? So based on the original code is just iterate from 1 to days plus 1. So the output may be something like morning activities in the specific for day 1 plus 1, which is 2. And also in the afternoon, it may be something like we have the afternoon activities in Paris for day 2, and also in night, we have the night activities in a specific city for day 2 as well. So how did it fix this? You can see here is this change of for loop into for day in range days. So it means that it will just generate the potential output, something like we have the morning activities in a specific city for day 1, and also we have the afternoon activities in a specific city for day 1, and also we have the night activities for a specific city for day 1. Yeah, so this is how it looks like. So let's back to the last slide to talk about the other mode. Other than the file mode, we also have another mode called div mode. And then we have 2 options of that. So if you want to scan a git div to find the potential problems in your code in a specific file, you can do the single file git div mode. So basically you can type something like auto-se space link space -div -mode, and also you need to have your file name in the end. So it will find all the potential problems in this file. And other than that, if you just want to do a project mode, which means if this command is executed in a git manage directory, it will just check all the potential issues in the div in this directory. So in this case, you can just do auto-se space link space -div -mode and make sure you do not have your file name at the end. The output of this mode is very similar to the previous one. And if you want to scan code in the whole directory, you may have more blocks similar to this one, because that will just identify all the potential risks inside the directory that you specify. Okay, let's talk about the second feature, which is called live. So this means that given a local task descriptor file, it can just help you to generate a local git patch for the specific task. I also prepared a command line for you guys. So in this case, you can just do auto-se space div space the file name, and then you need to make sure the file is in so the type of the file should be a YAML file. And also I have a example for this one. So this is how the YAML file looks like. So in the first line, you need to have your repo URL, which means the repo that you're gonna working on. And then in the second line, that's the description, which means you can just write down your description, like how would like to do this task. So for example, in this one, so we're going to create a file which name is utils-go.py, and we would like to implement a find function which will basically go through a folder and also have the specific file. So as you can see in the slide that I already attached a screenshot for that. So this is the output. You can see on the first few lines it is saying that it created a details dashboard.py, and also this is the core function in the middle part. So we have a find function which will work through the folder and also find a specific file. And we have the parameter folder, which is the folder that we want to search in. And we have the parameter file name. That means we have the name of the file to find. And also, if we do find the file, we will just return the path of that. If just cannot find it, we will basically return none. The logic of that is also very simple and straightforward. There's a for loop here, so basically we just look through the folder and we just check if the file name is inside the file, and if it does find it, it will just return a path, and if just cannot find it, it will just return none. Yeah, so I think this one is very simple and straightforward, and hopefully you guys can get some sense of that. Yeah. Okay, so other than that, I would like to introduce some other key highlights. The first part is the rich setup actions. So basically, we have already added some new actions for the large language model, which can help you to understand the code more efficiently. So basically, we just made it smart. For example, we have already added commands like search class command, and also search method in class, search method in code base, and also search method in file. And also, we are targeting to add the web search as well as the internal wiki search. And other than that, I want to highlight that we also support running 2 commands in one run, which can definitely save more cost of that. And so I will briefly introduce this one, and I will cover more details of that. So for example, you wanna for example, it wanna search a specific method in file A, and it also wanna search for specific method in file B. So based on the previous design, it may take 2 rounds to finish that, because it needs to search the specific method in file A in one round, and then it may need to search a method in the file B for one round. However, currently we can just support running multiple commands in one round, which basically means that it can finish the searching method in file A as well as searching method in file B in one round, which can just save more cost of that. Yeah, and then I will cover more details about this one later. Yeah, the second part that I want to talk about is the rec support. So basically, it can improve the model ability to retrieve relevant information and also generate more accurate and context-aware response. So basically, we provide the opportunity for the users to upload their documents, and then our response is generated by the retrieved relevant information. Last but not least, I would like to introduce our standing in SWE bench leaderboard. So you guys may curious about like what is the SWE bench? So basically, SWE bench is a benchmarking framework designed to evaluate the performance of the language models in the real-world software engineering task, specifically resolving GitHub issues. And it can test a system's ability to automatically generate the correct code patch by providing issue description alongside the relevant code base. And also more than that, the system is evaluated based on how well it can propose solutions to the issues. And moreover, models such as GPT-4, Cloud, and also some other models have been tested against this benchmark. And also the SW bench can definitely assess the real world applicability for language models in software engineering tasks by comparing their outputs to the actual post-PI state of the repository. Other than that, I want to mention that the dataset contains 2,294 pairs of issues and pull requests from 12 popular Python repositories. To evaluate that, we will use the unit test to check if the code was correctly, using the behavior of the code after the pull request as the correct solution. And also, I also have the screenshot ready for you guys to show the SWE bench leaderboard. There are a few fields in this leaderboard. The first field is the name of the project and also the model you use. And then the second one is the proportion of problems successfully solved. And also the third field is the data that is published, and also it attached some corresponding links at the end. So this is our position on that. So our project is named Abundance Auto SE, which is based on the SW agent, as what I mentioned before. And also we use ChatGPT and also ChatGPT-4o Max, and also the proportion of the problems successfully solved by the model out of the entire data set is around like 20.67%. So basically we're at the middle stage of this leaderboard. Okay. Yeah, so other than that, I would like to do a comparison between our Auto SE and SW agent. So basically, both our Auto SE and SW agent run the same task, and they all pass the task. And also, as you can see in the output, it just print out the calls and also the API calls and some other metrics in them, so we can just very easily to compare them. So we can see for our AutoSE, we have the total cost of 0.48, and also we have only 8 API calls. Comparing with the SWE agent, it just have more cost than that. It had the cost of 0.92, and also it has 15 API calls. So if you just compare the numbers of that, you can have the conclusion that we definitely have lower number of total cost as well as the API cost. So which can prove that we definitely save more cost. So why is that case? I would love to explain more details of that. As I mentioned before, we can just support running multi-commands in one run, which can help to save the cost. So I have a very simple example of this one. So for example, you need to search for So for example, you need to search for the 2 different classes in the code base. And then based on the previous design, if you want to search class for these 2, it definitely takes you 2 rounds to do that. However, in our case, it can just search the 2 class in 1 round. So you can see the screenshot right here. So and other than that, it can just have the output. So for example, you can see the first one is in line 9, and also the second one is in the line 19. So it can also return the true outputs in one run. So basically, it can just also return the true outputs in one run as well. So it can show that we can definitely save more cost on that. Yeah. So I feel like after showing this example, you guys may have some ideas about like why we can save more cost than the SW agent. Yeah. So yeah, I think that's pretty much I have for today, and thank you so much. Yeah.
I'm checking your agenda. Here for 2 minutes. We have 2 minutes.
Yeah,
for
we
Q&A.
have 2 minutes. So if you guys have any comments or any questions so far?
Yeah, so are there any like use cases or anybody outside of guidance?
So we are still typing in our focus on it, so we're still working on that. So probably later we can have a look at that.
Okay, thank you so much.
Thank you guys.
Michael Yuan from Wasmij will then discuss the concept of write once. Run anywhere but for GPUs, which is especially important for infrastructure and architecture at the edge.
MC, Did you submit your slides to the wiki?
Yeah, but I want to do a demo.
Oh, you want a demo? Okay.
Okay. In fact, let me do the.
一个 layer X 这个那种Excellent.
Can I start?
Yeah.
Okay.
All right, so hello everybody. So my name is Michael Yuan, and I'm the creator of this project called WasmEdge. So we are one of the CNCF Linux Foundation projects, and we provide WebAssembly-based runtime. So people keep asking me, why do you start a WebAssembly runtime? That was back in 2019, and I keep telling them that I made most of my money, from the Java days. And back then we had a thing called write once, run anywhere, but it's mostly about operating systems and CPUs. But in the new era of computing, that we have opportunity to do it for the GPUs. So that's what I want to talk about. So there would be a lot of, in fact, there will be a lot of demos and during this talk. So we have I have a GitHub repository that has all the scripts. So if you want to follow along, you can do that. And the goal is really by the end of this talk, that you would have a large language model running on your own device, no matter what device it is. It could be a Linux computer, it could be a Windows, could be Mac, and so you would have a large language model and agent running on your device. So I wrote a couple of computer books in the past, mostly for O'Reilly, Anderson Wesley, Prentice Hall, and all that. So about a year ago, many reached out and they said, Michael, why don't you want to write? Do you want to write a book about large language model LLMs, because we saw your work, you're active in that area. So I thought that may be a good idea, but then I find out there's no way to write an AI book in this day and age, because as soon as you finish, in fact, as soon as you finish a chapter, it's become outdated. So it's impossible to write the book this way. So I told them that I would only write it if that's an ebook. So so that's the outcome. So it's a three-chapter project that actually goes over a lot of the stuff that we talk about today. So enough about advertisement. And so let me start with a claim that is, I think it's somewhat contrarian and maybe unexpected to a lot of people, is that I believe large language models are inherently tightly coupled. Okay, so we have been pursuing this idea of loosely coupled application or microservices for a very long time. I know this is widely used in this company. However, when large language model first come out, it's pretty much follows that line of thinking, because OpenAI provides API. So you write application that talk to the large language model through API. And then there's Anthropic, there's lots of other models. There's open source models where people still use this SaaS paradigm. That's I provide API, and then you have a Python application, or you have some other application that interact with the model through a workflow management or function calling, something like that, right? However, I would argue through a lot of applications that we see, especially local applications and edge applications, that is actually the wrong approach to it, because there are a lot of things today that requires tight coupling between the model and the application itself. So for instance, we have all had this idea, this experience of when OpenAI changed to another model from GPT 3.5 to GPT 4, all your prompts stop working, or a lot of them stop working. When it's introduced the function call, different models has different ways of describing function calls in their return tags. So there's lots of applications that you saw it's running correctly, but it's no longer run correctly when it's changed to another model. And it's also the same for the inference, for the runtime and inference side of things. So say if you use Llama to run Llama 3.1, and then Llama 3.1 had another minor update and change their encoder in some slight format, then your Llama runtime has to update with it. Because if you don't update with it, it would not be able to run the new model. Although the model is the same, the weight, the architecture is 99% similar, but you need a patch to the underlying runtime in order to run it. And this list goes on and on. There's not just the prompt, but how you set up the vector database, how you set up the knowledge, how many dimensions do you have in the vector database? How do you do retrieval? Do you do graph retrieval? How many chunks do you? How do you chunk your knowledge documents? How many chunks do you retrieve? Do you reorder your retrieved chunks? And things like that. Everything is hugely model dependent. Depending on the model capability, that you would require a different way of writing an application. So that's a conversation we also had, just today, is that, we have a lot of applications prototyped on ByteDance, Doubao, models, but then we move it to GPT and then it would stop working. A lot of those workflow prompts would stop generating the answers that we would expect, right? So the solution for that really is, so that leads to the need for write once to anywhere, is that we believe that a lot of those production applications or agent applications would need to be tightly coupled with model, meaning that they are distributed with the model. In a system like a Docker image or a container, that you have the model files that are frozen at some time and has a runtime that's matched to that model and have prompt, have a vector database, have everything else all packaged together so that you can upgrade them together. So there would be no chance, say the model updated and the user downloads a new set of weights, then the application breaks, right? You package everything together and then distribute that through a software package, right? So that's, I think the basic thesis that we have, is that why you need to, have cross-platform model runtime. So in order to keep, illustrate this point, I would do a couple demos. Perhaps the first is the most important. It's actually a very simple demo. So we have the background of this demo is really, a question my son asked me. So he's at the time he was in middle school, so he's interested in chemistry. So he go on ChatGPT and ask, what is mercury? That's he meant the mercury is the element, right? The metal. And ChatGPT answers, Mercury is the innermost planet of the solar system, blah, 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 blah. It answers Mercury is a planet, okay? So he thought that was interesting, but it's not a big deal. So he would change the prompt to say, I'm asking about the chemical element. So ChatGPT returns and answers the question about, it's a toxic metal, it's liquid at room temperature, and blah, 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 and all that. It was largely correct. There are some inaccuracies in the answer. And then I thought that's what's most interesting. He asked the follow-up question to say, what is the melting temperature of mercury? As we all know, as the model itself has stated, mercury is liquid at room temperature. So the melting temperature of mercury would have to be pretty low in order for it to be liquid at room temperature, right? But the model answers is 400 something Fahrenheit. So at the time, I was very puzzled. Why would it get wrong? Such a simple question. That then it occurs to me, the surface temperature of Mercury, the planet, the innermost planet in the solar system, is 400 something Fahrenheit. Okay, so you can see how the model confused those facts together. That's so if I'm going to use ChatGPT as a chemistry teacher, like my son would want to, that's it would not be able to do that, because the model and the prompt is not designed to answer this specific type of question. So in order to do things like that, we need to package a chemistry-specific data, specific set of knowledge base with a model that doesn't really have not much chemistry knowledge or astronomy knowledge on its own, so that it would not confuse those facts because it doesn't have those facts to begin with. So that gives the whole idea of small large language models, SLMs, plus highly specific domain knowledges, right? So this is essentially those three steps we do. So we took, we have a software package in one of our community members who did the project called Gaia. And this is one of the projects that combines the vector database with the Wasm-Edge model runtime with a large language model. So you can choose essentially any model from Hugging Face, and then you can supplement it with your own knowledge base. So what they did, as my son did, what he did is that he took the chemistry textbook and then build a knowledge base from it. And then you can start that node and start chatting with it. And so I would do this demo by going through the process. So I would skip the first process, which is installing software, because I already have the software installed. And so I'm gonna just copy and paste the second command. And by the way, this is just my Mac laptop. So it's a very old laptop. So the saying really goes, that's 2 years ago, right before ChatGPT came out. I'm due for a new computer, so my assistant asked me, what type of computer do you need? I said I wanted the cheapest Apple computer possible because it's all overpowered. Only thing I need is get to the internet and write some code, right? Now I'm using it to run large language models, so that's so I really regret my choice. But that's so the next computer I'm gonna get the largest possible memory. But anyway, so I run this command on the command line, and you can see what it does is that it's check whether the large language model is here locally. I have already pre-downloaded, so it's here. It's a standard Llama 3.1 8B model. And, when I go to conferences and ask people to do that, that's people would actually try that, and then it would bring down the whole conference Wi-Fi because they are each downloading a 5 gigabytes, large language model. But here we're gonna have it, and we have a quadrant database, vector database installed. And what this command really did is that it goes online to download the chemistry knowledge base and put that into the quadrant, right? So now what I'm gonna do is I'm gonna do GANet start, which basically starts the large language model with the vector database with a set of prompts that makes the large language model think it's a chemistry teacher. Okay, so so it's so basically it's there's a configuration in this package that allows it to come up with a command that start with match and start with the large language model that we chose, which start with the embedding model, which is the AI model that's specifically turning language into vectors so that it can be searched in the vector database, right? So now it's also, so now it says it started. What I'm gonna do is I'm gonna go to localhost so that I can make sure it's runs locally. It doesn't, so this doesn't go, if this is not being broadcast, I'm gonna turn off my Wi-Fi at this point, just to show you this is entirely local. There's nothing that's on the internet. So I would start and ask the question, a somewhat difficult question. What is the atomic weight of mercury? Sorry. Okay, so the answer to the first question is a little slow because it has to, load all 5 gigabytes of, large language model into the memory and then do the inference, right? But it's going to be faster in the second one. So as you can see, it gives a highly specific answer. If you just ask ChatGPT or vanilla, Llama 3.1, it would not be able to provide this type of answer. It has a very accurate description of what is atomic weight. By the way, the atomic number is 80. So a lot of people confuse that, because the atomic number is how many protons it has in its nucleus, but the atomic weight is a combination of protons and neutrons, and because it has isotypes. So the atomic weight is not an integer number. So it goes like this. So it's a weighted average of all the isotopes of mercury, right? So it is I think it's a highly specific chemistry answer that it gave because the large language model itself is fairly small. It doesn't have a lot of knowledge, that's first. It doesn't have a lot of things to confuse itself. And second, we have a highly specific chemistry textbook. So I ask another one, which a lot of the our Chinese friends would find familiar. So let's say, what is copper sulfide? So this is a chemical compound that is very commonly used. If you are going through the Chinese education system, that's been tested again and again. This is a compound that's when dissolved in water, it's going to turn the water into sky blue. Okay, so if you ever see the exam question to say the solution is sky blue, there's there's this thing here. So it's yes. So it gives a fairly detailed answer of what it is and what is the chemical composition and things like that. I can go on and ask the type of chemical reactions. What if I mix this with, say, another metal? The other metal would have a replace reaction and replace the copper out of it, and things like that. So so we turned Llama 3.1 into a very capable chemistry teacher by feeding it highly specific data about chemistry. I think that illustrates the importance of tight coupling. So you have application. The application is not just the large language model running somewhere. But you have a specific attribute that you want from the large language model, and you have a knowledge base that supplements it, right? So I'll stop this demo because I can go on forever. But but I do want to show you something else, which is actually quite interesting to also relevant to the demo that we just saw about the coding demo, right? So what we did here, it actually have voice, but is that a voice? Oh well, so so I just talk it over. So essentially, we have all seen Cursor, the coding IDE, right? You can connect with cloud or whatever to do coding. But a lot of those models are not really good at Rust. They are good at Python. They are good at JavaScript. So we have a Llama 3.1b model. We have a graduate student from ITT in India, and we asked him to convert all the public Rust language knowledge into a knowledge database, then supplement that into that model, and then connect cursor with that model, right? So this is essentially one of our product manager, and she has no Rust experience. She has never coded Rust in her life. So I asked her to record this demo. So what she did is that she goes to the node first, then asks, how do you start a Rust project? She said, use cargo create, right? So that's what she did. She said cargo create. So now then she goes to this node, and then she, so she connects this node, she connects cursor with this node. This node, right, it's what we call, it's the same as the chemistry teacher. So it's a Llama 3.1 large language model. And then, you add this to cursor as one of the node and turn off every other node, right? Turn off all the other large language model backends. So now she can use it. So, so she comes to the IDE, let's wait. So, yeah. So she used a different URL that's replaced the OpenAI URL with our own large language model that's running on Llama Edge, right here. So now she goes to the template file, the main.rs, which is the hello world, in Rust. And she said, I want to do a to-do app, okay? So I want to write me a to-do app in Rust. What it does is that it goes to the model and asks how to do a to-do app. And the model returns something like this. And this is something I thought was very interesting, because this literally did a to-do app, just to print a bunch of to-do items. And this is not what we want, because we want logic in the application. We don't want the application just print a bunch of to-do items. So she said, support adding and deleting items. So that's not what I want. I want to support adding and deleting items. Now you can see the model generate much better answers. Why? Because it has seen applications like this in its knowledge base, not in its training, but in its knowledge base. So so it goes on to generate applications that use a vector to store those to-do items. Now you say accept, so you have all this, but being new to Rust, she doesn't even know how to compile and run Rust. So she on the chat window, she said, how do I run this Rust program? Now you write this Rust program for me, but how do I run it, right? So then it gives a detailed explanation of how to install Rust, which she already did. But there's so basically it goes on and say use cargo run, right? So at this point that she would go and say, okay, let's see. Yeah, come on. Okay, say cargo run, right? So she would do cargo run here. Okay. And cargo run not only compiles the application, the cargo build. Oh, by the way, when she did cargo build, it says it's wrong, because the Rust compiler is very unforgiving. As you can see, because it's put the markdown here, right? But being a Rust newbie, that she doesn't know that. However, the IDE already knew that. So the IDE got this error message and automatically sent back to the large language model to ask the large language model what is wrong. Large language model tells you what's wrong and how to fix it. So now she sees that, she fixed that. Okay, so so she asked how to run the model, how to run the application, and then she used the command to run the application, and then she find out, that's it didn't work. Now she compiled and runs, but another problem emerged. As soon as she runs, the application quits. It doesn't print anything. So she come here and say, how do I interact with it? The model looks at the code and then tells you that's because the code is written this way. Here's a loop, and then that means once you start the application, you should not enter a return immediately. You should select from one of the menus, right? This is one of the command line applications. So so she saw that, and then she go back there and do the run again. Let's see. So it's almost finished, and yeah. So she'll come back and say cargo run. And now she doesn't hit enter. She says, add a task, view task, delete task. Now she say add task, and then say buy milk, right? Then it would be saved into the memory of this application, and then she would say view task and tell her that you have a task outstanding that is buy milk. So so this, we have a couple of videos like that. There's we trained build model applications that has again, we would call small language model with a specific knowledge base. And we can go all the way to Alibaba's Qianwen 0.5B model. 0.5B model can, I think it's only 200 megabytes. And if running on the CPU without the GPU, it can get to 100 tokens per second. Okay, so it's a really fast and really good model. It doesn't really know much, without supplement knowledge base, but if you supplement it with a knowledge base, it can know a lot. It can know how to program in Rust and things like that. So let me go on. And so now I hope I have established the need to do the integrated large language model with the tools and with the knowledge base. So you build the whole application together and then distribute the whole application instead of using the large language model like an API, right? If you need to build application and then compile and distribute it with large language model embedded in it, then the problem then you encounter several immediate problems. The first is that there's a problem with Python because if you look at any Python code that runs those large language model like PyTorch, it actually surprised me. Do you guys know how big the PyTorch Docker image is? The dependency PyTorch need is 8 gigabytes. Okay, so the PyTorch Docker image is 8 gigabytes. And so it's gigabytes and gigabytes of stuff that you have to build into your application if you just want to use Python for it. And plus, the Python is not going to be cross CPU and cross GPU anyway. In Python you have to have CUDA specific commands in order to run the model that with CUDA, right? So that so that's why most of those applications do not distribute it as a Python image, because if you distribute agent as Python image, that's fine, but that's assuming the model is available somewhere else through an API, right? That's so the Python is just the workflow, it's just LangChain or Llama index, whatever, right? But if you want the whole application written in Python, I think you're gonna embed PyTorch. That's gonna be a huge amount of task for you to do. So that's actually not just I'm thinking that, so we all know this guy, right? That's so someone said AGI will be built with Python. Let that sink in. And he replied Rust. And Greg Brockman is the CTO of OpenAI. That's his famous tweet is that that's much of modern machine learning engineering is making Python not to be a bottleneck. Spending a lot of time installing Python and try to figure out why it's so slow, right? So the first thing that we rule out is that building application in Python is maybe good, for prototyping, maybe good for agent, but not good for highly integrated, tightly coupled large language model applications. So the second one is really that's then if not Python, and why not just C++ or Rust, whatever, right? So the problem with that is that it goes all the way back. It brings all the way back to 25 years ago when Java first came, right? Is that if I have a Windows machine and I write an application, then I can't deploy this application to my Linux server anymore because it's different APIs. It's the same thing today because we have so many GPUs today. So it's my application that's written for the Mac and running on the Mac would have zero chance to running on all of those. That's because they are all different hardware architecture, different software drivers, and things like that. So I thought it was very interesting. I'm gonna borrow a line that directly from one of the earlier speakers is that the solution for that, like anything in computer science, is really just to add another abstraction, right? Is that so in our world, this abstraction is called WASM. It's called WebAssembly. So so you can have C++, Rust, or any native language, Go, or any of those languages, and compile them to WebAssembly, and then not care about what kind of hardware you are running beneath that anymore. Okay, so meaning that if I develop something on the Mac and I compile to WebAssembly, I will be able to run on all those devices. Although it's not the reality today, but we have done this, we have done this, we have done this. So we are in the process of doing this.
People are coming tomorrow.
They are not open source. We don't have an open source SDK. You should convince them to do open source, right? Yeah. So
ask the questions when they present tomorrow.
Exactly. That's how open source community work with you guys, right? That's yeah, that's yeah. We're working with ARM as well. So yeah. So then I would have a final demo. That's I think I may have 10 minutes left. So so it's for this demo, I would not do a live demo because it's fairly complex, and I would really worry about to mess it up. So what it does is that I first build start a Docker image on my Mac machine. And in the Docker image, it has emulated ARM environment, and it has Linux environment, but it doesn't have any of the CPU features that the Mac has. So the standard Docker, when you start up Docker, it only have CPUs, right? So on the Docker system, I compile the Rust application that I wrote into Wasm. Okay, so the reason I do that is that I want to show you that I'm building this application on a system that doesn't have GPU at all. You know, not as hardware, not driver, not anything, and not library, not anything, right? So now, after I'm compiling it, I'm not compiling it to a native application, but I'm compiling it to a Wasm application called llama-chat.wasm. Okay, so now I switch back to my host Mac. On my Mac, I copy this file from my Docker container. Okay, so in the Docker container, I have no GPU, but outside of it, in the host, I do have a GPU. So now I'm running a compiled binary application that was compiled in the CPU environment and try to run it in the GPU environment, right? So now I started it, and then I say, plan me a 2-day trip to Tokyo, because I gave this talk at Tokyo first. So, you know, so this demo, actually this demo has a Japanese version. So, you know, there's a, so it blah, blah, blah goes on, you know, first day goes to the, you know, 浅草寺, you know, then it goes on and says, you know, that's, you know, so there's, yeah, that's, you know, it gave a pretty good, you know, explanation of, you know, how, you know, where to visit in Japan, right? And it's pretty fast. The reason I'm also showing this is because this is all real time. This is not a speed up recording. The only way a Llama 3 model can output text this fast is through a GPU. Through a CPU, it's going to be like the first day is blah, blah, blah. So this is actually faster than I can speak. Now I go to an Azure machine that is running NVIDIA T4 GPU. Okay, so now I do SCP to copy this Wasm file to the Azure machine. So I'm copying the binary application. I'm not rebuilding. I'm not, you know, adapting it in any way. I'm just copying the binary application. So on the Azure machine, you know, on the NVIDIA T4 machine, I'm asking a different question. Plan me a 2-day trip to Hong Kong, because the second time I gave this talk was in the Hong Kong KubeCon. So that's, but it gave much shorter answers, you know, I guess it's, I actually don't know why. So let's translate the above trip plan. Why would I translate to Japanese? Shouldn't I translate that into Chinese? But anyway, you know, so that's,
Okano-san, we need your translation.
yeah, so those are, you know, so this is, I thought that demo was interesting in a way that it's compiled on the CPU only machine, but runs on 2 different GPU machines that has very different GPU hardware. One is the Mac GPU with the software is the Metal framework. The other is the NVIDIA GPU. The software is CUDA framework, right? You know, so we have something that's, you know, that's that at the binary level cross-platform. I think that's especially interesting and also important because it's, say, if you think about things like how the current cloud infrastructure is set up, like Kubernetes. Kubernetes is designed to orchestrate binary files only. You know, it is not going to recompile your application on a new machine. It's just going to copy your application into to a new machine, right? That's why there's so much headache. You know, that's say if I have a new machine that is AMD, not NVIDIA. That's you know, I would have very detailed and error-prone configurations in Kubernetes to make sure that I'm orchestrating the AMD image to that machine instead of the NVIDIA image, right? You know, so there are lots of work and a lot of headaches. That's you know, that's what's involved in that brought us, you know, I think set us all the way back to 1995. You know, that's the days that we don't, that's pre-Java, right? So let me see. Well, yeah. So that's you know, so basically we're going to a new paradigm that where developers just write those applications using the what we call the Wasm API and compile to Wasm, and then let the ops figure out. So this is a slide that shows you how simple this application is. So you know, I would also like to boast that this is the entire core logic of the chat application you've seen. You've seen the loop. You've seen how to send the data to the context and then get the data from, you know, send the data to the large language model and get the data back, how to construct the POM. The whole thing fit into one slide, right? One PPT. That's the whole, that's all the code the developer has to write, right? You know, so then let the ops figure out which version of the driver and which version of the WASM Edge runtime they need to install on the machine. It's the same thing that if you have a Linux machine, you have AMD machine, you have to install the AMD version of Linux, right? If you have say, that's ARM machine, you need to install the ARM version of the operating system. It's the same thing. The ops people have to figure out the correct driver and runtime they have to install on that machine. So that the orchestrator or the or Kubernetes would be able to orchestrate those WASM applications across those the boundaries of those devices and have them run anywhere. So anyway, I think that's it. That's I have a. Do I still have time?
All the way to 3:20. You have 7 more minutes.
Oh, okay. So yeah, well, if you have questions, you can ask me now because I have done most of my talking. But as last thing, I really just want to show you another project called Moxie. This is one of the cross-platform UI for large language model. So it's we leverage the cross-platform raster UI, and because as you can see, all the things that we did running large language model and things like that is based on the command line, which I'm sure you all are very familiar with. But for the new person who has never done command line, like some of the graduate students my wife has, that's they're business students, and they were like, wow, do you really expect me to do those command line stuff? So we have a GUI stuff that allows you to we have rack distribution, Linux distribution, it's all written in Rust, and you can you can download it, you can install it, you can select large language, you can search, you can select large language model, you can install it, and then you can chat with it, and then there are a lot more functionalities like function calling and things like that, because it's running locally on your machine, so you will be able to access your machine to do things like make phone calls to people, send an email, or set your alarm, or things like that. This is also I think a very good example of a tightly integrated application. That's you have all those features that ties the application with large language model. It's not to say that's I can choose any large language model from OpenAI or from cloud and it will just work. It wouldn't. You would have to pair your large language model with the application itself. So yeah, that's so yeah, if you have time, that's so yeah, come visit us at WASM Edge, and we are really looking for more open source contributors and to adapt it to more devices. And yeah, that's it. Thank you.
So the project you just mentioned is open source?
Everything I talk about here is open source.
Okay.
Yeah.
Also, another question. The first demo we gave was for chemistry.
Yeah.
That part of the knowledge base is used right or used fine-tune?
So we did not fine-tune the model. So we did a lot of experimentation to say, can we fine-tune the model to make it become a chemistry teacher? And the answer is no. And then that's also some of the things I should have looked up. Papers that people publish. That people have repeatedly said the fine-tuning give you style, but doesn't give you knowledge. So you can't add new knowledge to the model by fine-tuning it, but you can fine-tune the styles. For instance, if you wanted to speak like Donald Trump, you can fine-tune it. So it's going to use the words that he likes and things like that, but it doesn't get more knowledge. So the knowledge is vector database outside of it.
Vector database. So basically, you use like a RAG.
Yes. So, but we do RAG in a more sophisticated way because those models, the key characteristic of those models are they have larger context lengths. So you don't have to have those like 100-word snippet, but you can have 4 chapters in it. But in order to put the 4 chapter into the prompt, you have to make the 4 chapters searchable, because the chapter has so much stuff. If I just say what is the melting temperature of mercury, it's going to match to a lot of different places in different chapters, right? Because it's going to be talking about melting temperature about different things in all kinds of places. So what we did is that we used the large language model to generate 100 questions and answers from that chapter, serve as a vector index, and then search that index to find the corresponding chapter, and then put that into the knowledge base. So there are lots of small things you can do. That's also to my point. That's you have to match the model with your infrastructure. Because say a ChatGPT, you may not need that. You may be able to put the whole book in there and just ask any question about the book. right? Because their say Gemini, their context length is very long, right? So you may not need that.
A problem is even though they have pretty big context, but it's too expensive.
Yeah. But that's also why you want to run it locally, is it? I mean,
right. That's what I'm looking for. That's why I'm curious.
Yeah.
Thank you.
Yeah.
Yeah, just curious about the Rust knowledge that, like some books or texts that they feed it, and how do they package them to share with others? Like,
Yeah. So the knowledge of Rust is so the way we did it is open source books. So there are a couple books called. There's one Rust by examples, and another one is called the Rust programming language. So those are fairly classic books that are open source that the Rust Foundation has provided, right? So at one point, the Rust Foundation want to use this, but that's as an education tool, right? So it's we can do a lot more by giving it Rust Q&As because there's a lot of Rust projects that has a lot of issues that you can actually go through those GitHub repository and find out the best practice and things like that. So this is something that we are doing. But our student intern, they have like 3 months. So basically he tried fine tuning and didn't work, and then he he built this knowledge base. So so we are really looking for contributors, to make it better so that the model can answer Rust questions or deep Rust questions a lot better.
yeah, this is interesting because I'm thinking about like an application or like domain expertise, right? Like in the future that people don't share the documentations anymore, share like a knowledge graph.
Oh yeah, exactly. Yeah.
Then yeah, and if it's like compatible based on the Rust match, like I can basically repeat like create myself, right? Like and all my knowledge and I think it's yeah, I think it's just interesting.
Yeah. So yeah, if you're talking about the sharing of the knowledge base, I think because it's dependent on the embedding model. So it's the embedding model generates what embedding model does is that it takes a natural language paragraph and turns that into a high dimensional vector. So it's say we are using the nomad embedding model, so it's 768 dimensions of vector space where it can turn any paragraph into a point in that space, right? So when you search, you do a close neighbor search, and so you ask a question, you search what are the vectors that are close by, and find their corresponding text, right? So you can package the whole vector database, the vector collection, into a zip file and then share with other people. But then the other people would have to have the same model in order to use that file, because they use another model to generate vectors, then it's going to be mismatched, right? So that's also why I say things are tightly coupled. A lot of the things that we take for granted, that's a loose coupling, probably doesn't work here.
Question is how many more minutes? 3:20 yet?
Yeah, I think it's time for the next.
Huh?
Time for the
3:20
next.
yet? Okay, yeah. Yeah, ask more questions to Michael. You're top popular offline. I think he deserves another round of applause.
Can I ask a question if we have time?
Oh, yeah, sure.
Yeah, so if a product is existing in Python, can you speak to a business audience as to how you would influence them to greenlight the budget to either adopt the product to Rust or integrate the product to Rust?
Yeah, so I think the biggest issue with Python, as an IT professional, I had this battle many, many times, because we keep pushing for new technology and people are already using X, and I say you should use Y, and then people say, well, that's you get the huge amount of resistance from that, right? So I would say from if you look at this rationally, the problem with Python is that it's too big and too expensive. So, so there's and also it's become too unwieldy. That's the people spend a lot of time just to install the non-conflicting, library packages and all that. So I think it's an easy sell for CTOs and CFOs. That's we should use something that's better than Python. However, I think it's difficult to sell to engineers because engineers already knew Python. So they would come up with all kinds of excuses why Python is better. It's more secure, or we have more talent to it. That's we can find a lot of students who knows Python. Nobody, none of them knows Rust. That's the things that we got, right? So in my opinion, from the business point of view, the only chance that we have is greenfield applications. So meaning applications that are being developed anew. Say if application has already been developed in Python, then I think it's lost. It's you can't convince them to use another language, because it'd be too much risk. It would be too much, too much politics. The thing I really like about AI is a lot of those AI applications are greenfield applications. Those are not Go-based microservices from 10 years ago. That's that people have been using it very reliably. That's so new applications. I think there's more of a chance.
Thank you. Just to follow that up, you mentioned about the time savings, right? And obviously the size. What if the response is, I don't care about that?
It's so I think from the CTO and CFO point of view, they do care about that. It's a balance whether their own developers objecting to that is going to balance that out, because as we all know, the most expensive part are humans. However, things might change, because the AI-based pair programmers might might replace a lot of humans, right? So it's
You read my mind.
Yes, so Rust has a very particular advantage of that, because unlike Python or JavaScript, where if you write the code, you actually don't know whether it's going to behave correctly or not, Rust has a really strong compiler. So if it compiles, in all likelihood, it's going to work. That's so it allows machines to to establish a loop. So you write your Rust code, and then you'll compile it yourself and see if it's going to pass the compiler. If you don't pass the compiler, you don't even tell me. You just go rewrite it, right? Based on the error messages that you receive yourself. So it's sort of like the strawberry today, right? The OpenAI strawberry. That's I thought a very hilarious example. The example a lot of models answer incorrectly to say, tell me how many words you have in your answer. So it'll give answer and 7 words or something. Strawberry has a long set of reasoning, and then it gives the right answer. But that question is also a very good question, because there's a deterministic answer. It's not like to say, is Donald Trump a good president? There's no deterministic answer, right? So if you have the beautiful thing about Rust is often the code being generated is a lot deterministic than say Python or JavaScript.
And so in your opinion, when do you think Rust will bypass Python in use and in foundation in business?
It's Rust has it's not a really new language. It has been 10 years, and Python, I think the creator of Python has already retired, right? So Python is like 30-year language. So the language adoption is very slow. That's you need the whole generation of people to retire before they actually to adopt anything, right?
All right.
Thank you so much. Appreciate that.
Next up, Lingli Deng from China Mobile will explain their new strategic planning in the AI era.
Hi everyone, this is Lingli from China Mobile. Can you hear me?
Yes, we can.
Okay. Let me try to share my screen.
Are you gonna turn on the camera? I guess you just got. Maybe do you mean to turn on your camera? I know it's too early. Maybe you need to just make up.
All right. Let me see. Can you see my screen now?
Yes.
All right.
Wow.
She did turn on her.
6 a.m. in the morning.
Is it 6?
Yes.
Yeah, it's really early in the morning. I hope that I look appropriate.
Yes. You look very good.
Hello, everyone. So actually, this is a joint presentation. And my colleagues Ke Guang and Meng Yuan will also, joining me later. And this is about, letting you know what we China Mobile are thinking, doing, and what we will be facing, in the process. And this is our first time to join this develop, conference. And I hope that you could join us and help us address some of the issues. And for the sake of, I think the traffic, because I am joining from a hotel, I'm currently on a business trip, so I will stop my video and hope that will, help smooth the presentation and help the slides get, all right. Let me see, how can I do this? Okay. Not very familiar with this application. This is also new for me. Sorry about that. And yes, so the first point I would like to clarify here and letting you know is how I'm sorry. It seems there's a little bit echo. Okay. So how we understand the relationship between X plus AI and AI plus X, and basically the title, because everyone knows addition is equal. A plus B is always equal to B plus A, right? But in mathematics, but in our daily life, for example, if we have some particular, we have like having dumplings, for example, which I am going to have for my breakfast. Today, we always say that we will be having dumplings with a bit of vinegar. And we rarely say that we have vinegar with a bit of dumplings, right? So this is the difference. So over the past decade, the team that I am part of in China Mobile, we have been doing, things for helping the company and some of our customers to leverage AI technology. What we have, gone through the long period is actually resembling the practice of X plus AI, which is in a context, for example, we will be helping our network operation and maintenance in all the systems, all the workflows for that stays the same. While we will be add-on systems, add-on like tools to that existing workflows, to that existing systems. And this is going to change when we are actually changing the mindset to do things. Now it's moving to more like an AI plus X pattern. And we see the change here. The first change is that we're no longer doing those, sorry. Okay, we're no longer doing those point-based enablement. Today, with the large language model technology, we are seeking end-to-end enablement so that we could achieve the end-to-end effectiveness. So increase efficiency, reduce cost, and in the same time to enable better user or customer experience. The second change we see is that the large language models are actually demonstrating a very good system information integration, capabilities. It can actually has the potential to integrate different domain knowledge and handle very complex tasks. So with such both system integration capability as well as the information integration capability, we are seeing the opportunities for us no longer standing as a communication service provider, but we can helping verticals, various industries to also reconstructing their business core with generative AI to achieve new business forms and models. In particular, we are looking at opportunities for us in 4 types of businesses: AI plus operation services, AI plus new creativity, AI plus new quality, productivity, and lastly but not least, AI plus strategic decision making. So we will be providing both the infrastructure for intelligent computing and also with our 9 large language models, as we said, to support all of this. And in the next, I will go very briefly with some of the practices in these 4 different areas and some of the challenges that we face along the way for information. The first one is AI plus operation service. Right now, you see, let me see. Yes, and this is actually a intelligentized version of our traditional customer caring service. There is a number that you can call as a China Mobile's customer. And this time we're offering a human-machine collaborative customer service back office system. You are actually talking to a large language model driven agent, and literally you can ask anything, and it will be integrating the internal back office capabilities, not only from China Mobile, but also from our partners. For example, if you like to book a ticket or flight, and we can also make the recommendation. You would like to know the weather of the travel target, and we can also do that. And this is actually offering a service integration point with these mobile customers that China Mobile has already been offering its service to.
您好，中国移动为您提供星级关怀服务。
你好，是哪位啊？
Okay, this is just a short demo. I will skip that. And in this slide, you will see that there is also a number of new services in this area. And what are the challenges that we are facing, especially in the scale adoption of these type of services? There are some of the basic problems that we see if we would like to actually advance in this direction. The first one is we believe that the research or study of generative AI and multi-level, multi-core controllability problems is still insufficient, because in these such scenarios, we need to actually having a number of, like human actually, get involved in such processes, especially when you are tackling a very complex, issue coming from the customer that originally, need multi-system or even multiple people to collaborating in address this issue. So in this case, the generative AI has to actually to collaborating with the human in the collaboration model. And also because it is tackling, like critical issues, it needs to be controllable. All right. And also because it is, dealing with the customer directly, and it needs to be more human driven, and it cannot be like a very strict and acting like a machine. It should be acting as a human, and you need to be caring about the customers, their moods, and understand and show your understanding. So we're also doing research on such direction on interactive large models that is focused on user experience, and we call it care-oriented services. And the second type of new services that we see is for creativity. And this is actually an example of our practice. This is actually, we have been providing 善学 as one of the applications for our 9天 services. It's actually providing industrial model based on the knowledge data that we acquired from our
刘老师
local、
张老师，你
customers.
们好，我是九。
And also, it will be offering, like solutions when it is prompted with a question. But however, if the user actually giving a negative feedback to this solution or it was proposed earlier, then it will turn to the experts that registered for helping this type of, like issues. And these experts could be providing guidance in an interactive pattern like this one, or providing more general guidance, and in a fixed period when we are looking about the history.
天善学大模型。
All right. So, and the challenges that we are facing here is we need to, have better patterns and mechanisms for these generative AI applications, as well as, the human experts or creators, and build expert models with their own uniqueness of thinking. Because human experts, they accumulated their knowledge in their way, and each of them are actually thinking differently. And it is also essential for the large language model to learn the uniqueness of these experts' thinking. And the third type is for new quality productivity practice. And this is our, what we have been doing, especially with communication networks. We have these simulation platforms that can actually mimic and also doing predictions for our radio access network. When you are doing, like supporting a very large scale event, you need to actually give a plan of the coverage in a very short time, and also taking into considerations of what would be the traffic pattern and what will be the audience and all the traffic around these areas, and make sure that they all have the quality coverage and connectivity during this period of time. So in that we need a system to offering the prediction, and also based on that generate plan recommendations for our experts so that they can actually deliver the task in time. In addition to that, we are also working with a lot of Chinese verticals like manufacturing and energy and resource exploration and material development as well. So the challenges facing in this sector includes multimodal and multi-source information fusion, characterization, and alignment. Because as you can see that each of these industries have long history. Some have over 100-year history even before AI was invented. So they have their own source or of information and their domain-specific knowledge, and they are having their also pattern of impact. So that is why we need to adapt to their used, interaction model and data information sources. The second part is because these are talking about real dynamic production environments, and these environments are actually, evolving. So it is important for us to also build an automatic closed loop evolution. The applications, the intelligence agents, or built from these models need to evolve along with these dynamic environments for it to be really practical in production. And the last one is, these applications needs to really possess production grade capability to take the perception, prediction, control, and decision making tasks for these production workflows. The last sector we're looking at is strategic decision making. This is a new one, and we're actually working with some of the industrial administration departments. They're doing analysis and also making regulations or publish guidelines to different verticals in Chinese market. And what they are looking at for these intelligent assistants is a tool to simplify complex tasks when they are actually trying to penetrating and understanding what is going on with the overall or domain specific areas for these different industries. And second, they need to make all these macro problems that they want to address and relate them to a micro scale, like issues that is observable from different industries. And lastly, when they're doing decision making, it is really important to clarify ambiguous decisions so that to relate their decision very general and decisions from across different industries and translate it into concrete and actionable guidelines to each of these industries to clarify the ambiguity in execution. And the challenges we're facing in this sector include how to effectively simulate and model complex dynamic macro systems. And for example, you need to understand, what is exactly going on inside each of the industry and also understand their relationship. Because different industries, for example, the material making industry, the manufacturing industry could have an impact also for the communication, like industries, that is for sure. And also the resource exploration industry also have an impact, in the manufacturing. So these are a very complex, dynamic macro systems. We need to understand it. And the second one is how to develop macro intelligent algorithms and mechanisms for dynamically representing the emergence and evolution of macro systems. And last one is how to design the mechanism and method for the coordination and aggregation from multi-scale micro intelligence to macro intelligence. I understand that this is a very specific, like situation we're talking about, but these issues are very interesting, and we believe that it also might be applied to different contexts as well. And that is all from my side. And next, my colleagues Ke Guang and Meng Yuan will be, presenting you more on our, industrial collaboration proposals from their perspective. And so I will stop from now, and I think we will be taking questions on the last. Thank you.
Okay, thank you, and hello everyone. I will show my desktop. Okay, Hello everyone. Just okay. For the second part, I will give introduction about China Mobile's mass practice. First, I will give introduction to model as a service. And under the traditional AI, traditional AI model application, developers and users need to work closely together to conduct specialized model training for specific scenario data. The resulting models have poor generalization capability and are difficult to transfer across scenarios. And however, the emergence of a large model has changed all of this. Based on large language models with general perception capabilities, after a small amount of fine-tuning or optimization through instructions, combined with domain knowledge enhancement and secret reinforcement, they can be employed in multiple scenarios. At the same time, the research and development phase of general large language models and the operate costs during the usage phase are extremely high, beyond the capability of individual application developers or domain service providers. This undoubtedly stressing the division of labor and cooperations between large language model provider and large language model consumers. More importantly, it also creates opportunities for the introduction of a third type of role, model aggregates and operators. As the name implies, the model operator provide model as a service. More specifically, MaaS offers three core elements: pure model inference services, application invocation of model composite agent services, and the DevOps management for applications. And in other words, MaaS is a suite of APIs include multiple APIs. The model operator does not need to provide all three categories of capabilities, but can choose one or a combination of servers based on its own accumulation and development requirements, especially for the first and the second categories of services. Compared to global public cloud service provider, we believe that telecommunication operators have a unique advantage in these areas because they are close to users and familiar with local culture and regulatory requirements. And the second part, I will introduce China Mobile's MaaS practice. And on the one hand, a large number of communication service providers are already developing or providing large language model-based smart custom servers, and for them, it only requires a change of approach to open up the existing system and capabilities with relatively high additional costs. On the other hand, the practice of MaaS in the industry has become very mature. For example, in China, both public cloud service provider and a traditional communication service provider has ventured into MaaS, and the time is ripe for the development of a cross-operate standard APIs. And China Mobile have a MaaS platform named 9天 Model Harbor. And for 9天 Model Harbor, it is collecting large model providers and operators, converging a rich area of large and small models, data sets, and AI native applications, offering one-stop service for model exploration, experience, downloading, tuning, training, deployment, inference, application, and evaluation and security. And establishing open and shared AI resource agreed platform include high-quality data science mode and AI-native applications. And it is also provide one-stop large model services, covering all aspects of model management, downloading, training, tuning, and inference deployment, and also provide integrated intelligent operation for operation develops provide intelligent operation service based on systematic AI technologies. And this is and for this page, I give an introduction about the data set and model usage process in 9 Model Harbor. First, the first step, pre-install with various of data sets, 9 foundation large models and high quality third-party open source large models, supporting data set reviews, model field reviews, and online experience of model effects. Second step, use Git for convenient downloading of data sets and models, quickly pull cloud-based model fields. And step 3, offer step 3 fine-tuning on a large model or pre-trained models, significantly lower the barrier to AI model development. Step 4, offer a variety of development methods supporting users to experience self-service one-click deployment on the platform. Step 5, support uploading high-quality data sets, models, applications to the platform for AI asset management. And this is a process about AI native application usage. Step 1, support configuring applications through prompt engineering, knowledge bases, model capabilities, and other functions. Step 2, support users in publishing their created applications which after review. And for step 3, users can view and use application published by other users or officially in the application marketplace. And for step 4, select the appropriate application for conversation via real-time execution steps and detailed information. And for 9 Model Harbors, we have several application scenarios like we provide mass services, large model evaluations, and large model content governance. And we also have several typical use cases in China, like server for China Mobile's group-wide mass services, and also open to universities, enterprises, and other industry academia research collaborations, also promoting the development and construction of large model across various hardware and software ecosystem. And the third part, I will give a introduction about our mass project in camera. And Camera is an open source project within Linux Foundation to define, develop, and test APIs. So in Camera, we also try to submit several proposals about Mars, and this is use case where we do that works. Imagine a smart custom service application scenario for a multinational corporation. A manufacturing company located in China sell its product worldwide. And to meet the trend of e-commerce and enhance customer experience, the company decided to introduce large model technologies to optimize its online custom service system that directly fits the customer. And we believe that the communication service provider have a competitive edge over cloud service providers in these scenarios. And they can not only because they have a connection sites close to user, but more importantly, they possess extensive knowledge and experience in local culture, security, and data governance. If they can offer standard APIs to to mass-related functionalities. These capabilities can be directly utilized by multinational corporation or application developers for rapid reuse across different geography areas. And this is another application scenarios about the flex selection of large language models at multiple sites. And this is our proposal in Camera. We submit API product family Mars, and also submit 3 APIs. First API is to manage knowledge base. Second API is manage question and answer assistant, and the last API is provided the function for users to call question and answer assistant. And if you are interested in the proposal, you can get more information from the link, and we kindly invited other companies to support our proposal. And for future plans, we continuously providing rich and high quality data sets, model, and AI native applications, further enhancing the level of intelligent operational services to meet the requirements of use and improve the user experience, and promoting the innovation and the development of large model technologies and expand more application scenarios, building a more reliable and secure mass platform, and promoting the standards and open source work related to Mars. And I think next Mengyuan will give an introduction about the third part. Mengyuan, please.
Hello, everyone. Can you hear me? Okay.
Yes.
Oh, I'm Ma Mengyuan from China Mobile, and it's a great honor for me to introduce China Mobile's AN Industry Collaboration Program, Practice, and Initiative. Okay, this is the outline of my introduction. First, I'll show you the background of autonomous network, and then I'm gonna give a brief overview of China Mobile's AN practice, and finally, our conclusion and initiative. Next page, please. Thank you. Autonomous networks aim to provide zero wait, zero touch, and zero trouble customer experience for vertical industry users and customers through intelligent infrastructure, agile operations, and all inclusive services of fully automated networks and ICT. This makes service easier for users to consume and leaves implementation complexity with the providers. ANs need to support self-service, self-fulfillment, and self-assurance of telecom network infrastructures for internal users across various departments, including planning, marketing, operations, and management. China Mobile L4 autonomous network is based on the original definition, put forward the machine design instead of manual design as the main feature, promotes the network work from experience lead to data-driven lead. Data-driven realize the upgrade from automation function construction to end-to-end for precise automation. And next page, thank you. And next, from 2019 to now, there are nearly 3,000 applications of autonomous network in China Mobile, and has achieved remarkable application effects, which give full play to the application advantages of AI small models in the precise enabling of deterministic operation and maintenance scenarios, such as intelligent optimization of 5G antenna weighting, 9天 intelligent energy saving solution of 5G base station and 5G base station acceptance and integration. Next page, thank you. And nowadays, generative AI has brought many opportunities, and the network is expected to introduce this technology to achieve a new round of cost reduction and efficiency improvement. And the core capabilities of generative AI of AN is as follows. First is intent experience, understand telecom know-how, a conventional OEM. Second is awareness analysis, multimodal perception, and complex network issue analysis. Third is decision execution, an unified performance per prediction, precise network simulation, and decision making. And China Mobile has invested in network OEM large model and application development. Next page. We have some application practice of generative AI recently. First is generative AI enables intelligent, compliant analysis for core network. And due to the challenge of low efficiency, high skill requirements, and complex process, we introduced intelligent signal analysis and automatic fault analysis. The solution is based on GNI, which can reduce the compliant analysis time from 6 hours to 5 minutes. It used to be handled by experts with 5 years experience, but now general engineers can get started in 1 year. The unified portal realizes closed loop for a single profession. Okay, next page. Our second is generative AI enables intelligent decision-making for transport network. Similar to the above problem, transport network domain also have some challenges, such as multiple work orders for a single fault, low recognition accuracy, human-centric, low decision-making efficiency, full communication, low rectification efficiency. We integrate AI, LLM, and SLM, new technologies, to reconstruct OEM models. We use generative AI to achieve the following capabilities: diagnosis solution generation, diagnosis repair solution generation, case and knowledge ONA, Q&A. This solution can help us reduce the diagnosis time from 13 minutes to 5 minutes, and MTTR from 1020 minutes to 20 minutes. Efficiency increased by 80%. Next page. In addition to the above AN case, implementing AN also delivering other benefits. China Mobile is committed to industry collaboration. We have led development more than 50 AN standards, focusing on ITUT, ETSI, TM Forum, 3GPP, CCIC, and other international standards organizations, leading the promotion of 6 standard projects and 1 new project about generative AI this year, and bringing together 19 industry partners, including enterprises and academic institutions, to jointly build an AN industry chain, build AN subchain, and establish a partner database of the of autonomous network, build an innovation carrier, intelligent network open and innovative platform, and establish international communication channels such as GTI and SAFA, and incubating multiple specialized small and medium-sized enterprises, and promoting the collaboration on building L4 autonomous network. And in the end, we are looking forward to your join the industrial cooperation with China Mobile. And that's all. Thank you for your attention.
Are we on time? Yeah, we have time. We have 13 minutes for Q&A. Yes.
Hey, this is Chi. Thank you for the presentation. I come from the cellular industry also, and I know that China Mobile is a telco company, right? Like you guys do the network, and I think my question is like, what is your thinking of like the role, like your role in the AI industry in the future? Are you going to be a service provider, like you're showing the LLM hub, that model services? Are you going to compete with the cloud service providers to provide also like another open AI, or like are you going to be like what is your role in the business wise? I think that's my first question. And second question would be like, for example, the Camara APIs. I heard about it, and it's great. It's you open up your network for the general developers. And I also see you showed applications, but that application is more like for yourself, right? Like you're using the AI to improve the network efficiency. But what about the third-party applications, like for general developers, for example, like Agenicics, like they're working on a small IoT project for like a strawberry farmers. And I think instead of just open up the APIs, do you guys also provide the servers or the computations to the developers, like not just the network? Because let's say like I have the solution, that Agenesis is the solution provider I work with. I set up my IoTs for the farmers, and I directly call the OpenAI API, right? I guess that China Mobile, or in general the telco, and also this Camara API can do something, but I still can. I don't foresee where you guys are lying in this business, right? Like between the strawberry farmers, Agenesis, and OpenAI API, where you guys are, like, what do you guys foresee for your future business in this AI industry? Yeah. I hope this is trying to explain my question.
Yeah, thank you for the question. These are very good questions and great questions. So first of all, I would like to say, yes, we come along the way, and starting from, like enabling AI plus communication networks. As I said earlier, so we're doing this for over 10 years from now. What we have been doing this is following the traditional path. So all the network, their workflows, their systems stay the same, while we are adding intelligence algorithms as an offline system for the human operation, stuff to call on, and then they carry on with their own business. Quite like this one. This is like a workflow. When they like a customer from China Mobile, they are calling to complain about their bad, connectivity experiences. Then there will be a agent answering the form and diagnosis of what are the problem and generate a ticket for a back office, operation, or even an outsourced engineer to actually taking care of the the issue. For example, some of the routine work even covers they need to go on site to figure out and finally dealing with this situation. And this workflow will stay the same while we are adding intelligent applications, for example, helping to diagnose the issues, or even helping generating some of the configuration recommendation on site. And this is the traditional way we are doing with our own communication network inside China Mobile. But now, because we are leveraging, we are building a large-scale intelligent computing infrastructure and also developing our own large models, in-house large models. And all these are very huge investments. And we are figuring that perhaps we can also working with other verticals to helping them not only inside China Mobile, but to bring this common infrastructure open to verticals inside China, or even to some of the regions that are not accessible to some of the services that was developed in the United States. And this is the way that has brought us here. And from our colleagues, I think the third colleague, Meng Yuan, she is mainly talking about what we have been doing with our network and shared our experience with our fellow communication service providers in constructing autonomous network in a more AI plus communication network manner. And we call on communication collaboration initiative from all our fellow service providers as well as our partners, but still in the communication sector. And what Ke Guang was presenting is actually is a mixture the two, as in described in your question. So we are calling our fellow communication service providers also thinking about perhaps exposing combined capabilities with their own smart customer caring services, not necessarily with their in-house large models, because we understand that not all the communication service providers would, investing in developing their own large language model, given that they have access to more, like open AI like service, not like us. So in their case, we are proposing not, exposing large models, but exposing added own service or capabilities that could be complementary to a third-party large model in offering this into verticals. And we're having, like application scenario discussions with some of the communication service providers, because they are they are all, considering, perhaps to upgrading their own smart customer caring services with the assistance of large language models from OpenAI or Amazon or any other cloud service providers. That is good, but there's also need besides that, right? We figure that communication service providers has their unique advantages in doing this compositive, or added on service, because they are local, they know the regulation well, and they're more close to the users, while we are all relying on a single hyperscaler to do all the updation and understand every local situation, which is highly dynamic. For example, in some regions, you are not supposed to, making fun or even talking about, some religious or political, figures. while in some occasions, that may be like a way of initiating a conversation. And this is not something that we believe, should be taken care of by a single hyperscaler, but it could be, one of the services unique, and our communication service providers could be good at. And that is why we're posing this to be, onto the table for cameras discussion. So all of these are related, but it is a little bit, different in different angles. And lastly, I would like to comment and explain more about your question about, how China Mobile would be helping a strawberry like farmers. In fact, we have been, collaborating with one of the largest Chinese agriculture enterprise in the northeast part of China. And what we have been doing is they are actually, farming a large scale, like a land with very little people. So they are based on their own machinery. They have their own, data format, and they have their own, mechanisms and algorithms of predicting, how the crops would grow, and also monitoring, how and predicts, how things would go. And what we are helping them is actually to stitching these different, workflows together, and with the large language model in the front, and actually providing end-to-end value-added intelligent services to them. And also in the process, we're helping them to further normalize the data formats from different data sources, and helping them to, how can I put it, project this end-to-end view, and also combining outsource information like, I don't know the exact word, but the systems are actually offering, weather prediction, weather analysis. So this is actually coming from another service provider local in China. So what we're doing here is to bring large language models, capability to further, intelligentize these already verticals. And we are not thinking about, collaborating with a single farmer with very little information, with very little, channel of doing this. So we're working with large verticals in agriculture, in manufacturing, and also a resource exploration, material development. And these are the current status. Perhaps, in some years in time, we can open these, services to individual farmers, but I'm not that sure. I hope that answers your question.
Yeah, thank you for the answers. Yeah. I mean, since this is an open source community, and this is open source meetings, and I understand that China Mobile can do this kind of vertical solutions for like the strawberry farmers, of course, but I think what I'm asking is, I also heard that you're trying to also providing the computations available for the third-party developers. I think I'm just like I don't know. I have a question is like, what is your thinking of? Is this going to be more easy for the developers? Because what is beautiful about cloud is like I can just easily tap in the Google GCP Google Cloud Services, and then I don't need to talk to any. I don't need to sign up any contract. I don't need to talk to anyone. Just a few clicks, I can spin up a server, right? For the China Mobile, I don't know, like, is this something going to be as easy as Google Cloud Service? Or Yeah, do you have a roadmap for that?
Well, I think we're talking about a different, like business model. We are not targeting the infrastructure as a service to be the main target. Keguang, could you share your screen about the application scenario? If we have time, I think since there is interest, we can have more discussion here. 客光，你能重新投一下屏吗？就关于第一个应用场景的例子。
Yeah, 5 minutes because we are 22 minutes over.
I remember the first slide. I think I understand that you guys are not going to do infrastructure as a service, but more like to provide a solution, and which is basically the same as Google and OpenAI and other service providers, right?
This is 22 minutes over.
Oh, yes. This is a very specific application scenario. So we are talking about, enterprises that are actually having, doing businesses all over the world. And they would like to offering the smart customer, their own smart customer services to all the customers around the globe. So, so in this case, they're not only talking about, having infrastructure as a service, but they would also have to think about, what would be the local appropriate way of communicating with the customer. For example, there is different ways of talking, and with a customer from Mid-Asia or East Asia or North America. So these types of communication added value like capabilities has already been solved by the communication service providers locally in that area because they are providing their own smart customer caring services to the communication customers, right? So what we are proposing here is actually the communication service provider partnering with the infrastructure providers. It could be themselves, or it could be Google, Amazon, Microsoft, based on what they can partnering with. But to offering these, enterprises, application developers, a standardized way of calling these localized capabilities. So you don't have to, calling different APIs for different, countries or different service providers. You can use a normed unified API. For example, in China, it will be interoperable from China Mobile, China Telecom, and in Europe, it will be aligned and also calling the same API, but actually what you will be accessing in runtime, it will be from BT, from Vodafone, in England, or from Orange and Dutch Telecom, for example, things like that. So this is not talking about infrastructure as a service. This is actually talking about orchestrating different capabilities coming from the service provider, communication service providers, or infrastructure service providers in combination. And the application developers don't need to, get into the burden of figuring out, would it be Google, would it be Amazon, or would it be, BT, or would it be Vodafone? And this is what is behind this.
Yeah, I mean, I totally understand. And my belief is like for the future of the AI will be the telco will host all the AI services, or not all the AI services, host the necessary AI services. That is for local business or local localizations of the services. Because the telco, each country has its own like couple or few like telco companies, and then the telco company has all the radio network and basically knowing the locals, right, and the languages and everything. The information should be also hosted in the local region, which is like for the telco.
Right.
companies.
Yes, exactly.
I think the the suffering from my side is for as a general developers, like how I can, um, the one big thing about the edge economy or this whole edge business is the scaling problem, right? Not get enough money back when you develop something for only like a very small market.
Right.
The total investment in terms of the time and also the infrastructure is the bottleneck. And also, hopefully with the AI, that the development time will be super fast. That's what other people here showcased, all the cool tools that you can quickly bring up applications. But I think the infrastructure is a missing part for what we are talking about, the use cases we're talking about. And that's why I think the telco company should take the responsibility of the infrastructure for this kind of local small businesses. Instead of like you guys providing like good big models, I think that's not the expertise of the telco, but you will never compete with Google and Microsoft. And I think it's better to have a clearly standpoint at the beginning, telling, let's say, you are building an edge developer community, open source, and then you provide the infrastructure as simple like Raspberry Pi or some other small servers for free, and then the end devices users will be easily connecting to your network without worry about setting up their own Wi-Fi network or competition resources. And those kind of things, I think, will be very valuable for this edge service community. Yeah.
Yeah,
Those
I
in
have-
general development.
I have
Thank
to
you so
be
much.
short. Yeah, thank you, because 9 minutes over. I know this is a very important topics that I encourage the China Mobile team join our LARC or Slack channel, so we can continue this very interactive and important discussion. Yeah, I think, what's your name again? She really listen and have this great communication of the great minds. Yeah, let's continue at the Lark and Slack channel. Yeah.
Sujata Taiburwala from ByteDance will discuss using AI to scale massive global applications.
Hello, good afternoon, everyone. I know it's been a long day, so hopefully, and also we are running behind, so hopefully I will bring us back in time because I was anyway not planning to talk for long. And hopefully my session will wake you up. So before I begin, I am Sujata Tibrewala, I work in ByteDance Open Source Program Office with Tina. I work on community development and advocacy for 50 plus ByteDance open source projects. I am at the Linux Foundation Edge Governing Board, and before this, I was at Intel, working on community and as a director at Open Source Alliance within Intel Open Ecosystem, running strategy for in all of Intel open source projects, which was quite a few, more than 1,200. So fun fact, I started my career as a network software engineer, and I was talking to one of the attendees back in Indian Institute of Science, Bangalore, which is one of the top institutes of India. I was working on computer vision much before AI was, a thing. And you'll be surprised to know there were no jobs at that time in computer vision because it was just a research thing. And that is what made me move to networking software, and it'll be a long story. But then I'm here back with ByteDance Open Source and talking about AI. When I'm not working, I am running. I'm a long distance runner. I have completed 7 full marathons, and yeah, thank you. I'm a loyal SF runner. No prizes for guessing because we stay in Bay Area and SF marathon is beautiful. And the reason why I'm able to do it because I am an ardent yogi for like now 15 years, I think, and I'm also an artist. So with that, let us reset and rewind. So I'll give you guys 2 minutes of meditation. I know everybody's sleeping, so this is a very difficult session. So why don't we close our eyes and take a deep breath. A breath in, a breath out, a deep breath in, a breath out, a breath in, a breath out. And now you can open your eyes. So, why did I do this? Breath is the mechanism which is used for meditation. I don't know if anybody has used a meditation app before. No, only one hand. Can everybody raise their hands? Okay, that's a test. Everybody can raise their hand. Now, who has used a meditation app before? One person still. Okay, I encourage you to find a meditation app and use it, please. All of us are working in tech, and I'm about to also share some bad news, so you will need meditation for that. So, we have been all talking about AI. I'm sure you have heard some versions of this. I'll let you read. By the way, this QR code is my link tree. You will get my LinkedIn connection there, and all the data there that I have put here is from articles that is linked on that link tree as well. So, what IMF says is it will affect 40% of jobs world over. It doesn't mean that it will take over our jobs, but the nature of jobs will change. Okay, so we have to be prepared. And well, we all know about success of ChatGPT, and why? Because it has saved US companies between $50,000 to $75,000 in 2023, or 24% savings, right? And this is why we are all talking about AI today, right? But then there are several problems with AI. Can we list a few problems? AI models are not inclusive. Can I have like somebody in the audience give an example of why AI models are not inclusive, or an example of that?
I mean, example of why?
Why AI models are not inclusive?
Because it has all the data.
Sorry?
It has all the data about all the opinions. Like some might be biased, some might not be biased.
So opinions that the AI models are based on are biased,
Yes.
right? Okay. Any other examples?
Access to content
Access to content.
might be biased as well.
Access to content might be biased as well. Yes, data is the basically the key problem here. The data that most models have are not unbiased. So AI inherently inherits the biases that the data has, right? And the second problem that I care about, and hopefully everybody in this room cares about, is the the environmental impact of AI. The next two bullets, we were talking about open AI, right? Data centers today, some of the data centers today consume more electricity than the entire cities in the world. Is this news to anyone here in the room?
No.
Probably not. You would have to be living under a rock if you were not aware of that, right? So, I mean, but then putting the last sentence was like what just blew me off. Training a single large language model can emit as much carbon footprint as 5 cars in their lifetime. So, yeah, we solve one problem and we create another set of problems. And then, but then what is AI doing? What is the type of problems AI is solving? What's the most popular thing the AI is doing? What, like,
Making people look good,
sorry?
like photos, making people.
Making photos, making art, making videos,
Content production.
writing content, writing poetry. But yes.
I found the most useful thing it does is summarize.
Sorry?
Summarize.
Summarizes,
Like a
yeah.
long contract or a long article, ask it for the key points or ask it to find something in the contract that might be objectionable.
Yeah, right. So summarizing contracts and long articles that humans might find difficult and tedious to read.
Tedious, not difficult, but tedious.
Yeah. In some cases also difficult, like, if you're talking about legal contracts, they don't write in English, in my opinion.
Okay, well, that's possible.
Sorry?
I said that is possible.
Yeah. So anyway, I'm sure you would have seen this image, right? Again, you would have to be living under a rock, right? So I disclosed earlier, I'm an artist, right? So art is something I like to create. I'm sure, like, all of us here do something creative outside, like, or like, listen to poetry, write poetry, listen to books, or write, like, something, right? This is not what we want AI to do. We want humans should be doing that. What should AI do? AI should do the problems that humans are facing, like summarizing articles and tedious data that we can't ourselves. So why is there a disconnect? Now, this is a statement by Sam Altman. I don't know if any of you have come across this statement. So Sam Altman was in India last year, and he was asked a question that if a startup had 10 million and 10 developers, something like that, could they do something what OpenAI did? And this is what Sam said. He said that is not possible. Yes?
It is not possible, but you can try.
But you can try, yeah. So actually that challenge was taken up by quite a few Indian companies. I think Tech Mahindra was one of them. So basically this is the challenge I am giving to the audience here. Because I see there are a lot of startups, I see there are AI developers. So this room has the capacity to basically challenge what Sam Altman said, and especially because we are all here because we care about open source, right? So today I'm going to talk about a few open source projects that ByteDance is working on. Before, my colleague Ben Hui, she gave a really good lay of the land of AI algorithms, like in the edge, and then I had my colleague earlier talk about I forgot the name of the project now. Auto SE, right? Auto SE, yeah. So I'll talk about some more of them. Now, we were talking about, so this is like, how open source AI is blowing up. Hugging Face has more than 700K models. Llama X, which has been open sourced by Meta, of course, has a flourishing developer community. But then what is a limiting factor is the data that is available for these open source models, which we earlier talked about, right? So the bias in data, inclusivity of these models, that's the thing. So open data, but then work is going on in different organizations, open data libraries in US, European Union. We are working on that. I am working with NIST, the government body as well. So hopefully we'll solve that problem soon. Now, there's one tool which is available to developers. Now, one of the key, everybody knows that large language models, they need big servers and, immense infrastructure, right? So one of the things that can level the playing field is cloud native AI. How many of you agree in the room?
Can you expand on what you mean by cloud?
Yes, so I will expand on it a little bit later. So what is cloud basically? So before that, what is the definition of cloud? Cloud is basically a set of servers and data, storage, compute, that is available to any user which wants to access it, right? And there's a lot of cloud service providers earlier. China Mobile was there earlier. And then we have the Google and AWS and everything, right? And those servers are available cheaply. And many open source projects like Akreno also has cloud servers available. And why has cloud taken off? Because the compute and storage can be scaled up and scaled down very easily. So what if we could run these large language models, the training models, on the cloud servers instead of having to have a monolithic, huge GPU and CPU compute resources? That's what I mean by running AI on cloud native. Does that make sense? Yeah.
I mean, like, it's just cloud, like, what is
Sorry?
it? I mean, is it not just cloud, like running?
Yeah, it is cloud, but then.
What is the native part? That's all I was trying.
Oh, what is the native part? I mean, that you don't. Yeah.
Microphone to you. Just leave it here. I'll take it.
Oh, you have? Okay.
Okay.
So this is the architecture that cloud native from I took this from the Kubernetes website. Kubernetes is actually working on this. Yes.
Sujeta, can I ask a question before you continue?
Yes, please.
Have you thought much about the underlying root cause for why Sam Altman would make that quotation?
Yeah, I think it was more about the infrastructure, the access to infrastructure.
Right. The problem is the GPU. Underneath that, the problem is the need for matrix multiply.
Sorry?
Matrix multiply. So many, so fast,
yes.
such a massive, voluminous amount of matrix multiply. So my question to you would be, in your work on finding this alternative, where is your R&D on an alternative way to train that does not require gradient descent, backpropagation, or they're kind of the same. But if that problem could be solved as a way to train on CPUs, that this whole argument would go away.
Yeah, so
that's the problem, is people can't afford a startup that goes off and funds themselves with what, let's just say 100 billion. Half of that immediately, according to Jensen's CEO math, half of that is immediately paid to NVIDIA.
And they might not even get their GPUs for several months. That's the root cause. That's why you can't compete.
Yeah, so basically, so the approach that OpenAI has taken, or like, most of the large language models today are taken, that is the reason why, we can do it on, we can scale it on smaller infrastructure, right? Or like, it requires GPUs. But then
You can always scale it down, but you can't train fast enough. You can't do trial and error training. You can't have different attempts at a model being trained concurrently because you don't have enough GPUs or CPUs.
Yeah, so there is always an alternate way.
Yeah, but it would
Is
just
also, and that is the problem we in the open source need to solve.
Yeah. Right. So that's back to my original question.
Yeah.
There should be a component in this open source effort, an R&D component.
Okay. That is
Find the alternative.
Mhm.
Now, of course, that takes some PhD math level type people, but that's what's needed.
Yeah.
Because
So
clearly, if you look at evolution, if you look at the human brain, we have nowhere near the energy capacity to support a level of numerical accuracy to do something like matrix multiply or gradient descent. We're running 40 watts in a human brain, and these, NVIDIA's latest rack of what is it, GB200, that's over a megawatt.
yes, so
There's something wrong with that.
no, so I would argue, so that will go into neurobiology, like, but like,
No, it doesn't. It just that takes some creative software engineering. But I think
no, so
people,
our software
I would like to see people working on that, because if they could solve that problem or even make some promising headway, then the need for these, what is it? I don't know what the price of a GPU, the latest, even an H100, $30-some thousand or $70-some thousand a piece. That's an obstacle, not just here in the US, but around the world.
Yeah, no, I agree. So I would argue human brain has more power than, like, in some cases.
Not
saying not everything, like
not
compute.
not compute processing.
Not so human brain does not function like, in a logical steps.
No, it does not.
It does not. It does
vastly
not.
parallel.
It does a lot of things in a fraction of a second, which if you break it down to logical steps, it will take a lot of steps, but human brain does it anyway, right?
Yeah.
So I can recognize you because I know your face, but it took so many years to teach the computer to recognize your face. When I was working on computer vision, that was a difficult problem to solve, but then it was solved, right? So anyway, that's a yeah, that's a great point. So yes, so this is the cloud native infrastructure. So sitting on the hardware, the CPUs, GPUs, you have those cloud service providers, and then you have the platforms like, Kubernetes, Azure, etc. And then on the top of that, your ML or AI algorithms can run, and then you have the workloads, your use cases that would be using all of this infrastructure. Now, how is ByteDance placed to solve these problems, and where do our open source projects come from? So this is a data that I took from this article so this is also a little bit dated because it's a 2022 article. So ByteDance products, over 2.5 billion users are using every day. And the products, of course, TikTok, everybody knows. CapCut, how many have experienced CapCut? Okay, younger generation has. Lark, we are using Lark today. Douyin is TikTok equivalent in China. So most of the open source projects, how they come, they start as experimental products within the company. And what ByteDance has something called shared service platform. So every business unit, every function will be using the same product, same technology. In many other companies, for example, I was at Intel, this was not the case. Every business unit functioned as a independent company of their own, but that is not the case here. So then what happens is whatever application or product we are talking about, uh, they're tested very well before they are, put out into the open source or into the market. So that hardens them very well, and also it's an efficient way of development. So one of the products that came out of this is Babbitt Multimedia Framework. So it is a cross-platform multimedia video processing framework where AI inference or any algorithm can be hooked into it. It also supports Python, which is one of the most used languages. So here there is a demo. On the left-hand side is a black and white image, and on the right-hand side, so you can't see that it is a high resolution 4K image because it's a very small, GIF here. But imagine that you had your parents' wedding video, which is in low resolution, black and white, and that could be upsampled using AI and created into a high fidelity 4K color video, right? Or any other memory for that matter. Or I mean, it could have multiple other applications. Any other applications you could think of? Something like this? Movies, yeah, old movies, definitely. Old classics. Some of them also get destroyed because archival technologies was not that, good on those times. Record keeping, old photographs from 1800s, which has historical interest in the museums. Yes.
Probably be like forensics and crime fighting. I could see it's like a low resolution CCTV camera or something.
Yeah, forensic. Oh wow, that's also another good example. Any others you can think of? Okay, another good demo of that is this. So while in live stream, AI generated images can be interleaved over a live video feed. So for example, a reporter is reporting on some event that happened on some forests in China for an endangered species that we all know, panda, right? But then to make the audience care about the panda or put a little bit more of human touch into it, you could interleave it with the image of panda which AI had generated. So make the news more human friendly. Any example? Any other example you could think of? So this example actually is where BMF libraries were integrated with one of the Hugging Face library. And my one of my colleagues who is unfortunately no longer with ByteDance, he's here, but not with ByteDance. He had written an article, and that article is linked here. So integrating BMF with Hugging Face. Recommendation system. How many of you are social media addicts? One hand. I'm guilty of it. I had to put time limit on my social media. And why is that? Because the recommendation algorithms are so good. They get personalized, right? So we have actually open sourced our recommendation algorithm. It's called monolith. So you could go to that GitHub and look at that algorithm and see what you could do with that. Again, what could be done with the recommendation algorithm if you had access to it? Sorry? Advertising? Okay.
What exactly does it do? I'm in.
Oh, okay. So that's a really good question. So, do you watch Netflix? Yes. So, Netflix is a really good example. So, if you watch one movie, Netflix will recommend you other movies based on what you have watched. So, that is content based recommendation. The collaborative recommendation is like people like you. So, you watched a certain type of movies. Other people who watch those type of movies, they like to watch that. So like in Amazon, if you bought something, they'll say, oh, you bought something, somebody who bought that also bought this. So that is collaborative recommendation. Okay, so this is one of the tools that makes the training algorithm run on cloud without any code changes. So this is VE Scale. Again, the GitHub link is there on that link tree. It's an open source project. So you could take any algorithm, and what VScale does it abstracts that algorithm on one device, and the user doesn't need to worry about it, but then it will parallelize it on multiple devices and it'll run on it. So it makes it easy to debug. It automatically parallelizes it. The model design and parallelism they're separated, so it's easy to debug. In the interest of time, I'll not go into details. This is another tool that is available to you open source. So this makes any kind of data warehouse run on cloud. So data warehouse or OLAP engines are another example of things like that needs huge storage. So what Biconity does is it separates compute and storage, and you can run a huge data warehouse even on S3, some Amazon servers, a low cost server. So that again helps you in running your AI algorithms on cloud native. And this is the graph performance of Biconity versus other algorithms. Now this is some of the other AI algorithms. This is Magic Boost. So based on a reference image and a motion sequence, a video image can be generated. This is a story create. So based on text, videos and images can be generated. Again, this is an open source project also. And here is the GitHub link of 50 plus open source projects that we have. Some of the open source projects that I talked about, they are not under here. They have their own separate GitHub link, but all of that is there in the link tree. And if you are interested in any of these open source projects, find me. We have a program called ByteDance Innovator Program, and I know we're running out of time, so I'll just briefly talk about it. It's a recognition program for developers outside. I heard a lot of good ideas. We want to hear more about those ideas. Once you are into the program, you get access to our project teams. They'll answer questions. They'll help you in your projects. Will help you in you becoming successful in whatever work you're doing on case-to-case basis. We also have stipends available, and of course, we like to showcase your work. It's like it's like open source. It's a meritocracy. How much work you put in, that much you get back. So if you put in the work, if you are far along in your project, we would like to showcase you in our events, in our conferences, on our webinars. We keep doing those things. So yeah, would love to hear about you from that. So hopefully today I got you inspired, and I know before me you heard about a lot of great AI open source projects and also about ByteDance open source projects. So hope you'll collaborate with all of them and would work with us in the innovative program. Thank you.
Straight time every other Thursday evening to answer any questions regarding to the ByteDance open source.
Lastly, Dr. Fu Li from Clussies Inc. will close the day with an in-depth talk on AI networking innovations.
Just to clarify, this is not the last one. Yeah, after that we have another 15 minutes from NTT. Right. Natalie? So Leo, is that you are the presenter or? Oh,
You see my screen?
yeah, are you going to turn on the camera?
Oh, sure. No problem. Yeah.
Are you talking? Are you muted?
Yes. Should we start right now?
Yes, go ahead.
Okay. Hello, everyone. Today I will discuss some our technology advancement about the AI networking, especially on the RDMA and also TCP/IP. Of course, today we will also discuss the difference between the scale up or scale out and scale up networking. So first of all, let's talk about why people care about the AI networking today. Actually, the reason is, of course, the obvious reason that we just said that the computing power has increased like 1,000 times in the past 8 years. But if we look in detail about what is really changing in the past 8 years, is not because of one single chip they increased for like 1,000 times. Of course, no people can do that. Actually, the reason that the AI computing power has increased 1,000 times because the definition of the AI computing from the single card to a rack of computer. Like I think in 8 years, when people talk about the GPU, talk about like AI computing, always refer to a card, like standard PCIe card. But about like 4 or 5 years ago, when people introduced the GPU, they said, okay, the GPU actually is made of like 8 chips, like a single module with 8 GPU inside. But until last year, the Jason Huang said, no, the supercomputer actually is a rack. The whole rack is a GPU. That's why he said the GPU is not big enough. They need a more bigger GPU. actually behind this, the reason why the definition of the GPU computing changed is because of interconnections across the GPU that changed. So that's why actually the reason the computing power of the GPU changed for like 1,000 times is that the computing and the link. So when we go back to see what the link it is, the link they compose like two parts. I mean, in the very beginning, when we talk about networking, we talk about the link. We always refer to the TCP/IP. You know, TCP/IP is very good. They designed for the connection for the different servers, but in the AI computing, because of TCP/IP, they have some like drawbacks because they designed for the wide range computing. People come up with like RDMA. The RDMA said, okay, let's go bypass the kernel. Because most of the TCP/IP, because of the kernel management, the speed and the latency is high, and speed is not that good. So they come up with the RDMA technology. The RDMA technology is very simple and very straightforward. They just bypass the kernel. You know, when kernel is a problem, then we just get rid of the kernel. We just bypass kernel. We can send the data from the NIC directly to the application. The application can manage the data flow efficiently. That's why RDMA is one of the is one of the best protocol for the AI computing in the past several years. And in the open source community said, okay, because RDMA is it's prepared to the NVIDIA. So why let's do like RDMA over the Ethernet? So we call it ROCking. And nowadays it's called the Ultra Ethernet. They want to use the RDMA technology inside the Ethernet. But this is for the protocol. When we go to see the link, I mean, not just the protocol to change from TCP/IP to the protocol like RDMA or like ROCking or UEC, but actually another fundamental change is about the link. The link, when we talk about TCP/IP, we normally do not refer what kind of link it is, because people by default think about the link is MAC, like Ethernet. But NVIDIA said that, okay, when we want to make a super fast AI networking, we do not need only to change the protocol for the networking layer, but we also to update the link. Then they call it the NVLink, always call it the future link. NVLink is based on the PCIe, and then they promote a very simple protocol on top of the link. Okay, I will talk about that later. And accordingly, for the open source and the community said, okay, NVLink, is NVLink is belong to NVIDIA. Why we do not, why not we us together, we can get like a CXL, like Computing Express Link to do that. I mean, even today, as this year, people think the CXL is still too heavy in the AI networking. Then they introduced called the AI link, Ultra Accelerator, the accelerator link. So our vision that in the change in the both protocol and also the link, our vision that we want to build up a high performance and low latency scale up cluster. So what is the scale up networking? This is about the word. Every people doing the AI infrastructure, they're talking about that. But actually in the old days, there is nothing called scale up networking. When in the past, we divided the connection in the computer system, like a CPU to CPU, CPU to device, and device to device. And of course, the device to device across some nodes, and node to node, and cloud to cloud. So for these 6 different connections, people have different technology. They develop like Intel has the UPI, and also AMD HT, and also ARM like CCIX. And for the CPU to device, normally people use like PCIe as a standard. And the device to device, they call it the PCIe P2P. And some like a TCP/IP, as we mentioned, and also RDMA. So when NVIDIA revolutionized this area, they introduced like an NVLink for, originally they introduced the NVLink is for the device to device connection inside the box. We call it because that's why they call it the bus protocol. And of course, they extended that into the device to device across the different board. And recently, they introduced the NVLink C2C. They want to cover the CPU to the device. So what is the scale up? So in the old days, we call that the out of a box connection, like a load to load connection, we call it scale out domain. So scale out means we add more server and then we have more performance. That's the very basic and also the principle for the scale out domain. So actually, when we talk about the scale up domain in the computing architecture, we always talk about the CPU performance. We talk about that CPU to CPU, like a dual way, like a quadral way, and even like an octal way. Like you put 2 CPU together, put 4 CPU together, and even for 8 CPU together. But in old days, actually, when we talk about the CPU and the GPU to like a NIC, we call heterogeneous computing domain. So you can see that in the old days, scale-up networking actually is for homogeneous computing inside the CPU or between the CPU or among the CPUs. So NVIDIA just used this definition. They said, okay, so NVLink, why is it called NVLink? It's a scale-up network because originally NVLink is only defined, only used for GPU to GPU connection. So they think it's homogeneous and also it's a computing unit. So that's why it's called a scale up. So actually you can think about that. We can think about that right now that the scale up networking is for the homogeneous computing across the GPUs. So that's a lot of people that are doing right now. And that's why we come up with this definition. So why the big model, like a large language model, they need to scale up networking? As in today's talk, people talk about the PP, PD, DP, PP, and also like TP. You know, in different parallelism algorithm, we always need to scatter the data across different GPU, and then we do the computing. So in nature, when you distribute the data across the GPUs, you need communication. And the communication in nature is synchronized, they're not parallel, because you have to send the data 1 byte by 1 byte. Of course, use like a PP algorithm, you can let the networking to parallelize by itself, but still between the one GPU to another GPU is still serialized. So that's why, due to this data movement, the scaling of the computing across the GPU is very sensitive to the latency and also the throughput. That's why we need a scale-up networking. But actually, the key for the scale-up is dropping the leak. Why we say that? So originally, when we want to move the data from one GPU to another GPU, we need to use a PCI switch and also a NIC, like a network adapter. The data will move from the GPU through the PCI switch to the NIC, and the NIC send the data to another NIC, and then the NIC send the data to the GPU. So of course, you will have a lot of technology to optimize this data transfer. So, but in summary, we need a CPU, we need a PCI switch and with a NIC to scale out networking. But for the scale up networking, if you look very closely into the the infrastructure for the GPU like clusters, you can see the data movement is from one GPU to the NVLink switch, and then NVLink switch to another GPU. So you can see actually the NVLink switch has the same position as a PCIe switch in the traditional way, like in the traditional scale out way. The only thing we drop is the NIC. Or you can think about the NIC inside the GPU. But in either way, the network adapter, it doesn't matter, it's a Rocky network adapter or it's like RDMA, it's IB network or the traditional NIC, they just dropped. So in our definition, actually, when we talk about the scale up and the scale out, the difference is whether we use NIC or not. That is what we have in our definition. Actually, LF Edge leads the trends. 2 years ago, I think we did something, but we do call it scale up. We call it scale in. The reason because the scale up network, they only suitable for the small clusters. And I think in the white paper we said that the networking shift, the networking innovation, they shift from the port density. The port density is one of the big key value for the networking in the old days because they want to scale up. scale out means you need more port, right? So the port density is very important. But actually in the recently, especially for the AI computing, like a rack scale computing, the scaling is not an issue because you cannot put 1,000 computers inside one rack. Instead, you can only put like 32 servers, for maximum like 64 servers inside one rack. So when port density is not the critical issue or critical point we need to consider, then what we need to consider is the link type and also the protocol on the link type to increase that. So Aquarino, actually, we do share the vision like 2 years ago. So, but we call it scale in. Scale up is better. It's really a good word compared to the scale in. So let's go back to the technology. Actually, the technology is correct. How to extending the PCIe transportation. So as I said, in the scale out and the scale in, so doesn't matter what kind of the link it is, actually they're all based on the PCIe. Then the real factor, the difference between these two kind of technology is whether you have an adapter that will have a network adapter. So when we talk about the PCIe transaction, we talk about PCIe transportation. Sometimes we always need a translator, like a PCIe to network translator to translate the data from the CPU to the networking. But why just connect them together? Just connect the PCIe physical layer, like 30s to 30s through a networking. So this is a very similar technology compared to the NVLink. Actually, NVLink is doing exactly the same. So our answer to the difference between the scale out and the scale up, actually, we think they're the same. The only thing difference is that the connection model, the change from you need a protocol translator from the PCIe protocol to the Ethernet protocol by a network adapter, or right now you just connect them together. So we call it PCIe network. Of course, you can say 6L network or like an NVLink network, or in the future maybe like a UA-link network, but they're the same. So let's revisit why we can do that and why people build up NVLink built up the protocol based on PCIe, UA-link based up the network based on the PCIe, and also the 6L based on the link based on the PCIe as well. The reason that people want to drop the Ethernet is because in the future, in the old days, because the Ethernet they designed like a layer by layer. In the hardware layer, they only standardize the DMA and the MAC. So that said, okay, the MAC serve like a data transfer, but they do not control whether the data reach the other MAC, like reach the destination. They just say, hey, I get the data from the upper layer, like the CPU, like the application, and then we drop the data into my port. That's it. So whether the data transfer from my Mac to another Mac or to the destination Mac, I don't care. Who cares? The protocol cares. Who runs the protocol? Actually, it's the CPU. It's the application, like a socket, like a TCP IP or UDP. Then in UDP and the TCP, you have a lot of mechanisms to control the data reach the destination. So actually, people know that in like 30 years ago and 40 years ago. So that's why they have two protocols. One protocol is UDP, say, hey, I don't care. If you want to care about whether the data reach the destination, you just need to program control by your application. The TCP said, oh, no, that's too risky. I will do the control mechanism by myself. So TCP introduced a shift window, like a window to guarantee the data can reach the destination. However, you see, actually all the innovations right now based on the Ethernet, they choose different ways. One said, okay, I just treat the Ethernet as a link. We just treat we do our flow control in our application. So I think Tesla, they introduced like a very efficient protocol based on the UDP to do this way. So that's okay. I only use UDP as adapter to send the data. I do the control by myself. And another way, like IWAP, I use a TCP to do that. Either way, that's only the difference between the innovation in the Ethernet that you have to control the flow by by the software. And all the software is runs in the CPU. So that's why they consumed a lot of the CPU cores in the Ethernet protocol. And for the PCIe, they're different. The PCIe, they introduce a logic layer. So this logic layer actually have a very strong echo mechanism. That's that whenever I send a data from my PCIe service to another PCIe service, I need to guarantee you reach it. In how can I say? When you do this, of course, the data transfer is very reliable. Very reliable. You can always receive. But the problem that you need to echo every time. You need to echo say, hey, when I send one data, I say, hey, do you receive the data? When I check you receive the data, I send the next data. So the latency actually is a little bit longer, but because it's doing by the hardware, you cannot notice that. And because of the hardware to guarantee the data can reach to the destination, so the software is very simple. Normally people ask me that, what is the driver for the PCIe? So actually, this is a very, very, very good question. So when we think about the kernel, what is really the driver for the PCIe? It's not the PCIe driver by the different windows, okay? Actually, the PCIe driver is the memory address. It's a memory addressing. So like a star. Actually, the only driver in the PCIe system is we call the read L, like read the W, like a read, like a star to fetch the data. So in other words, that in the PCIe technology, the CPU only see the device as a memory. They do not care about how you send the data. They only care about I can fetch a data from the controller. That's it. So you can see the PCIe and the Ethernet, they are different by design. The design is just how to control the data flow. So right now, some people think about that Ethernet with some like very, how can I say, very clever flow control is a good way. And some people said, oh, we just dropped the PCIe. We just dropped the Ethernet protocol. We just use our PCIe. We use memory addressing. So actually, that's why people discuss the difference between the scale up and the scale out. They always call, they said, oh, load and store. They said, in the Ethernet, you use the send and the receive. In the PCIe or in the N1 link, you use load and store. Actually, in our idea, load and store and send and receive, actually, that's the same. The only difference that who will do that is the CPU do that or the controller, hardware controller doing that. So why in the CUDA, like GPU computing, like AI computing, we prefer the PCIe, not the Ethernet? The reason, as I said, because in the Ethernet protocol, the CPU need to do a lot of work. If you connect the Ethernet directly to the GPU, then the GPU core need to do that. So, if we choose the Mac, like choose the Ethernet protocol to do the GPU transfer, data transfer, you will see a lot of the CUDA cores, a lot of like the GPU cores, they're doing the data processing, just like a CPU, Then you will see the efficiency for the GPU cores who do the computing actually is much fewer than the PCIe one. Because PCIe, the GPU, they do not need to actually do not even need to care about the data transfer. They just say, hey, the PCIe controller give you the data. Then the controller give you the data. That's it. The only thing you need to see is you need to wait for the data achieved or arrive, or you just go to do another work and then go back. Then that's we summarize that. Because of the lightweight driver layer in the PCIe, that's why people prefer the PCIe in the CUDA, like in the GPU cluster, like also all called scale out. Then, so we talk about the link in the hardware layer, then we talk about like the protocol in the software layer. In the software layer, besides the TCP/IP, we always think about to the application, what exactly the application want. Do the application need to know the TCP/IP, need to know the socket, need to know the send and receive? Actually, no. The application only want to know I want to receive the data from some memory address. That's I said. In the scale out and scale up networking architecture, we need to solve one problem. We need to let the application to to know, and we want to let the application to see the data just like the memory addressing. We do not need the application to know how the data arrived. So that's why we develop a software to hide all the data movement based on this kind of philosophy. And also, we introduce I will talk about later, our software layer. So actually this is what we are doing in the originally, this is the HPC. HPC doing that. When we do the HPC, we hide all the data movement is MPI. In MPI, you do not need to know where is the data. You only need to see, I want the data, and I want data to, I want the data and the wait, or I want the data to not wait. That's it. So in the HPC, actually, they do that before. So large language model is in between the HPC and the cloud native or the storage native, the protocol. So also, as I said, in the mainstream hardware, so you need to think about whether we choose the Ethernet or choose the RDMA. That's it. So we promote our protocol. As I said, we talk about the protocol. We talk about the protocol in the software, and also we talk about the protocol in the hardware. So if we put it together, so we think about that RDMA over the CXL is one of the, I think it's the only way right now, or maybe in the future to have another alternative. But right now, it's a very good candidate to replace the RDMA and NVLink. The reason we compare with the RDMA from the original IB and also Rocky from the NIC. As I said, with the RDMA over CXL technology or like PCIe technology, you do not need the NIC. You do not need the adapter. That's a very key difference between the scale out and the scale up. And also, you only introduce a very thin driver layer. You do not need to take the TCP/IP protocol into the software or into the hardware. So the key feature with the RDMA over CXL that we based on the CXL technology. Actually, we based on the PCIe technology. It offers very low cost and high performance. And it's feature oriented because in the future, we think the CXL will replace the PCIe very soon. So in the data flow, compared to the RDMA data transportation that I said, the data will move from the kernel space to the hardware and then go to another hardware. In the CXL data transfer, we just integrate the DMA from the NIC into the CXL switch because each PCIe have a DMA assigned with it. So that is what I said, scale up. So you need to drop the NIC. And we do not need to use the data copy. We only need data copy once, actually twice, okay, because through the switch. And then we do not need to take about the interrupts because it's a memory connection. So you can copy to the memory directly. And also the CPU do not need to get involved. So combining the characteristics of IB and the PCIe technology, very similar to the NVLink technology, the CXL with RDMA will provide a very low latency, high throughput, active and passive data transfer. The active means you need to wait. The passive means you do not need to wait. You just you can go back. So with the technology, with the CXL, so what is the new part is doing? Actually, new part is we have 3 layers. So the first layer is the CXL controller. We use the traditional one or like standard one. You can use like a PCIe with a DMA. And then the new part core will control or management all the PCIe CXL controller, and then to provide a unified memory address space to the LUPA lib. LUPA lib, they call the LUPA IB. They will provide like IB device for people to use the IB, or you can use the user space UIO to program it directly. So we call it a unified protocol for the networking. So this is our reference design with FPGA to mimic the to provide the ASIC to provide the protocol, and then we use RDMA to link the different nodes. So similar to the NVLink and also the app technology, we can have like a cluster, like we can put in the rack, we have like 16 servers and then connect with 2 switches. And then we can provide like all-in-one server for the storage scenario. And for the GPU, because GPU need more bandwidth, then you can have more. You can stack the switch. You have like 4, maybe like 8, if it depends on the GPU. Then you can put all the GPU like a slice into the cluster. So just like the rack scale. So for this reference design, there is no IB card needed, and also no Rocky card needed. But still, you have RDMA across the class, the rack, and all the server they have a global memory addressing across the GPU and also CPU. So the CPU, GPUs have the same memory addressing. The only thing, the only difference is that you need to receive the data until to wait or not await until the data arrives. So that we call the passive and active data transfer. And then we only need the network adapter when you want to connect to the clients, like you want to provide a cloud service, a cloud native service, then you need a NIC. Otherwise, you do not need a NIC. We move the BGFS, one of the HPC storage, on this system. You can see in the BGFS, actually, you see no difference compared to the IB device because there's a similar IB. You can see IP address. This IP address is only for labeling. Actually, they have low stack. It's only labeling. Yeah. Then you can see they can do the transportation very well, and you can run the system very well. And especially when you use RDMA protocol with IP labeling, the performance is very good compared to use the TCP. And so more on future. So what we are doing. So when we join the LFH and also Arduino, we always think about the evolution of the networking. So as we said, in nowadays, for the massive cloud, it's only for several big companies like like ByteDance and also like Amazon. I mean, very few people that can have the ability and also have the money, to build up a massive cloud. Most of the people they only have a small cloud, especially for like only one rack or maybe like 10 racks. So actually, for the networking architecture, we need to think about how to make the connection inside one rack more efficient. I mean, at the most 10 racks, how to scale up in that kind of scenario. So maybe, today we said PCIe is a good Mac. And some people say like Ethernet is a good Mac. Or maybe in the future, like a UA link or CXL link, they will do their own Mac. But it doesn't matter. It doesn't matter what kind of Mac it is. We need to think about how we can put all of them together. And then in the future, for the UEC protocol, like TCP/IP and RDMA, where is our position? So our position that we want to use the standardized PCIe Mac, like a PCIe controller with a DMA. And then we have adapter to the UEC or RDMA or like a TCP/IP to bring them together and then provide a very efficient and low latency, high performance, and actually most important is a very low cost connection solution to the connection inside a rack. That is our vision and also our thinking on the future, like UEC and UA link. So yeah, that's it. Thanks, everybody. Yeah.
Only one question because of time. You have the microphone there?
Yeah, the question is about TCP/IP. One of the assumptions of TCP/IP is that it assumes that packets are going to get lost. Is there that same assumption with your direction as well?
Yes, actually, that's a very good question. Yes, in the TCP/IP, in the initially, like 30 years ago, when we invented the TCP/IP protocol, right? The genius, they think about because they know that the packet will lost in the wide range networking, but in the short distance, especially in the inside the one rack, the chance for the packet loss is very low. So either you have another flow control, like the Tesla, they're doing that, then you can make it better. Another way that you use the PCIe, that in the PCIe, each packet it cannot be lost. If it lost, the PCIe will retransmit the data until it reached. So in the TCP/IP scenario, if you check each data to get lost or not lost, is very costly because the chance is high, right? But in the short distance, because chance is really low, so even you check is lost, because always you see that it's not lost. So the cost is very, very, very light. So actually, that's the key point.
Yeah. No, that's what I wanted to clear up because I
So
had that conversation. I had that conversation actually with David Boggs, the guy that invented it, and that's what TCP/IP almost died right before the internet. 2 years before the internet, it died, right? And
yes,
brought back. All right, thank you so much.
Yeah. Actually, all the difference, I mean, in the PCIe and the Ethernet is how to do the flow control. Yeah, that's it. Yeah. Thank you.
We're excited to welcome Rintaro Harada from NTT, who will introduce us to the IO1 Global Forum.
Hi, I'm Rintaro Harada from NTT. So, can I start my presentation? Yes. Okay, so let me share my screen. Okay, so again, I'm Rintaro Harada from NTT and also from ION Global Forum. Today, I'll briefly introduce an overview of ION Global Forum and one of its POC activities for efficient AI analysis. So first of all, IOWN, or ION, stands for Innovative Optical and Wireless Network. It aims to create a sustainable society by utilizing optical wireless communications and photonics-electronics convergence to overcome the limit of current infrastructure. To achieve this ION concept, NTT, Intel, and Sony founded ION Global Forum in January 2020. The ION Global Forum is a non-profit organization achieving the ION as a novel communication infrastructure. Yeah? Sorry?
We cannot see the screen sharing anymore.
Oh, sorry. Sorry. Can I check? Can you see my screen?
Yes, I can.
Okay. Okay, sorry about that. Okay, so yeah, I'd like to start my presentation again. Yeah, so today I'll briefly introduce an overview of ION Global Forum and one of its POC activities for efficient AI analysis. So first of all, IOWN, or ION, stands for Innovative Optical and Wireless Network. It aims to create a sustainable society by utilizing optical wireless communications and photonics electronics convergence to overcome the limit of current infrastructure. To achieve this concept, NTT, Intel, and Sony founded ION Global Forum in January 2020. The ION Global Forum is a non-profit organization achieving the ION as a novel communication infrastructure by developing new technologies, frameworks, technical specifications, and reference architectures. As of May 2024, 142 organizations have already participated. Now, here is an overview of ION Global Forum. So we have three visions. The first one is to create a smarter world experienced in the daily lives of billions of people. And the second one is to popularize a next generation communication infrastructure to provide new services with sustainability by 2030. Sorry. And the last one is to achieve novel technologies for cutting-edge applications and explosive amount of data. Especially in technology aspect, we have three target performances in 2030, such as 1 over 100 in power consumption, 125 times in transmission capacity, and 1 over 200 in latency. To achieve the visions and target performances, ION Global Forum has been considering technical solutions. But just technical considerations are not enough to deploy ION-based services, so we've been considering use cases and applications. So this figure illustrates the overview of ION architecture and POC activities in the ION Global Forum. The bottom layer is called ION All Photonics Network, or APN. The APN provides end-to-end optical path for low latency, high capacity, and energy efficient communications. A network services layer and overlay solutions layer are on top of the APN. The ION Global Forum published 10 POC references. The POC reference is a document of POC which defines the use case, features, and expected benchmarks of its POC. Each POC team conducts a POC based on the POC reference and submit a POC report. Today, I will share the overview of CPS area management POC regarding remote real-time AI analysis in later pages. So this is an event of Linux Foundation, so I'll briefly share the relationship between Linux Foundation and ION Global Forum. ION Global Forum is collaborating with various projects in Linux Foundation, such as Cloud Native Computing Foundation, Open Programmable Infrastructure, LF Networking, and LFH for the future sustainable, smart, connected world. So this slide illustrates an example POC achieving remote real-time AI analysis. The assumed use case in this POC is smart city, where video data captured from cameras are collected at monitored area and analyzed at regional edge cloud. We built an environment assuming monitored area in Yokosuka and the regional edge cloud in Musashino, Japan. In the monitored area, a video server substituting for cameras in a smart city and a local aggregation node that collects video data are deployed. Aggregated video data are transferred to the regional edge cloud through the APN. In the regional edge cloud, our efficient hardware accelerated pipeline for AI analysis is executed with GPU resources. Also, OpenShift is utilized for easier lifecycle management of workloads with hardware-based data transfer feature. According to our evaluations with a single GPU, latency was reduced by up to 60% and power consumption was reduced by up to 40%. And we have an estimation of required resources and power consumption for accommodating 1,000 video streams, assuming the smart city. In the conventional on-premise deployment, about 5,000 watts are required in the monitored area. In the conventional implementation with AI at the cloud, the system is distributed into the monitored area and the regional edge cloud. The power consumption in the monitored area can be reduced, but the total power consumption increases. And the last one, in the case of ION-based implementation with AI at the cloud, the power consumption, both in the monitored area and the regional edge cloud, can be reduced, the total of which are less than 3,000 watts. Also, the space in the monitored area can be saved. As an advance from the POC, a possible idea for collaborated POC with Linux Foundation comes up this figure. Data stored in the monitored area can be efficiently analyzed with GPU resources in the regional edge cloud via Edge Lake and GPU direct storage. And more concrete use cases and system configurations are illustrated in the presentation from Fukano-san. So please also see his slide again. ION Global Forum picks out these 3 use cases as early adoption use cases, which are aimed to be deployed in 2025 through 2026. We consider applying ION technologies to broadcasting, generative AI, LLM, and financial industries. It's very important to widely collaborate inside and outside the ION Global Forum for deployment and widespread use of ION technologies. Lastly, let me announce an upcoming event named Futures in Taipei next month. This is a half-day conference to envision a photonics-driven future of next-generation communications and infrastructure technology, and how it will impact business strategy and innovation. You can join this event even if your organization doesn't participate in ION Global Forum. Yeah, that's all of my presentation. Thank you.
AI character is gonna say anything?
Is the AI character is gonna?
That wraps up day 1. Thank you all for your participation. We'll see you back here tomorrow for more exciting discussions and presentations.
Hooray. Okay, so tomorrow, I know, like, today we truly have the true discussion, and I like to see people fighting. That means we are really thinking, working together. Yeah. Okay. Yeah. Wilson, are you going to the cafeteria? Yeah, because I need to go to back to school night, and if people interested, go with Wilson for our just the dinner for employee, not super fancy, but we'll fed you well.
we can take them?
Yeah, you can take them. Yeah, just be quiet.
Oh, don't tell them.
Yeah, never mind. We have plenty of food.
Yeah.